Okay, so I think we can start. We don't have everybody here yet, but we have enough people. Hello, Ali.
Hey.
Did you drop again, right?
Yeah, I'm kicked out from Chrome for some reason.
Are you running on Chrome or in Firefox?
I'm running on Chrome because I need the live chat extension.
Okay, I'm afraid that happened during the event, but someone entered.
Yes.
Okay, great. Hello. Hello, Gidlin. Hello, Donnie.
Hello, good evening.
Hello.
Good morning, good afternoon, or good night for some of you.
Good afternoon.
We have enough people here to start this event, so we are a little bit late this time. So, guys, let's warm up and start our best. And we have already some people in the YouTube channel posting comments. So we'll put these comments, some of these comments here. So we will start with. Can you see, guys, the comments, or it's not appear yet?
Yes, they are on the screen.
Oh, great!
Greetings from the Netherlands.
Nice. I remember him. I remember Ari from Netherlands. Do you remember him?
Unfortunately, no. It was way too many new faces that I knew at that event.
Yeah, he was the guy in the first row near the screen, near the presentations during the event. Correct, Ari? Okay, so let's put other comments. We have Lingao Main. Hello. Yuka also is here.
We are happy to have you here.
Nice to see you here, Yuka. We have a presentation from him about the Polar Fire. It's very nice microcontroller, microprocessor. It's microcontroller, but very, very powerful. And it is a RISC-V microcontroller. So stay tuned because that will be a nice presentation. Hello, Glauber. Hello, Nauber from Brazil. Nauber Souza. Also, our friend Koval. Hello, Philip. Philip Koval is here. Bob from Nairobi. Nice to see someone from Africa, right? From Kenya. Yes, as I told, Ari was in front of the speakers. He just confirmed. James Howe, Ni Hao. Hello, Philippe again. Nice to see someone from France here. Roberto, is our contributor. He creates the Python encoder and put it to work on NuttX. It's very nice project. Thank you, Roberto, to see you here with us. Okay, now I will remove the comments and let's go back to our presentations.
Sure. Thank you, Alan. I would have a small request for the speakers. Please join us on Jitsi because we will have a panel discussion in 30 minutes.
Yeah, good point, Ali. For those that not yet in Jitsi, I send an email today early with the Jitsi link. So please go there. Let's see, Ali. You are okay. You got already.
Can you see my screen?
Let's see. Yeah, I can.
Perfect. Let me stop.
I need to. Yeah. Okay. Go ahead, Ali. We will start with Alan's presentation about the NuttX status and NuttX history for those are new to NuttX, and then later we'll do more. We'll talk more with our speakers, and we'll bring some news and some great information for you. This year we have some good surprise for those participants that will stay with us like in the previous year. So please stay here to get more news very soon. Okay, Alan, please go ahead.
Thank you.
You can move the right participants to out of the screen to make it full screen.
Should be. At least on my side, it looks like I am full screen and there is no participant in the list.
Let's see. I need to see in the YouTube. Okay, I think in the YouTube should be nice, right? Let me confirm. Yes, okay, Alan. In YouTube it's okay. It seems like it's full screen.
Yeah, I checked the stream. Thank you, Alan. Hi, everybody, and thanks for joining us for the NuttX International Workshop 2022. This should be the third event in the workshop series. We started in Gouda in 2019 when we had the pleasure to meet for the first time in person. Since then, a lot has happened. The NuttX has moved to Apache, and I see many code contributions. I see every day people interacting with NuttX, and everybody seems to be extremely busy with developing the NuttX itself, coding for NuttX, porting NuttX everywhere. But from time to time, we should also stop and reflect. What did we do in the last 3 years? What is the NuttX history? And how we all ended up here. So instead of doing a technical presentation today, I was thinking that maybe it's worth spending 15 minutes of your time with a status report. And then we should look where NuttX started. We should check how the project evolved. We should look at us as the community. And we should also look where we are with the licenses, because licenses are an important part of each project's life. I will start talking about the NuttX and how things have started. In the 2019, Greg had a really nice slide development deck where he presented how NuttX started. And it started in the mid-90s when he tried to do just an experiment with a handful of files. Quote from him. That development continues in early 2000, here and there adding small utilities at a low pace development. And in 2007, he released NuttX 1.0 under the BSD license on Bitbucket. Since then, the project has evolved on Bitbucket and it got more traction. But in 2019, the project has been donated to the Apache Software Foundation, and we started our journey as an incubation project. In 2022, we are in the final stages for graduation as a top project of the Apache software. So with those 20 plus years of history, we now are finally a project that is managed by a project community, and we have a lot of community developers. I think that we should thank Greg for creating this really nice project, and I want to personally thank him because it's not only something that we have to work with, but it's also a fun real-time operating system. The main characteristics from my perspective are illustrated in the arrow tips of the triangle. The operating system is portable, it's scalable, and it's compatible, which means that it's also available. It supports AMP and ASMP and SMP, and it also has edge AI support, because nowadays we start moving the AI to the edge, and we see more and more microcontrollers supporting those frameworks. Looking at what I presented before, we can also see the benefits. The project is mature with over 20 years of development. It has a consistent coding style. And I remember that it was really well documented when I first tried to submit code to the NuttX project. We have an active developer community which is reviewing and commenting on patches every day. And also it has an open license, which helps companies take the code in. From the requirements perspective, you can run NuttX on almost every low, medium, and microcontroller or microprocessor. It requires no MMU, but it can use MMU if you have. It can run on 8-bit boards. It can also run on 64-bit boards. It requires as little as 8 kilobytes of RAM for the basic operating system. And after that, only the application will set the needed amount of RAM. It's also extremely small. If you build the tiniest configuration, it's less than 16 kilobytes of flash. It started for 8-bit microcontrollers, and now we can use it even on RISC-V 64-bit. It was designed to be real-time from scratch, and it's designed for low power consumption. It's also available out of the box on over 300 boards from various architectures. Having all those benefits, we saw NuttX used on a wide range of devices, from Sony digital audio recorders. Masayuki-san had a really nice presentation in 2019, if I'm not wrong. In Bluetooth headphones, drones, protection equipment, safety equipment, RFID readers, IoT devices, fiscal printers, and even fitness trackers. And this year we got the news that it is also used in the Xiaomi S1 Pro smartwatch. We saw that along the time the software has been incorporated in products from Sony, Xiaomi, Samsung, Fitbit, Motorola, Haltian, 3D Robotics, Daruma, Verge Aero, with their awesome drones and many, many others. If you're interested, you can check the presentations that have been done by the respective companies in the NuttX online workshop 2019, 20, and 21. And we look forward on hearing about more use cases this year and in the following years. Now that we looked on the project history and benefits, I think that we should also look on how we all work. I could only find project activity from 2013 mid-year up to 2020 now, and we can see that each day we have quite a nice contribution ratio. The project slowed down between 2018 and 19 and ramped up after. Also, I was looking at the releases, since now we are doing quite nice releases on time schedule, and we try to do releases every 3 months. So we can see that in every release we had at least 950 push requests. Also, the next release planned for December this year, the 11.1, it's supposed to have roughly the same number. But then I looked at the number of files. And here you can see a nice growth. We started with 22,000 files in the 9.0 release, and now we have 26,500 of files included in the NuttX Git. Which, if we look at the lines of code, is roughly 950,000 lines of code added to the project from 9.0 up until 11.0. By the way, it's worth noting that the 11.0 has passed the project management committee vote, and now it's waiting for the Apache IPMC to vote. We need 2 more votes and the release will be live. Having the code contribution is also guiding us into the community aspect. And here we can see that we have more than 100 contributors in a snapshot that I took from GitHub. And we have a ranking here, but I think that it's less important the rank and it's more important the people. We have over 100 people working with the project, and I would like to thank you all for being part of this awesome community that we are part of, and we help NuttX develop. In the NuttX Git, there is a file called authors. Please check that your name is in that file if you submitted the ICLA or an SGA, because we are trying to fix the last remaining bits of the licenses. And we want to make sure that all people that have submitted the ICLA are documented in the authors. We want to give authorship and credits for all community members that help us develop this awesome operating system. As a recap, each release increases with 950 push requests, more than 200,000 lines of code. All of those contributed by over 100 developers. Those are amazing numbers. And since I mentioned the licenses, we should also look on how the licenses evolve. As you can see, in the NuttX 9.0 and 10.0 releases, the project was having mostly BSD licenses, with some Apache, some MIT, and some GPL licenses added here and there. After the NuttX 10.1, the number of Apache licenses has increased dramatically. And now in the latest release, the one that is supposed to come soon, we have over 15,000 files that bear the Apache license, followed by roughly 450 files that still have the BSD license. All of those files are documented, and you are supposed to find them in the license file. So the licenses are documented, but we are still working on making your life easier. So we started a big journey of adding the licenses to the setup itself, and then you are supposed to be able to exclude the licenses that you do not want in your project. This will make your life way easier documenting a product based on NuttX. As I mentioned, this is still work in progress. There are still some licenses which are not excluded when you select when you unselect the menu option. I hope that next year I will be able to tell you that this work in progress is done and the system will take care of everything for you. But for now, please also check manually if you have some concerns. And don't forget to check the license file to be sure that your project or product is compliant with the licenses. As a recap, we should remember that the project has main license as Apache. There are other licenses used in the project like BSD, MIT, and 2 files that are GPL. And you should check the license file for detail. There are no other licenses included in the project. Thank you. If you have questions, I will gladly answer now or later over email.
Very nice, Ali. Very good presentation. And yes, as you said, the license is very important because, for example, in the Apache license, you have some guarantees that the source code complies with the license. So if some company is contributing to it, it agrees that license will not be used against other companies using that source of code. And when you use other more primitive license, we don't have this kind of guarantee. So you need to be more aware of it by yourself. You need to verify if the features you are using are not subject of some software patent, for example. It's a very huge discussion about if it's correct or not. I think mainly in Europe, it's very restrictive about software license. So it's different from USA, where you have more freedom to patent everything, basically. So it's nice to. Okay, now you are present about the helpfuls, right?
Yes, it's that time of the day according to the schedule. So if there are questions, I will take them later, or you can write me an email. And I think that it's really important to also tell people that if they will be with us the whole day, today and tomorrow, we have prizes for them. There will be a raffle each day. For day 1, Sony is providing 5 presence LTE boards in case you want to build something with an LTE modem. Its presence is a Sony development board with a powerful microcontroller, and it supports Edge AI, it supports cameras, it supports high-res audio. So it is really nice if you want to build something along the line. In the second day, we have 5
Lolly,
Hey,
are you back?
yes,
Okay.
sorry, it looked like Chrome is still crashing. I will reshare. In the second day, we have another 5 presence LTE boards, and we also have a big prize from Xiaomi, the smartwatch S1 Pro, a smartwatch that runs NuttX, and I'm happy to see that they developed this beautiful smartwatch with the NuttX real-time operating system. I'm also curious if they will allow us to reflash the device with our own flavor, but yeah.
Yeah, I think we have some people from Xiaomi here. I don't know if they can talk about it. Donnie, do you know something about it, if it's possible or not? I suppose it's not so easy to do that because normally the company, they have some protections about it, but maybe it could be possible. I don't know. It's someone that Xiaomi that want to talk a little bit. Donnie, I think we have only Donnie here, right, from Xiaomi.
Yeah.
Yeah, it is possible. Do you know if Xiaomi has some plan to do something like in Android phone, where if you agree to assign that you lost your, for example, your guarantee, you will be able to flash your device. Do you know it's possible?
You may share later.
Sorry, too noisy here on my side. I cannot hear you.
Sorry, little Matt, could you repeat your question?
It's possible, for example, if the user wants to flash a new version of NuttX in his smartwatch, it's possible to remove the original firmware and flash a new one, or it has some protection to avoid it.
So it means the virtual environment for this middleware?
Yeah, imagine I want to flash a new Vela or a new NuttX OS on this smartwatch for my purpose, for my use. Can I do it? It will be possible, or it will block it to avoid it.
Yeah, it can be achieved.
Oh, nice.
That is a really nice news for most developers.
Yeah. I remember, for example, I have one here from a recorder from Sony, and and Masayuki told me it's not possible to flash it directly because it has some protection. Maybe in the future it could be possible to do something like that for all NuttX devices, because I want, for example, to try put a new version on it, and and to do that, I need to hack the device and maybe modify the hardware, and I could damage if I do it. So maybe if it's possible to do it in Xiaomi, it is in this smartwatch, it will be very nice, because it will allow all the users to do what they want. But probably after doing that, we lost our guarantee, right?
Yeah. Sure. But currently, maybe it's not implied on the real device with plan. So it's maybe about we are using these devices step by step. We develop this by step. Currently, it's just like the normal smartwatch, and it's using your apps. You can install some kind of apps on your smartwatch and can that. And also, it got some third-party apps, not just the like some smart band or something. It's more smart compared with this watch. Yeah.
Yeah, I understood. So we'll be able to use the SDK to create applications and put our application on this device. That's correct?
Yeah, we got it.
Oh, great. Very nice, right, Alin?
Yes, this is exciting. I think that we are getting a really nice news regarding reusability and repurposing after the expected life cycle of the device.
Very nice. We have others people arriving here. I cannot read Chinese name. Maybe Donnie can read this Chinese name for us. Donnie, can you help us to to read Chinese names that people are arriving here?
Sorry, what? Can you repeat your question?
We have some people names are in Chinese in the NuttX channel, but I don't know how to read his names in Chinese.
Yeah, his name is Guo Yizhuo. You can call him Mr. Guo. Yeah.
Okay. I think it help a little bit, but not too much.
Yeah.
Just okay, thank you very much. Chinese is very difficult for me.
Okay.
Same here. I will also share this schedule in case we have people that still miss it.
Okay. And yeah, let's see. Okay, guys. Thank you, Ali, for putting it online. So feel free to start asking questions for us, for the other speakers and other developers here in the NuttX International Workshop. Okay. We are very happy to have you guys here. Everybody, speakers and people watching this event. This year we have a little bit less people join at this moment, but I think it was in some way our fault. Let's say this way, because we didn't have too much time to promote the event and to do the same thing as you did in the previous year. And also this year, we decided to put the event more to end of the year, and then this shift all the logistics to organize the things. But we are doing our best to get everybody enjoying the event, and we are very happy because we got many nice presentations. We are full of presentation for today and also for tomorrow. And so, guys, feel free to ask questions. Okay. You can use the YouTube chat to do it, and we'll put your comment here in the channel. Okay. So while you ask question, we will start to talk between us and talk a little bit about the NuttX and about some curiosities about NuttX. Okay. I think I asked this question last year, but Alin, how did you discover NuttX?
For me, it was mostly through presence. At that time, I was working with presence. We were thinking about upstreaming the hardware support for the presence board, and that's how I started for the first time. I have to admit that it was a really nice journey. Me coming from Android, so mostly Linux. And after that, I started looking on what are the missing things. And I contributed mostly the license part on top of this present support. I think that licenses are an important part that us developers most of the time forget.
Yeah, thank you, Ali. And yeah, that's true. As I said before, the license is very important, mainly in this case where you have some patent trolls trying to damage your company because they are a competitor or some other for some other reasons. But in this case, have a good license, you can avoid this kind of issues. So it's very important to have a good license. And the next one here, Donnie, how did you discover about NuttX?
Sorry, you mean how discover NuttX the first time?
Yeah, your first time. When you saw it the first time and how you start working with NuttX?
It's about the PX4. It's the first time I'm using PX4. I noticed that there is some NuttX inside it. That's the first time I'm using and to touch how NuttX works and applied it to my project.
Nice. Yeah, actually, many people start to discover NuttX because the PX4.
Yeah.
The PX4 open a new world for NuttX because many people enjoy drones and start to use the PX4 project in his own drone, and then it is running NuttX as the kernel, and then they start to use NuttX and contributing to NuttX. Thank you, Donnie. The next here is Yerne. I always, it's difficult to say your name.
Yes. Hi all. Well, let me think about it. I was developing my own hardware board and I was looking for a good operating system. And truthfully, my first choice was Zephyr operating system. But when I was working with Zephyr, I noticed that the POSIX compliance is a little bit not as good as it should be. So I was looking further and come to find the NuttX operating system. And after I was trying the NuttX operating system, it was no way back. So there were also some moments because the microcontroller which I was using was not supported, and then I decided to make a contribution to NuttX and support the microcontroller. And today it is supported.
Yeah, nice. I remember one of your first contribution was the Flex Flash or something like that for.
Yes, the NXP RT microcontrollers are not on NuttX. They were not having a support for external flash to put the little file system on. So this was also needed to be developed in order to get external flash support.
Yeah, very nice. And it's good to have previous Zephyr user here on NuttX, because normally we see people, some people move from NuttX to Zephyr. So now to see the opposite as well.
Yes.
I think
Zephyr has some good points, but nevertheless, what convinced me was the build process itself. It's much easier on NuttX than on Zephyr, and you get all the code. The code is much more readable, I would say, in the NuttX than in Zephyr. So, and it's a good point to have these rules how to make the contribution.
Nice, very good. Thank you. The next is Lup Yuan Lee. I say your name correctly today?
Yes, perfect. Lup is correct.
Okay.
Yeah.
Lup.
Yeah.
Lup is also a previous other OS user, right?
Yeah. Actually, I haven't. I'm very new. I haven't. I only used NuttX for about less than a year. So, I'm an IoT educator, so I'm always looking for new, interesting ways to teach IoT. So, I was experimenting with a RISC-V board BL602, and NuttX is the only community-supported option. So that's why I tried NuttX, and I love it, and I started with them since. So since then, I've been writing a lot of articles, publishing, what you can do with NuttX or IoT. My proudest achievement is probably porting LoRaWAN stack into NuttX. So super complicated, but it works. Yes.
Oh, very nice. We are very excited to have Lupi with our team in NuttX. He now is part of the PPMC, and he did very good articles, very good contributions. And if people don't know, Lup is the only people here since the first event 4 years ago that submitted 4 presentations for this event. But this time he got only 3 accepted. Yeah, congratulations.
Thank you.
I hope in the future you submit 5 presentations and all 5 are accepted.
Yeah, no problem.
Alan, another comment on the same topic. It would be really nice to see NuttX getting some traction in the 3D printing community, since most people are using Linux over there for the driver boards. And I was having an idea of looking if we can somehow port it. So yeah, maybe next year we will have something to talk about, and instead of being just PX4 that spreads the news about NuttX, maybe it will be some 3D printing community.
Yes. Did you know the first Linux international, the ELC, Embedded Linux Conference, the first Embedded Linux Conference that I went, it was in, Masayuki was there in Portland. And did you know the people from the company 3D Systems, the famous industrial 3D printer, show 3D printer running Linux. They create a Linux with real-time paths applied on it and so on, and got it printing in like a plastic resin, like a sinterization of plastic. I don't remember the code. It was MJ2000, something like that. The machine code. I can't remember correctly, but it was running in Linux. And maybe if we get NuttX running on one 3D printer, we can open a new field of application for NuttX. Yeah, that idea is very good, very clever, Ali.
At least from my side, I can share the pain. Linux works perfect when everything has booted up, but in case of something or on the first boot, you will still have to wait 30 seconds until you can do anything. And the NuttX boot up time is extremely small compared with that.
Yeah, and other detail for 3D print is not a big issue, but comparing to NuttX, Linux consumes too much energy. It's very power hungry compared to NuttX. So
that is mainly the reason why it takes 30 minutes. It's not a very powerful machine because you don't need that amount of power, and then Linux is booting slow.
Yeah. Okay, good idea, Ali. And so I think you go for it. And next is Masayuki. Hello, Masayuki-san. Oh, now we can. I am happy because now I can see you and I can see your motorcycle in the
yeah.
in the wall. So, could you please talk a little bit how you discovered NuttX? How was your first
perhaps some of you already know my journey to
yeah, but we like to
NuttX. But yeah, actually, I discovered NuttX in 2013. So when we started to study the feasibility study for a new generation of voice recorder, as well as wearable devices such as as called the Walkman feature with headphones. And so we worked with semiconductors in Japan, but they didn't know how the NuttX is. And I also tried to find a good operating system for their such products. And I firstly tried to use FreeRTOS or ChibiOS, or maybe you don't know, but in Japan we call the so-called iTron-based operating system. Is very famous. But I personally don't want to use such a operating system because it's not project space. So, and then finally I found NuttX, and soon after our team supported NuttX to all the processor for us. And this is 7 base. And soon after, on Semiconductor created a FPGA based new processor, and we ported NuttX and to the new processor. And finally, we succeeded to create our new products as Alan just saw here. And I gave a gift. Yeah.
Yeah, you gave me it 4 years ago. And most important,
yes.
Most important, it's still working. And very fast and very good.
Yeah, this is our first generation of IC recorder, which has NuttX based voice recorder.
Yeah, I have a device running NuttX, a commercial device running NuttX on my house. Yeah, very good.
And so that's our history.
Yeah. Can you say, can you speak about it? What was that FPGA microcontroller that you ported to NuttX? Do you remember the FPGA? You said you ported NuttX for an FPGA running a microcontroller, implementing a microcontroller. What was that microcontroller?
Yeah, actually, as I said, so at the time, on Semiconductor was developing a new generation of microcontroller, so-called LC823450, which is used for new voice recorder. But before creating a processor, they created the FPGA version of a new processor. So that's why I tried to port NuttX. So before getting ES version of the processor, so actually we ported it to the FPGA version of the processor first.
Nice. Okay. I saw we have this on semiconductor microcontroller ported on NuttX that you did the port.
Yeah.
Thank you, Masayuki. Michael, how did you discover NuttX?
Yeah, I've been working for a company that does payment terminals for credit card payments, basically. And the terminals were based on embedded Linux. And for me, it seemed a little heavyweight Linux, especially the boot time, as Alan already said, is like 30 seconds a minute for a Linux-based payment terminal, and they have to be restarted once a day out of security reasons. And depending on the deployment, in which context they are deployed, this is a real problem. And back then, we looked into a less heavyweight solution that would boot up faster, execute in place, Flash-like, basically. We had some experience with microcontroller Linux, but then just by Googling, I got hold of NuttX and understood that this is a POSIX-compliant operating system running on microcontrollers, booting up very fast. And we played with it, and it's really amazing. And I stuck with it. You are on mute.
You are muted. Michael, as a comment, this year at Embedded Linux Conference Europe, BMW presented their hardware that runs Linux, and they managed to achieve under 2 seconds boot time.
Yeah, but you need to optimize a lot for it, and this is typically not worth the effort in the payment space. I mean, BMW probably has a huge budget for doing this kind of optimizations, but small companies.
And over 100 watts of power.
Yes.
Thank you very much, Michael. I was going to say I also started with micro C Linux or ICU Linux.
Okay.
I see Linux actually.
Perhaps, Alan, I have one question to your presentation, if I can pose it now.
Sure, yeah. We have 2 more minutes, so I will take your question. We will start the next presentation, and then we will continue after the presentation. Okay?
Okay, perfect. So how's the Apache Software Foundation seeing the NuttX project, and what's the outlook for becoming a full top-level project? Do you think this will happen this year?
I really hope. We started the discussion regarding what things we have to still do. So there is a checklist. And now it's still under discussion. From my perspective, we did everything from the list, or almost everything, but they have to be documented. So that is the part that is still going slow. And then from my personal perspective, I would like to have that menu up and running in setup. That will help a lot. So from a legal perspective, all the licenses are documented and you can check them in the license file. But then you have to manually go and select the options that you do not want. Well, with that automatic menu, you will get rid of the licenses that you do not want as a bulk.
Okay,
thank you.
Thank you, Alan. Thank you, Michael. Now we have time to second presentation. Just before we start the presentation, I want to ask everybody to turn on the camera, and we'll do a print screen just to produce a material to put in the website. So everybody, Donnie, please turn on your camera. Pedro, and Koizumi-san, Lupi, say hello.
Hello, Petra.
Hello.
Hello. Hello.
Hello.
Hello.
Yeah.
Hello.
Okay, we just need to, I'll do it again. Oh, now everybody's here.
We need.
Hello.
Hey guys, nice to see you all.
Nice to see you all. So Ali, let's start the next presentation.
Please start the playback.
Okay, I need to open it. Can you tell me I need to open it.
The next presentation is porting Luajit on Cortex M7 from Yerney.
Yeah, Yerney. Okay, just a second. I will open it. Okay, I will share my screen and let me know if now it works. Okay, can you see my screen?
Yes.
Yes, I can see it.
Perfect. So let's play it.
Hi, my name is Jerne Turnšek, and today I will present you porting of Luajit to Cortex M7 architecture and NuttX operating system. NuttX has already an excellent support for standard Lua interpreter, but with Luajit we can gain more speed and performance compared to standard Lua interpreter. But first I would like to introduce myself. I come from Slovenia, which is a beautiful country situated between Croatia, Hungary, Austria and Italy. I'm working with embedded systems for over 20 years in a company called Iskra Emeko, where we produce energy electricity meters. We are mainly producing household and industrial meters. During this time, I had the privilege to work with numerous operating systems, down from RTOS, like FreeRTOS, to up to Linux and Windows CE. I worked even with some custom operating systems developed especially for our meters. Off work, I have designed also and developed a tiny platform for IoT and do-it-yourself electronics, which I called Edge Pro 1. I will talk about it later. I'm father of two, and in my spare time I like to mountain biking and RC modeling and of course open source ThinkRig. Okay, first we need to ask ourselves why Lua? Lua was developed in Brazil and it means moon in Portuguese. It has a simple syntax and very easy learning curve. And of course, Lua is very powerful, efficient, lightweight, and embeddable scripting language. It supports procedural programming, object-oriented programming, functional programming, data-driven programming, and data description. Of course, what I mostly like of Lua is that it comes without batteries. This means that you can add things later when you need it. So thus it is very convenient to use in embedded systems. It has also a very simple interface to see, especially in the case of Luajit, where we can use foreign function interface built in Luajit. As I said, it has very powerful data description constructs based on associative arrays and extensible semantics. Of course, it's dynamically typed language, and I think it's ideal for configuration, scripting, and also rapid prototyping. Where it is used, Lua is used mainly, it was used mainly in games. Everybody knows Angry Birds. Also routers, OpenVRT, for example. Software-defined radios, like Lua Radio. Web servers, NGINX uses Lua for configuration. And also Adobe Photoshop Lightroom uses Lua underneath. You can, of course, find Lua also on embedded devices. Maybe you heard of eLua project or Node MCU on the ESP8266. It uses Lua. And of course, Whitecat project also using Lua. Okay, so now we need to ask, why LuaJIT? LuaJIT is another implementation of Lua interpreter with an emphasis on speed. It relies heavily on double precision floating point numbers, thus having a double precision floating point unit is very beneficial. As I said, as the name is saying, it's just-in-time compiler for the Lua programming language, and it is based on Lua 5.1 with extensions like foreign function interface, bit operations, and it also has hard and soft floating point support. It has a built-in dynamic assembler for code generation. I will talk about it later also. And underneath, it uses a hot loop trace execution. So JIT compilers comes in many flavors. One of this flavor is hot loop trace execution, where piece of a program is analyzed and it is translated directly into the machine code if this piece of a program is running many times. So in this way we can speed things up with the just-in-time compiler. As I spoke earlier, Lua has a great support for interfacing to C with the foreign function interface. It's even easier to interface with C with FFI than with a standard C application interface, which is also built in Lua. LuaJIT supports multiple architectures from Linux, Windows, macOS, also some real-time operating systems, but unfortunately it does not support ARMv7M architecture and NuttX. And also the great thing about LuaJIT is that it has an MIT license, which is compatible to Apache 2.0 license. Well, to run LuaJIT, we need hardware. Because LuaJIT is a synonym for speed and performance, we need equally fast microcontrollers to experiment with. So the Cortex M7 is one of the fastest cores for embedded use, and the decision was made to use M7 for running LuaJIT on embedded. On the other hand, LuaJIT is very, very small compared to other virtual machines or JIT-capable virtual machines. So we need equally small hardware to demonstrate the capabilities of LuaJIT. Initially, I was working with official NXP development board for IMX RT1064 CPU microcontroller, but later I have decided to build my own, and I have named it Edge Pro 1. Edge Pro 1, as you can see here in the picture, is a tiny open source 600 MHz ARM Cortex M7 board. It has 4 megabytes of executing plates flash, 1 megabyte of RAM, and of course 8 megabytes of external flash to store Lua programs on. It also comes with the uBlocks Nina W102 Wi-Fi Bluetooth module, which is built on ESP32 architecture. Optionally, it is available as also ECC 608 security chip. Although NXP-RT microcontroller also have some security peripheral, I decided to add also additional security chip to store externally private keys, etc. The board itself has 22 pins. 17 pins are general purpose IOs and can be configured as an SPI, I2C, I2, I2S, UART, FlexIO. Even 2 pins can be used as an analog to digital converter for ADC purposes, yes. For the communication with the board, I use micro USB connector, which is also powering the board and used as a console to NuttX operating system. On the board itself is a 1.2 amps DC-DC power converter, which can also supply power to externally connected devices. The board itself was developed in 4-layer technology, although there were times where I was considering 6-layer, but nevertheless I managed to squeeze everything on the board with the 4-layer technology. And as you see here, it's 32 millimeters by 16 millimeters, which is very, very tiny. You can compare this with the standard Lego 8-stat brick, which I'm showing here on the picture. Okay, now let's go deeper. Here we can see the architecture of Cortex-M7. We can look closer under the hood of this Cortex-M7 architecture, and we can see that it is built around the ARM v7M architecture. ARM v7M architecture is unique to all Cortex-M devices, although the Cortex-M7 is using actually a ARM v7EM architecture, which means it comes with the DSP extensions for digital signal processing, instructions for digital signal processing. The unique thing of ARM v7M architecture is that it supports only thumb and thumb2 instruction set. It is not supporting ARM instruction set. Cortex-M7 usually comes with a single or double precision floating point unit. In the case of NXP, it is a double precision floating point unit, and this is a positive thing because Lua mainly use double precision floating point numbers, and this way we gain speed. There are 4 instruction encodings inside ARM v7M. Called T1, T2, T3, T4. The first 2 are 16-bit and the second 2 are 32-bit instruction encodings. Also, some special thing of ARM v7M architecture is that all conditional instructions must be preceded with special IT instruction, which is not the case with the ARM instruction set, where almost all instructions are conditional, but here instructions are conditional only if they are encapsulated with the IT instruction, but the IT instruction can encapsulate up to 4 instructions, so that we don't lose so many speed if we have many conditional instructions. Also, permitted offsets from a program counter are smaller than with ARM. These can be problematic this was problematic when I was porting LuaJIT to ARM v7M because some of the program inside LuaJIT has to jump a little bit further than these permitted offsets are in the instruction set. And also some instructions from ARM are missing in thumb2, although thumb2 is completely, it's quite close to ARM instruction set, but some instructions are missing, yes, and this also presents a challenge to me. Okay, now we can go to actual porting of LuaJIT to ARMv7M. This is the first step. Because LuaJIT has a very complex structure, we need some kind of strategy to port LuaJIT to a new architecture. And this comes in the form of checklist. I have analyzed the LuaJIT source code, and I have found out these 3 points which needs to be done, or 3 tasks, in order to successfully port LuaJIT to ARMv7M architecture. Of course, ARMv7M reference architecture manual is very important. It's our friend here, because previously I was not aware of every instruction inside the ARMv7M, and with this document we can get information about every instruction in this architecture. First 3 tasks which needed to be done are, the first task is actually to port dynamic assembler to ARMv7M to ARMv7M architecture, and this dynamic assembler is written, some part of it is written in C and some part is written in Lua. Then the second task is to port the LuaJIT interpreter itself, which is written in assembly. And the last task is to port the JIT compiler backend. This is the hardest part of the porting of LuaJIT. Because of the complexity of our tasks, regression testing is a must. Luckily, LuaJIT comes with an extensive set of tests. This way we can immediately test and see where we stand with our implementation. This is especially the case with JIT backend porting, where all the hard stuff is stored. So this test repository, it has over 500 different tests, and it is testing the LuaJIT interpreter, it is testing the JIT compiler, it is testing almost everything in LuaJIT. Okay, let's see now what the dynamic assembler is and how we get to LuaJIT interpreter. As I said earlier, one of the most interesting part of LuaJIT is dynamic assembler. This dynamic assembler code generator can be even used as a standalone program in other projects. It is the first step towards porting LuaJIT to Cortex-M7 architecture, because it must know how to generate correct assembly code for ARMv7M architecture. And here on the picture we can see dynamic assembler preprocessor. It is here in the middle part. And the 2 files which we need to prepare for the new architecture are dynamic assembler ARMv7M.h and dynamic assembler ARMv7M Lua. Yes, dynamic assembler preprocessor is written in Lua itself. It is a small Lua implementation inside LuaJIT, which is pre-built in the build phase, and it is used to construct the dynamic assembler preprocessor, which in turn then pre-process the VM ARMv7M.tsasc file, which holds the Lua-JIT interpreter part written in assembly. And here in upper right corner, we can see the syntax of this DASC file, where we can mix C code with assembler code, and also, as you see here, there are some variables from the Lua state, which are then dynamically assembled into Lua-JIT interpreter assembly file. And this preprocessor is then generating output to build tool, which is also built in during the build of Lua-JIT. So it's built on the host machine, and this tool is actually transforming DASC preprocessed file to machine code and storing this machine code into assembly file, which is called Lua-JIT VM.s assembly file. And as you can see here, this file already has machine code built in for each of the interpreter functions, like Lua-JIT virtual machine hot call function. It is not using assembly instructions, but it is using machine code. But this file is then linked in the build phase of the Lua-JIT to produce the final Lua-JIT executable and library. Okay, this is the first step, and also the second step, how to port Lua-JIT to a new architecture. In short, we need these three files to be prepared to get this single file here, which is then linked to final executable and library. And then comes the hard part. This is the JIT backend. So after successful porting of Lua-JIT interpreter, we need to port also the JIT backend. JIT compiler holds all the black magic of Lua-JIT and is responsible to generate hot loop traces directly into machine code. For this, intermediate instruction representation is used. It's a special format inside Lua-JIT where all bytecode commands are transformed into intermediate instruction representation codes, and these IRR codes are then compiled into machine code. So to gain speed, optimizations and exploitations of specific CPU architecture are very important. Also, for the whole JIT backend, I used ARM backend, which was prepared for ARM instruction set as a base, and I use it for the thumb backend. Only 32-bit instructions were used, so I deliberately choose to avoid 16-bit instructions, although some 16-bit instructions are unavoidable, and they were filled with NOP instruction, which is also 16-bit instruction, in order to get the 32-bit alignment. All these conditional instructions, as I said earlier, are wrapped with IT instruction, and also extensive use of double precision floating point unit instructions were used. I will show later what was the problem with the branching, and here I will just touch this issue. I used winners for calling virtual machine interpreter functions from traces because simple branch instructions were not good enough because of the different address space. So as the ARM v7M architecture has only a 24-bit maximum address say, relative address inside the instructions, but with our hardware we need the whole 32-bit range to jump from hot loop traces to virtual machine interpreter functions. I will show this later. Also, I need to isolate the trace memory allocation. I put this memory into the tightly coupled memory of the NXP RT1064 microcontroller to increase the speed of execution, because tightly coupled memory is executing at the speed of CPU, which is 600 megahertz, and it is not using cache at all. This way we can speed up things. Also, this JIT engine, which is built inside Lua JIT, it can be highly tuned and also turned on and off programmatically. What is on my to-do list is that I don't have an RV7M disassembler. This is used mainly when debugging of the generated traces is needed. You can show this generated machine code through the Lua JIT command line interface, but this task still needs to be done. Okay, now let's jump to NuttX support in Lua JIT. Minimal work was needed to port Lua JIT to NuttX because of NuttX POSIX compliance. Lua JIT has already a POSIX, is already POSIX compatible, so also the NuttX is, and this was the positive thing because it wasn't required so much work to port Lua JIT to NuttX. As we can see, Lua JIT is compatible also with Linux, BSD, macOS, Windows, you name it. But I need to change the M code allocator for Cortex M7 MCU. As I said earlier, this M code allocation is in tightly coupled memory, which has completely different address space than data memory or even Lua object memory. Because Lua JIT on Linux is meant to be run from process memory space, addresses used for traces are close to code execution addresses, which is not the case with NuttX. So some kind of a winner method needs to be used when branching from traces to interpreter. This is slowing things down a little bit, but this is the price to pay. So here we have a winner to extend the range of a branch, and on this picture we have 4 different memory areas inside the Cortex M7 CPU. First is the flash memory area, which is on this address 0x7000. It's execute in place flash memory, 4 megabytes of it. Here is the main Lua JIT code is running from. Also the Lua JIT interpreter code is running from this memory address. Then we have this instruction, tightly coupled memory on this address, which is 0. It's 128 kilobytes of it, and we use it for M code allocation. So all traces are allocated from this memory. This memory is, this M code allocator is actually allocating memory in steps of 8K. And then internally it uses this memory as it is needed. So there is no memory defragmentation because all allocations are in 8K steps. On the other hand, we have a data tightly coupled memory, which is on address 0x20 million. We have 256 kilobytes of it, and here are NuttX variables, tasks, stacks, etc. allocated from. I decided to use this data tightly coupled memory in order to gain some speed. On the other hand, we have also OCRAM2 memory range, which is on this address here, and we have 640 kilobytes of it, and the whole this memory is used for Lua object memory. Lua object memory uses internal memory allocations in steps of 32 kilobytes. Then internally from these 32 kilobytes, it is allocating objects, deallocating objects, it's doing garbage collections, etc. Everything is done in legit. Okay, this is NuttX, and now we come to conclusion. So I will try to show a little demo here. I prepared two demonstrations. First is with Renault simulation. I can simulate the whole NuttX operating system on the PC with the help of Renault simulation tool. It's an excellent tool. It can simulate peripherals, CPUs, different CPUs, architectures, networkings, etc. You name it, everything can be simulated inside the Renault. It's written in C#, but actually, for our case, everything is already present in the Renault. We can simulate the hardware as we were using the real hardware on the desk. So the second demonstration will be RGB LED turning on and off on the real Edge Pro 1 hardware. Okay, we can go. Now I will change this and go to this 3. So here I have a virtual machine, Ubuntu virtual machine, where I have a NuttX 3. I have already pre-built the Edge Pro 1 configuration. And now I will show you, okay, I can show maybe how the NuttX is here. Maybe you can see we have an Edge Pro 1 board. Inside this, we have all these files, and we pre-built the Edge Pro 1 configuration. So I prepared two configurations. One is with the Nut shell, and one is for the Renault simulation. And we will be running Renault simulation. So to run Renault simulation, we just need to call Renault program, and the Renault console should be showing here. Okay, we have a Renault console, it's a monitor, and from this Renault console we need to trigger our machine, which is called Edge Pro 1. So we just press S for start, and Edge Pro 1, see, we have a script for firing up the Renault machine, which will in turn open the serial console here. And you can see it is running the serial console. We can do the help. Inside the serial console, we have all these commands. We have already LuaJIT built in, all the nutshell, and also VI editor here. I had only a slight issue with mounting the little file system. This still needs to be repaired because I'm not using the actual flash which I'm using on the actual hardware. here, and I think there's a problem with mounting to the file system, but nevertheless, I can show how LuaJIT is working. So we fire the LuaJIT repl. So, and here we have a LuaJIT running already. We can do print hello Lua, for example, and it will print hello Lua on the command line. So we can leave this. To finish with the Renault simulation, we can just type quit in the Renault console, and the Renault is closed down. So now we can go to actual hardware, which I have here. It's a very small board. I will connect this to a USB cable. Hope it will work. Okay, we have this connected, and then we need to fire the okay, now we have NUT shared console on the actual hardware Edge Pro 1. And again, here we can see the help. We have a LuaJIT VI RGB LED application also built in, but here we have a working file system where I prepared two files. The first is a test Lua program, which we will be calling to fire the RGB LED. And we can see what is inside this program with the help of VI editor. And here we have an RGB device which is opened. And then we just in a loop write some value to the RGB, wait a little bit, and shut down the RGB and repeat the whole step. So we can do this and fire this program. JIT test Lua, enter. And you can see LED is blinking. For 10 times. Okay, it's finished. I also want to show another program which is called a CMark, written in Lua. It can test the performance of Lua itself. So we can just fire it and wait to see the results. So now this CMark tool is calculating a lot of things inside the board, and it will show the numbers how fast it is calculating. There are many. Okay, we have an FFT test, which is actually 18.9 million operations per second. And also other tests are finished, and the overall CMark was 28.25. If we compare this with JIT compiler off, we can do it like this. So we can do it JIT J off. The test is run again, but the numbers will be much lower because the JIT compiler is turned off. So we need to wait. Okay, you can see the difference is quite substantial. Just to finish for test. Okay, it's almost 6 times slower the overall than with the JIT compiler on. So this concludes our presentation. Thank you for listening, and I will be available for questions. Thank you.
Okay, thank you, Yernik. Very nice presentation. I need to turn off my... Okay. Very good, very nice. It's really surprised how LuaJIT improved the performance comparing to Lua without the just-in-time compilation. So it's really nice. And yeah, let's see if we have some questions. I saw you already replied some of them, right?
Yes, yes.
Okay. Let's see. I will just put some normal comments. Andrea Branches say thank you for sharing. Okay, now it's appearing. Hello all. It delayed a little bit to show the message, but eventually it appears here. Okay. Hello, André. André Almeida saying hello in Portuguese. Bom dia. Nice. Guilherme Rossi saying this is a nice presentation, interesting presentation. Yes, we really enjoy it. And actually, I have a question. Yeah. Do you have plans to submit your board to NuttX mainline?
Sorry, NuttX?
Do you have plan to submit your board support to NuttX mainline?
Yes, actually, after a successful campaign on crowd supply, I was planning to open source the whole thing, even the hardware and even the LuaJIT interpreter, and also, of course, the Edge Pro 1 board itself.
Nice. And do you have some schedule for the board? When the board will be available to buy?
Yeah, it's very hard to say because currently I have only a few prototypes of this board. I'm negotiating with the local EMS company to produce it, and as you know, currently it's very hard to get the materials. So I think the lead time for the microprocessors is 52 weeks, but I'm hoping to get it sooner. The main CPUs, and also for the U-Blocks module, it's 26 weeks. But I'm also negotiating to get it sooner. So it's hard to say when the board will be available, but maybe the end of the year or first quarter next year, it will be finished. It is the firmware itself, it's quite finished, but now how to produce it in the large quantities, this is the main problem.
Okay, nice. Ari has a question for you about the footprint of NuttX plus LuaJIT.
Oh, yes, it's interesting. Yes, I would say the bare bone LuaJIT on NuttX footprint is around 400K, or even smaller if something is thrown out of the NuttX. But the LuaJIT interpreter and compiler, it's 300K, and then everything else, it's in the NuttX. I would say currently I have a VI editor and also have some other libraries which are not used, and I'm on 400K.
Nice.
But in the future, I plan to add additional libraries. I also developed a few of my own, and those libraries will be accessible through foreign function interface from LuaJIT. So, as I mentioned in the presentation, it's quite easy to call through foreign function interface directly to C code. Especially if you have this DL open support in the NuttX, which is quite nice to have it. This is also one of the main reasons I migrated from Zephyr to NuttX. But nevertheless, it's still not the same as it's on Linux to include the shared libraries, but you need to prepare a special application in order to get all the application interfaces from this shared library and built into NuttX. And this I'm planning to do, to incorporate many more libraries and make it accessible through the foreign function interface.
Nice. Talking about it, still talking about memory, André Almeida is asking how much memory consumption. I suppose he mean exactly about it during the running, how the memory consumption is low, is high. How is that memory consumption?
Yes. As I presented in the presentation, you have a 640 case for the Lua memory. And only 256 Ks for the NuttX itself and all the stacks, tasks, etc. Regarding the memory, the LuaJIT executable, I think I'm running currently with the 16K of stack, but it's not needed, I would say. It's more 8K, which is needed in order to get the LuaJIT executable running. I think when the LuaJIT is loading the state, it's, I think, less than 20K of memory used. And then you can run all of the LuaJIT code, which allocates the Lua memory inside this 640Ks. I would say the usual, for this usual embedded stuff, Lua programs, you don't need more than 100 Ks for Lua memory or something like that. And if you're doing the LuaJIT JIT compiler also, which is then allocating from the 128K of this M code allocator, this is also not a problem, because these hot traces are usually very small pieces of program compiled directly to machine code, and for normal use, you don't, I would say, maybe 2 or 3 allocations from this memory were needed in order to get the normal program running. So, but it depends what you're running on site on this what kind of Lua program you're running. So you can, if you're a bad programmer in Lua, you can get quite a lot of memory use. But if you're a little bit wiser, then you don't need to allocate so many objects inside Lua program. It's completely dependent on the programmer itself.
Yeah, perfect. By the way, talking about the loading, we have a presentation about the dynamic loading for NuttX. It's from Neil. Neil, he's a guy that works for Middle project, and he create a more evolved loader for NuttX, and we will have a talk about it. And so maybe it could help you on this area to improve the dynamic loads of libraries, of of binaries. So
yeah, I'm looking forward to hear that presentation.
Yeah, I think it will be nice. Okay, now
we have 10 more minutes, and I think that we can continue with our history on how did you embark into the NuttX.
Yeah,
we have some speakers.
We missed Pedro. Hello, Pedro.
Yeah, hello. Can you hear me well?
Yeah, we can hear you.
Yeah, so a bit of my story. So probably 5 or 6 years ago, I was working in the wind industry, and we were developing different kind of gateway to redesign it. And I had like a small budget to do investigation in what kind of good design software is available on the market. So it was all the open source and the closed source, the proprietary stuff. I investigated. I found during that investigation many like good things like the quantum leaps, even during framework, the NuttX, the proto threads, even from the Adam Dunkel. So pretty good things. I made the report, and I also found the NuttX. And loved that from the first line of code. That was so well designed that I just couldn't think that what can be better. So the things that are usually missing from the design point of view, I think, is like the weight on the multiple objects. Things like a free RTOS or all other, you cannot wait on a semaphore and the queue at the same time. But with the POSIX and the NuttX, you can do it easily by using the select. I started to look into NuttX. Unfortunately, I didn't convince the management to use the NuttX in that project, but I started to follow up silently and then contributed my first board, and now I'm contributing more and more based on what I can.
Yeah, you are very good contributor. You review all the commits and do a lot of contributions. So congratulations you for doing that. And about working for some company that don't want to use NuttX, I think Michael has a way to fix it. Right, Michael? I don't know if Michael is listening us now. But basically what Michael did was he decided to create his own company because his previous company didn't like to use NuttX for the project that they are planning to work. So
yeah, probably a very good plan, I would say. I will note that.
Yeah. So now he has his own company and he can work on that. He can work in everything he wants because now he decide what to do, what RTOS to use, and then he's free to do what he wants. And sometimes when you work for some other companies, it's very difficult to convince the company that your idea is good or this RTOS is good to use, because normally they prefer to use RTOS. They're more commercial, so they have some company supporting it from scratch. So it's a little different when you are open source project. Then yeah. So this is something we need to find a way to improve over the time. How to get better support for NuttX. Maybe having more companies supporting it, more companies developing consultants. Right, Alin?
Yeah, I finally managed to get my camera up running. Apparently, this is crashing Chrome.
I saw you go out and then appear to enter again and just click on accept it. So
thank you.
Yeah, this Chrome is not good for some applications.
Yeah, like usually big companies, they would like to delegate the risks about the things they don't know how to do. So if we manage to build a good community that can be asked for support, that also can be improvement for many more people starting using, and even commercial companies.
Yes. But Donnie also dropping. Okay. Yes, I agree, and I think this is the way to go. We need to have a more participative community. We need to have more people helping the project, and then we see more small companies helping the project. And as you saw in Ali presentation, there are many companies already using NuttX, big companies like Xiaomi, that we have presentations from them here. We have Sony, we have Fitbit, now part of Google, and many others. We have like I said, Michael has his own company working on NuttX, creates some smart card reader device, POS, point of sales, and so I think is having good community and strong communities is the way to go. And doing this event, doing this workshop, is a way we want to get more people involved. And over the time, we will see during each event we get more people contributing to the project. So I think we need to work on that to still getting more people involved. Okay. Now, Alin,
it is time for the next presentation.
Yeah, I think we just need 2 minutes.
Yeah, we have 1 minute and a half more.
Yeah. The next presentation is LUP, about the LVGL. LUP, just to confirm, you are planning to presentation live, or do you want to play the video?
Can you play my video? Thank you.
Yeah, yes, sure. Alin, do you want to?
Please read the chat on Discord.
Okay. You mean the LVGL creator?
Yes.
I don't know if he'll be around, but we can try to ask him to.
Okay, play the presentation and we will try to do it.
Okay, nice idea. Okay, thank you, Lup. We'll play your presentation now. Just a second, guys. I need to open it and LVGL. Okay. Move it to here. Okay, can you see the screen?
Yes.
Okay, with full screen and.
Hello, everybody. I am Luck. I am an IoT educator from sunny Singapore. I used to teach IoT at a local school for evening adult education. Nowadays, I write educational articles about NuttX and publish them online. So my work in IoT education has kind of moved online. IoT gadgets today are becoming more sophisticated. Some of them have a touchscreen display, which explains why I'm so excited about today's presentation. Today I shall talk about LVGL touchscreen apps in NuttX and why it might be a good idea to build them in Zig. Typically, we build our touchscreen apps with LVGL. LVGL looks intimidating to NuttX developers, but it doesn't have to be that way. In a while, we shall see that it is possible to make LVGL friendlier and safer when we write LVGL programs in Zig.
Can you listen me?
I can hear you, but we have no sound from the presentation.
I don't know what happened, but during the presentation, I saw the sound like someone muted me, and then the sound disappeared. Are you listening the sound before I
Yes.
start?
When you started the presentation, we had sound and then we lost it.
Yeah, for some way the microphone was muted. I don't know what's happening.
Okay, please restart.
Yeah.
Let's see.
Let's try again. I don't know if it's already in presentation mode. I think
it is in presentation mode.
Yeah, can you see the screen? I will just go back a little bit.
Yes, I can. Let's see.
This
sounds okay.
Yeah.
BL604. I shall explain the challenges of running NuttX on RISC-V. If you like to download the presentation slides, please head over to this link, login.github.io/NuttX. Dex, the letter L, not the digit 1. All my presentations, articles, and source code are available at that link. We shall test our LVGL app on this device, Pioneer Stack BL604 with ST7789 LCD display and Buffalo Lab BL604 SoC inside. We're looking at the touch panel calibration of our touchscreen app. Pioneer Stack has an I2C touch panel. We can see that the touch panel responds correctly in our LVGL app. Let us talk about LVGL. LVGL is a very popular graphical user interface library for microcontrollers. It works great for rendering text, graphics, buttons, and other interactive widgets. In fact, I first used LVGL on a PineTime smartwatch. Then I ran it on PinePhone. LVGL is natively supported by NuttX. It works great with NuttX frame buffers, LCD devices, even touch input devices. There is a demo app bundled with NuttX, but be careful. The code is super verbose because it tries to create all kinds of LVGL widgets. For today, we shall look at a simple LVGL demo that creates a single text label. Here is our super simple LVGL app. It doesn't do much, but the code is actually quite lengthy. Before we create our label, we need to fetch the active screen. This is how we do it. Then we create our label, passing the active screen as the parent widget. Now we set some properties on the label. Our label should wrap the text if it's too long, and our label will have embedded colors. So it will show the text in multiple colors. But wait, we're not done yet. We align the text to the center of the label, and we are ready to set the text or label now. This prints three words: hello, Pioneer, and stack in red, green, and blue. That's because we inserted the color codes into the text. We set the width of the label in pixels. Finally, we align the label to the center of the screen. Let us flip back to the earlier code. Imagine a person writing LVGL code for the very first time. LVGL looks super intimidating, doesn't it? So much repetition, right? LV everywhere, super long function names. What about safety? Can we be sure that these two functions won't return a null pointer? I will probably add assertion checks to be sure. So can we make LVGL coding simpler and safer? Maybe with the Zig programming language? So here is our proposition for today. Let us tweak the LVGL code so that it looks simpler and safer. With a little help from Zig, the newish programming language. Zig is so new that it hasn't quite reached version 1.0 yet. There are some limitations. I shall explain in a while. Zig works well with C, so importing LVGL types and functions into Zig is a piece of cake. Zig will check for null pointers and other runtime problems that we commonly miss, so our LVGL app will actually become safer. Zig can infer missing types from our code, so there's less repetition and clutter in our code, easier to focus. Zig will even automatically convert a program from C to Zig. The converted code looks long and verbose, but it's a good reference for studying the nuances between C and Zig. So you might be thinking, hey, I'm not familiar with Zig. You know what? I'm new to Zig too. We'll explain all the Zig features in this presentation. Let us take a peek at our Zig code. We no longer specify the LVGL types, like for screen and label. Zig infers the LVGL types for us, so our code looks less cluttered. Notice that we use try when calling the LVGL functions. This is how we handle errors in Zig. If any of these functions return an error, the execution stops, and the error is returned to the caller. This is why we specify the return type with a bang, exclamation mark or exclamation point. This means that this function might return an error. Nice, tidy way to handle errors. The rest of the code looks similar to C, except that we move label to the front so that it appears more object-like. We shall explain later how we did that. The plus here is for string concatenation, but it works only for constant strings at compile time, so it is safe. When we compare the C and the Zig versions of our LVGL app, the Zig version looks simpler less repetition, less clutter. Yet Zig is actually doing more behind the scenes, like watching out for null pointers, underflow, overflow, array out of bounds. If something goes wrong at runtime, Zig will halt our program with a panic message and show a helpful stack trace. Let us go deeper into Zig and understand how exactly it makes our program simpler and safer. First, we talk about C macros, and we change hex define to at C define. So hex define NuttX becomes at C define NuttX. How did we get these defines? We'll come back to this. For C declarations, we change hex include to at C include, which we shall see in a while. How is it possible that Zig can understand C macros and declarations? That is because Zig calls the C-lang compiler to pass C macros and declarations, which makes it really easy to import C functions into Zig. Remember we talked about changing hex include to C include? This is how we do it. With this couple of lines of code, we have imported all the C header files that we need for NuttX, LVGL, and our app. The first two lines look out of place. Types of H and limits of H. I ran into some macro problems without these lines, so I added them. Could be a problem with C-lang. That's all for importing C functions into Zig. No wrappers needed. This is how we call the functions imported into Zig. If we compare the Zig code at right with the original C code at left, they look highly similar because we haven't wrapped the LVGL functions yet. We'll talk more about this in a while. Do you see the dot question mark at the end of the line? Zig will verify that the result is not null. If these functions return a null pointer, Zig will stop our program with a panic message and show a helpful stack trace. To compile our Zig code for the RISC-V BL604 SoC, we run this command. Then we link the object file with NuttX. How did we get these compiler options? We copied them from NuttX, as observed with a make trace. This is what we observe with NuttX and make trace. Here are the options that we copied from GCC to the Zig compiler. Now, what about the rest of the GCC options, like NuttX, NDebug, Arc RISC-V? Well, we copied these C macros to our Zig program as C defined, since the Zig compiler won't accept these options. Earlier, we saw this Zig target and CPU when compiling our app for BL604. What is baseline RV minus D? Well, BL604 is officially designated in RISC-V as RV32 IMAC-F, which means that BL604 has all these goodies, IMAC-F, including hardware floating point, single precision. Now this is almost similar to baseline RV32, which is RV32 IMAC-FD. The D here means double precision floating point. Now, since we don't have double precision floating point, we subtract the D, right? Remove it, but keep the single precision floating point. That's why baseline RV32 minus D is equivalent to RV32 IMAC-F. Things get a little quirky for Zig on RISC-V BL602, since Zig hasn't officially reached version 1.0 yet. The binary produced by Zig compiler says that it's using software floating point ABI or application binary interface. But we told Zig compiler to use hardware floating point. The binary produced by Zig won't link with NuttX because the rest of the binaries are hardware floating point. This is a terrible hack that modifies the ELF header from soft float to hard float. Our Zig binary will link successfully with NuttX after this hack. We tested the Zig app on Pioneer Stack BL604 by Pine64. This gadget is based on the BL602 RISC-V SoC by Buffalo Lab. Check out my presentation on NuttX on the RISC-V IoT gadget, Pioneer Stack BL604. The app begins with touch panel calibration, which still runs in C because we haven't finished conversion to Zig. Then it calls our Zig code to render the line like this. We see the text label with the color text in red, green, and blue. So yeah, our LVGL app runs correctly on Pioneer Stack BL604. This is a demo of our LVGL touchscreen app running on Pioneer Stack BL604. This is a demo of our LVGL 7789 LCD display and an I2C touch panel. We have compiled the Zig touchscreen app into the NuttX firmware. Pioneer Stack is now booting the NuttX firmware. The screen turns pink when NuttX boots. Uname says that this is a recent build, NuttX version 10.4.0. Let us check the NuttX devices. We see the LCD device, LCD0, that is connected to the ST7789 LCD display. Our touchscreen app will render graphics to that LCD device, and we see the touch input device, input 0, that is connected to the CST816S touch panel. Our touchscreen app will read touch input from that device. Let us run the touchscreen app. Remember, this is a Zig app that we have compiled and linked into NuttX, though it still contains some C code. The touchscreen app begins with the touch panel calibration. We need to tap all four corners of the screen to complete the calibration. This is coded in C because we haven't converted the calibration code to Zig yet. The screen refresh looks laggy. Hopefully this will be fixed when SPI DMA has been implemented for BL604. When we tap the screen, the touch input driver captures the touch coordinates and passes them to our app. After computing the calibration, our app renders a simple text label, Hello, Pioneer Stack. Remember the Zig code we saw earlier? This is the output from our Zig code. And that was a demo of our LVGL touchscreen app in Zig on Pioneer Stack BL604. Let us head back to our Zig code. When we last saw our Zig code, we were calling the LVGL API that we have imported from C, which looks long and cumbersome like this. Can we wrap the LVGL API with Zig and make it object-based so that it looks more friendly? This is what we mean. We move the LVGL widget to the front, right? Like this. And we shorten the function names from this to this, so the code looks more sensible. We do this by wrapping the LVGL API with Zig. Inside our LVGL wrapper, we call the LVGL API like getting the active screen. When the LVGL returns the active screen, we wrap it inside a Zig object like this. This Zig object will be used by our LVGL app to perform LVGL operations. We need to do this wrapping for every kind of LVGL widget: buttons, labels, text areas, and so on. It will be tedious, but hopefully worth the effort. By the way, this funny notation with the screen and bar S bar, this means that if screen is not null, then S becomes the value of screen. But if screen is null, then we do the else clause. Remember that we use the active screen to create a text label. We need to wrap this as well. Inside our wrapper, we call LVGL to create a label, and we return it wrapped as a Zig label. Our label allows setting of text and properties. This is how we define the functions for our Zig label. These functions will forward the calls to the LVGL API, right? It looks highly mechanical. Maybe we can automate this so we don't need to write up every single wrapper by hand. We shall come back to it. After wrapping our LVGL API with Zig, we get this neater, tidier version of our LVGL app that we saw at the start of our presentation. This code runs okay and renders the label correctly. But if we try to do anything else in LVGL, our wrapper might not support it because our wrapper is incomplete. To build a complete LVGL wrapper, we might need some automation. Zig compiler can generate a type info JSON that describes all the types and functions imported from LVGL. We could scan through the type info JSON and auto-generate the LVGL wrapper. However, we might have a problem designing the LVGL wrapper because LVGL is actually object-oriented. It supports widget inheritance. Zig isn't an object-oriented language, so mapping LVGL widgets to Zig can get challenging. Now that we have a simpler, friendlier way for our LVGL developer to build touchscreen apps, let's talk about safety. Zig performs safety checks at runtime. If we try to dereference a null pointer, or if our computation causes an underflow or overflow, if we try to access an array beyond its bounds, all these will trigger a Zig panic, followed by a helpful stack trace, which is really helpful for tracking down the bug. Zig isn't memory safe yet. It doesn't have a borrow checker or compile type checking, so Zig might have problems tracking our heap memory. Problems like use after free. See this article for the details. Some of us might wonder, if Zig is really so great, why isn't everyone using it yet? Well, Zig is still new. It hasn't reached version 1.0 yet. Some things are a little rough. This is one of the quirks that we can live with for now. LVGL defines this struct that represents color. This is RGB 565 format. 5 bits for blue, 6 bits for green, 5 bits for red, total 16 bits. Notice that it's implemented with bit views. Sadly, this is a no-no for Zig. Zig will refuse to import struct types with bit views. Instead, it becomes an opaque type in Zig. We can pass pointers to it, but we can't create instances of it, and we can't access the views inside. The workaround is to access the bit views in C, and Zig will have to pass the struct pointers to C. This complicates some widgets in LVGL, like the canvas widget, which uses color type. Since we're running NuttX on RISC-V, let me share some thoughts on the RISC-V ecosystem and how it affects NuttX. Sadly, the RISC-V ecosystem today is severely fragmented. RISC-V microcontrollers like BL602, ESP32, GD32V, FE310 all have vastly different internals. Memory layout is completely different. How we handle interrupts is also different. It's not easy to jump from one platform to another. Now, Buffalo Lab has two families of RISC-V SoCs, BL602 that we've seen earlier, and BL702, like this photo that we see here. Yet, BL702 is so different from BL602 that NuttX won't run on BL702, right? So it gets rather frustrating. I understand that we might be creating a unified makefile for NuttX that will support C, Zig, and Rust. Now, this might be challenging for RISC-V. We've seen earlier that RISC-V needs a special target for Zig, but for Rust, we actually need to provide a custom target JSON that will support hardware floating point on RISC-V, like for BL602. There's one last thing that makes BL602 frustratingly different from other microcontrollers, and it causes problems with a touch input for our LVGL app. You know, when we talk to I2C devices on I2C bus, we need to send the register ID inside the I2C request. Well, BL602 calls this the I2C subaddress, and it mandates that we send the I2C subaddress through a dedicated hardware register. But NuttX assumes that I2C subaddress is part of the I2C data. So right now, NuttX extracts the I2C subaddress from the I2C data. Under some conditions, it doesn't quite work correctly. Perhaps you might need to extend the NuttX I2C interface to support I2C subaddress as a separate parameter. Since Zig has proven to work so well on NuttX, we plan to do more experiments with Zig on NuttX. We are now porting NuttX to PinePhone, this mobile phone based on All-Winner A64 SoC. Why port NuttX to PinePhone? Well, I think it's highly educational to document the process of running NuttX on a real phone, something that we might use every single day. Someday, we might even use PinePhone to teach our students about the internals of NuttX. The progress has been great. NuttX now boots OK on PinePhone all the way to the NSH shell, as we see in the photo here. We have plenty of NuttX drivers and apps to build for PinePhone. We need a quick and safe way to prototype these drivers and apps on PinePhone. Zig might be super interesting for doing this. Check out the progress here. If you're keen to learn Zig, here are some helpful links. Zig Learn is probably the best tutorial for Zig. The Zig language reference is a readable, concise guide for the entire Zig language, which isn't really that big. Many of the Zig features are implemented in the Zig standard library, so we should refer to the official documentation. Zig News has plenty of insightful articles. The Zig community on Reddit has friendly folks who might be able to help if we have a question about Zig. If we need more information about compiling Zig apps and Zig method programming, check out these guides. Also check out my presentations. The first presentation is on Zig programming for NuttX sensors. We explain the compile time features in Zig and how we use them to read NuttX sensors. The second presentation is about Pioneer Stack BL604, the new RISC-V IoT gadget, and how we plan to build Zig apps for the device. I've been using Zig for the past 5 months. Before that, I've been using Rust for a couple of years. To wrap up today's presentation, I would like to share my thoughts on Zig. Zig works surprisingly well with NuttX. Zig can call NuttX functions without any bindings or wrappers.
It was a really nice presentation. If you have questions for Luke, please ask them on YouTube and we will copy them here.
Maybe I could take some questions from YouTube. There was a question about wrappers. Okay, so just to clarify, we have two things we're talking about here. So Zig can natively import LVGL library, from C into Zig. So that's one thing. The second thing we did today was that we actually created a wrapper around that. So there are two separate things here. So there are questions about whether we can auto-generate the wrapper, whether it's any performance penalty for using the wrapper. So let me clarify that if you just import the functions straight from LVGL in C into Zig, that probably costs no penalty. From what I understand, Zig has its own C-lang compiler. It will actually know how to call C functions natively. So think of Zig as a very low-level version of C that knows how to operate with C. The other concern that we have was that the wrappers. So yes, once we can call LVGL from Zig, maybe we can make it a bit simpler, which is why I suggested putting around object-oriented wrappers. So that is the problem here. We need to auto-generate some wrappers. We need to make sure that they perform well. So that could be a separate concern. Right now, this is all very early work. I haven't done a full assessment yet. So I'm not sure exactly how much work it will take to generate the wrappers, and also how much performance penalty there will be. But that is for the work. Yeah.
Okay, you have other questions here? Let's see.
Maybe just one more question from Robert. So there was a question about namespaces. So yes, I understand that C doesn't have namespaces. That's why we need to put the LV underscore everywhere, right? Good thing is that Zig has namespaces. So once we import this into Zig,
okay, nice. By the way, as you talk about LVGL, people suggest we ask the LVGL creator, Mr. Gabor, and I hope I have speak his name correctly. Hello, Gabor. Nice to meet you. Your microphone is muted. Okay.
Hi. Yeah, nice to meet you, and thank you for inviting me. It was a nice talk.
Thank you. It's great to have you here. Thank you.
Yes, we talked with Gabor, right? How is your name in your language?
Gabor. Yeah, it's Gabor.
Gabor.
Yeah.
Okay. I think we have speak with Gabor some years ago when we start to adding support on NuttX. Actually, the first support on NuttX was completely done by Gabor. Gabor himself. He did all the work. I just helped like the Sonic and the little fox. I was the little fox trying to help Sonic, but I was more like following him than helping actually. But he did a great work, and it was really nice to get the LVGL integrated on NuttX, and it opened door for many applications. Just to know, we have a company in Brazil that used your LVGL to create an application in C, and this application is collecting the interact with users and send data to the web server, like a REST application or something similar to that. So it's interacting with a high-level application, server application is writing PHP and so on. So it works really nice.
Yeah, that's really cool.
Yeah, LVGL is very is very powerful, and it is very low end as well. It doesn't require so much memory to run, and it is really good to embedded system.
Yeah, we were building from the lower end MCUs, and now we started to target more high-end stuffs with embedded GPU or even desktop applications with video card. Already we have an SDL rendering backend to really make the most out of a desktop. And I just wanted to say one word about the NuttX integration, because I'm really happy about it as well, because it brought LVGL into the site of Xiaomi, which is absolutely the highest achievement of LVGL to being on the table of such a large company.
Yeah, I don't know. Maybe Donnie can say it if not closed information, but I suspect the new smartwatch from Xiaomi, the S1 Pro, is already running LVGL on top of NuttX, because the interface is very beautiful. And
I haven't seen images about the UI, but I'm very curious and excited to see something.
Yeah, I hope we will discover it and let you know about it, because it's a remarkable information, a remarkable thing for LVGL, because being used in final product like a smartwatch should be really nice.
Yeah.
And
during the presentation, I got 2 questions. May I ask them directly now? Okay. What do you think? What are the advantages of Zig compared to Rust?
Okay, this is going to be controversial. So let me clarify that Zig and Rust, they're really 2 different classes of languages. Rust, I would say, is the ultimate goal. It's the perfection. It's what you want in a memory safe, kind of system. Yes. Zig is halfway there. So Zig is better. I mean, Zig is safer than C, yes, but not as safe as Rust, because Zig doesn't have memory safety. It will not. Doesn't have a borrow checker. It doesn't check that your heat allocation is correct. So you may see right into heat problems. So Rust is the best way to fix that. So I guess in my years of doing Rust education, I've written a lot of articles on Rust. I tried to promote Rust. It's a very tough sell. I find that a lot of people are quite resistant to moving to Rust because it's just way too different from C. To create, actually 2 years ago, I tried creating a wrapper for LVGL in Rust. So I had to go through the whole thing of creating the wrapper automatically and all that. It was actually quite tough. Versus Zig. Zig is quite low level, similar to C. Importing LVGL into Zig is just importing the header files, and it just works. So I see that Zig might be hopefully it'll be more friendlier to C programmers since it actually consumes header files easily. And also I'm hoping that Zig could be a slippery slope outwards, because once you move to Zig, you notice that the syntax is actually quite similar to Rust, except it doesn't have all the complicated stuff like lifetimes and traits and all that. But I think once we move people to Zig, people might be interested in also moving up to Rust, as an upscaling kind of thing. So So for embedded programmers, I feel that Zig is a better solution today. Ultimately, if we can move everybody to Rust, that would be great too. Yeah.
And do you know how the performance compare? I mean, the performance of Zig and Rust.
Again, it's quite hard to compare the two. Zig tries to be very much similar to a C compiler. It's very low level, so that's why it has C-lang embedded inside, and it can actually import C functions. So the kind of code that it generates is actually like direct C calls. Rust, on the other hand, you have your borrow checker, you have your other kinds of checks and all that. So I would think that the performance profile might be a bit different. Depends how well the wrappers are created. Also, one thing to note about Zig is that it has runtime safety. So it will do, by default, checks like overflow, underflow, array out of bounds, null pointers. But you have the option to disable them. Okay, so if you enable these options, obviously there'll be some penalty. But I suppose those will be quite minimal. So it's a trade-off. How safe you want it to be versus how fast you want it to be.
Okay, got it. Thank you very much.
Yeah.
The second question is, would you be interested in hosting your Zig binding in some form in LVGL's organization?
Yeah, so that's another interesting question that I have. How could I move a object-oriented structure like LVGL into Zig? Because Zig is not exactly object-oriented. So Zig wasn't designed to be a replacement for C++. It doesn't have inheritance. So it might be challenging. So I'm still trying to figure out how best to map the LVGL objects into Zig. Yeah.
Actually, on the API level, on the highest level, LVGL doesn't look like object-oriented. Actually, as it's in C, it couldn't be true object-oriented. It's just something hacky, object-orienting kind of stuff, but it's completely hidden. It's just an internal mechanism to make widget inheritance and feature inheritance among related widgets easier. But on the top level, let's say if we are speaking about a slider, they have two type of these widgets has two type of APIs. One is the simple object, which has coordinates, can have events, has a position and things like that. and the other API is related to the slider. So for example, I can call a function like LV object set X on the slider, and also call LV slider set value on the same slider. So only the basic object API and the widget specific high level API applies to the widgets.
So today, if you are just sticking with the plain LVGL API, we could just simply include the header files into Zig, and it just works, which is what you saw in the slides. Actually, there's no wrapping needed. The wrapper is only needed if you want to build like object-based, object-oriented kind of structure. So maybe you don't even need a wrapper at all. Just call the LVGL API, just import it into Zig by using the C include thing. But we have a problem today. So I mentioned that Zig is not 1.0 yet. One thing that really bugs me is that the support for bit views. For example, your the color type is based on RGB 565. 5 bits for red, 6 bits for green, and 5 bits for blue. That is not supported in Zig. It will not import that struct in. It becomes what they call an opaque type. I can have a pointer to it, but I cannot access individual views. So that might have to wait until version 1.0, because right now that is actually quite cumbersome. I cannot work with color types directly in Zig. I need to pass it as a pointer to my C code. Let my C do the manipulation and then pass it back. So there are some things like canvas widgets. Canvas widgets depend on the color type. I can't really use that so well. So I have to do it in C. So that is a bit messy right now. We might need to wait for Zig to mature just a little bit until it supports bit views, and then we can handle the whole Zig API.
I think in 90% of the cases, the user doesn't need to know about how the colors are actually represented. We have API functions to create colors from RGB value, hex value, HSL value, and things like that. And they just return a color object. We don't need to know what is inside. There might be interesting cases for the canvas widget where we deal directly with bit manipulations, but I believe we can figure out a workaround. For example, we already have a MicroPython binding which creates a truly object-oriented binding for LVGL in Python, similar to your second concept where we can write label, point, set text. So it somewhat confirms that it's possible, and Python doesn't support bit fields either. So we can manage it on the API level.
Sure. MicroPython is easier to do this because it's a dynamic language. So, but with Zig, it's a static language. So we need to define all these things, at compile time, which might be a bit more challenging.
Yeah. Okay. Anyway, feel free to open an issue in LVGS repository, and we can discuss how to proceed if you are interested, of course.
Cool. Sure. Thanks.
Yeah. Thank you too.
Thank you.
Thanks, guys. We have 10 more minutes until the next presentation.
Okay, thank you, Gabor. Actually, I have one more question to him. Did you, before creating LVGL, did you study some designs or something like that? Because almost all embedded libraries. Sorry? I think I didn't listen correctly, but I think he's busy replying some important call. My question was mostly if he had some previous design work, because LVGL widgets are very beautiful.
Thank you very much. Actually, when I created LVGL only for myself, I designed those widgets and they looked like as a developer designed them. So they looked ugly, actually. And
LVGL is very beautiful. It's very high.
It was, I don't know, 4 years ago or 5 years ago. But since then, I met a guy, a designer, and we work a lot together. Obviously, he is doing the design parts. We are doing services together. He designs UIs for companies, and I'm implementing the UIs. And of course, he helped me to create, more eye-catching, themes for LVGL.
Okay. Now it explains everything, because normally when a guy is a designer, is not a programmer, and then when he's a programmer, he's not a designer, and it's very difficult to have one people that master these two things at the same time. So yes, now it's make a lot of.
I'm also not that guy. I remember that years ago I showed him my most beautiful designs I have ever imagined, and he looked at it and almost started to cry that how to explain to that stupid developer that it's just ugly.
Yeah, I can imagine for someone that has some good design background, it's very difficult to see other simple design like some beautiful thing, because for them they want the perfection, they want something very beautiful. And I think he did a great job, because all the components, all the widgets in LVGL are very beautiful, really nice.
Thank you very much. And during this cooperation, we have found that it's really, really hard to speak the same language for the designer and the developer, because when I said for the project, it's almost ready, because all the functionality was there. If I counted the boxes, it had the right number of boxes. They had the text. It had a nice API, and I said it's almost ready. And he looked at it and said, "Okay, but look at the design and look at what you have done. Okay, but it doesn't matter. It's just a few numbers and colors. Who cares? I can change red to something different red. Who cares? It's just a value. Okay, but it looks like, very bad." And we had a lot of long discussions, because I couldn't recreate the design exactly as he imagined, because I even didn't notice that padding, that color, that, I don't know, arrangement is a little bit different. And actually to solve these issues, we have created the Squareline Studio UI editor, which is quite common for other graphics libraries to have UI editor software. And now we also have one where the designer can put together the UI, and the developer only need to add the functionality. It makes things much easier in the practice.
Yeah. And if you want to talk a little bit now about your IDE for simplify the design that you create, and now it is even easier to people to use it.
Do you mean in Squareline?
Yeah, Squareline.
Yeah, so a few words about it. It was released at the beginning of this year in March, so it's only half a year out. It's not free and open source like LVGL. It's a proprietary subscription-based software, but it is a very nice licensing model. It's very affordable for makers as well, and for larger companies as well. If I compare it with the tools of our competitors, the big difference is that you can put together a UI right inside Squareline Studio. You don't have to create it in Figma or Adobe XD first. You can do it in Squareline, and it's possible because LVGL has a lot of opportunities to style the widgets. You don't have to build up the UI from images. You can create a slider and add gradient, outline, radius, shadow, of course some images as well, and it's quite flexible. So I don't say that what you can do in Photoshop you can do in LVGL as well, because it would be a big lie. But you can do a lot of things, and usually for the basic widgets you don't have to use a UI editor, a graphics editor software, an image editor software. Therefore, if a designer starts to create a UI, he or she can just open Squareline Studio, start to create a UI, set the position, styles, everything, and that design, that project is already a proof of concept, an MVP, and actually a product from the design point of view as well, because that can be exported, and that's it. You don't have to recreate the UI. The UI don't have to be recreated by the developer, and count the pixels and set the correct font and everything. Setting up the animations is a hell, because I remember we always needed to do it together. He seated next to me, and speed it up with 10 milliseconds and change the X coordinate by 3. And I changed it. It just took both of our times. Instead, they could sit in front of his computer, set everything, and just send me the correct values.
Yeah, and now it will be very easy for someone that's not designer to create a very beautiful interface, just moving the components, moving the widgets in the square line. So it will be very nice for developers. Yeah, good.
We're also planning to add some design templates to have a basic, just a basic project to get started with, which already looks good, where there are some good-looking buttons, charts, and sliders and everything. Because, as we talked about it, if developers need to do it, it just won't look good.
Yeah, very nice. And by the way, we just saw Mr. Gregor Nutt is here in the chat. Greg, we send the invitation to the meeting, to the Jitsi. If you want to join us, please come here. And we also invite other people from the community, but they didn't show up yet. So our developers should be here to let more people to know them. And Gabor, thank you very much again for your great library, and also for spending time help us on NuttX community to get LVGL integrated on NuttX, and that lets, as you saw, Mr. Lopi Lee create nice demos, nice applications like he did. Okay, thank you very much, and
thank you too.
We are looking forward for the next integration. We want to integrate the LVGL 8.3 or so on to get the square line supported by NuttX as well.
Okay, let's keep in touch.
Yeah, let's do that.
Okay, have a nice day.
Nice day. Nice to have you here. Nice to see you here. Bye-bye. By the way, Bye-bye was still here with us. So, Alin, now we can, I think we have 1 minute.
Yeah, we should start the presentation from Donny.
Yeah, I will start his presentation now about the sensors and micro orbit. Yeah.
And hi, Helen. During you play the show, and I want to say something.
Yeah.
First is that thanks, Gabo. We're happy to get some prize from Gabo about we are using such like LVGL or something. So really, we are really appreciate to get that. And also, our team member will also contact Gabriel later, and we'd like to send the Xiaomi Watch S1 Pro and to Gabriel, let him to experience how to use it by his own, and to experience how we did on this smartphone. Yeah.
Oh, nice! Congratulations, Don, for this support to adding LVGL in smartwatch, and congratulations, Gabor, to receive now the proof of concept of your project, the smartwatch running your graphical interface.
Yeah,
So,
sure.
thank
And
you.
also, and also another thing is that the first thing you mentioned in the beginning, that so I maybe I make a mistake about answering questions, is that you're asking if the user can flash the smartphones, right? Actually, I need to make it more clear. It's more like that for the third-party developer, currently they cannot just flash the NuttX, the new version of NuttX to the smartphone, because we also get some signature inside, and also there's some security privacy, or some privacy inside to protect the user's data. So it may be currently it's hard for third-party developer to get in touch with the system inside about this smartphone, because we also consider some smart security issues. But maybe for the later, of course, maybe also with some company issues. But for the later, maybe we'll release some develop board or the virtual same environment for the developer to get in touch with smartphone, and to get make some third-party development, and to make some extension on it. Yeah, I think maybe later as we've got some announcement on it. It's also all about the company issues, so we also to get some limitations from the company.
Thank you for the clarification, Donny. We are looking forward as developers into being able to tinker with the smartwatch.
Yeah, sure. And I think now maybe Alan, could you please play the presentation?
I will play your video. Just to complement what Alan said, I think we can. I think it should be nice for Xiaomi to think like an Android phone and let users to do that. Okay. Hello, Greg.
Hello, Greg.
Hello. Nice to see you. Can you hear? Hello.
Good morning. Yes, I can hear fine.
I think it's very early on your side, right? Maybe.
It's about 8 o'clock.
Oh, yeah, not so early. I was thinking it's even early. Okay, I will play now the Donny presentation. Just a second, guys. And so after that, we will talk more with NuttX, with the NuttX father. just a second. Okay. I need to close my. Too many tabs open. It's very difficult to see here, but just a second. Presentations and sensors and micro orbit and open display.
Hello, everyone. This is Donny from Xiaomi Vela. It's my great pleasure to share today Vela sensor framework and the whole process of its design and
I cannot see the presentation yet.
Yeah, I'm figuring out yet. Just a second. I need to select the presentation. NuttX. Okay. Can you see now?
Yes.
Oh, great. So let's play.
Hello, everyone. This is Donny from Xiaomi Villa. It's my great pleasure to join this online workshop today. I'd like to share Villa sensor frameworks, which I've been working on this year. Now, this framework has been applied to hundreds of thousands Xiaomi products, and I have updated all this feature for the NuttX community this August. Let me tell a little about myself first. Before I joined Villa, I worked in embedded systems for several years in Xiaomi's Tencom, especially in the sensor and IoT domain. I'm engaged in Android mobile phone BSP, Linux device driver, library palette flight control integration, and ground control data transmission development. Now, I take responsibility for Xiaomi Villa sensor subsystem, file system, and another kernel components. There are 12 parts in my share today. Villa sensor framework and the whole process of its design and optimization. Then, I'd like to introduce URB and how it works. The third part is made about NuttX sensor driver, which contain multi-user access, multi-core communication, and others. Besides that, I'd develop a common programming model, which make application developer easier. Also function display on Xiaomi Watch S1 Pro in the last part. The original design of NuttX sensor driver is quite simple. Application gets sensor data via system call with device node. However, as more and more drivers are developed by different developers, the control method, type definition, data structure, and the data units vary greatly, even for the same type of sensor. That makes a big mess for application developers. They need to write a lot of different code to adapt to the hardware. In other words, there is no abstraction layer like an Android have between the application and the driver. This condition makes underlying hardware information exposed to the app layer directly. Besides that, most drivers don't support multi-user access. Based on research on mainstream RTOS, PX4, and sensor framework for Android, the current sensor framework, which functionally on performance, has surpassed other RTOS. The framework with intelligent, flexible, low-power feature. For better understanding, I've listed the hierarchy of Android sensor framework on the left. We are grounded twice in the framework design. The first time, we introduced PX4 URB as the soundbound interface for the entire framework. We are using RP Messenger Extension 8. The URB channel class that provided multi-core abilities to manage all hardware sensor knowledge. The local service sensor manager is designed, which will select optimal sample rate according the user subscription, open the sensor automatic, call the URB interface to publish the topic, and close the sensor. The subscription is finished. Similar to Linux sensor subsystem, the NuttX sensor driver is divided into up half and low half. Among them, the low half is used as the master interface to interact with hardware. Unfortunately, when we used the framework in a resource-constrained MCU, we finally decided to reject the framework because of basically the C++ too bigger, too many tasks, too many memory copies for topic release, and some other internal requirements. We reject the URB with C language first, and move its main function to the up half of the sensor driver, remove local service sensor manager, and publish topic data directly from the driver lawyer, which could reduce twice memory copies. Besides, we implement RP message law hub to expand multi-core readability ability. I will give more detail on internal implementation later. The roadmap shows some key points of VLA's sensor framework development, which follows the needs of product. The first version is used on the audio speaker launched in August 2021. It's used for transmission of audio PCM stream between multi-core. In the Watch project, the framework was refactored for the second time. The Watch S1 Pro was launched on August 11 this year, and the feedback is pretty good. In addition, a number of upcoming products will also apply the sensor framework. The following are some important capabilities of this current framework. First, we support access to multi-types of sensor: physical sensor, virtual sensor, and remote sensor. Second, define event data structure and data unit of sensor to better processing and transmission between multi-application. Simple sensor operation set. Support multi-user access. Support multi-core access to remote sensor. Support sensor simulation in PC environment. That's brief intro for VLA sensor framework. Next, I will take a quick introduce to URB. URB means Micro Object Request Broker, which is the important middleware in open source flight control PHR4. It's PubSub-based message bus for multi-model subscription and description of data, and it is the internal implement based on shared memory that rely on threads, workers, and log, and low latency data exchange, small memory footprint. In URB, the topic describes the characteristics of something. The method is used to describe the topic structure, and the advertiser is used to advertise the extent of topic. Every topic supports multi-instance, and it is independent of each other. Why URB? This is a complex message shared in multi-core IoT device, and URB is designed for subscription description among multi-model. You can see PHR4 URB graph in PHR4. Almost all messages between models working in the way of topic subscription and publishing through the URB bus, similar to IoT device. URB is middleware designed based on C++. Each topic is URB device node object, which interacts with the device node through CDV driver to complete behavior of subscriber and advertiser. URB manager manage entire URB contact. URB device master manage all URB device node objects. In PX4, all flight control units and drivers are ready in C++. So, URB provides many callback class. User program can work by inheriting this class. However, this design is different from NuttX concept. The CDV driver is implemented in the user space, and too many derived class cannot be used in NuttX. So we refactor it. There are 7 key points of URB change by VLA. Refactor URB in C language and reduce memory footprint. Implement CDV driver into the kernel space and remove extra buffer, which is more simple. Add the way subscriber and advertiser can monitor each other, let the system automatically choose the most power efficient way to work. Support for multi-core subscription and publishing. Support sensor batch mode and enhanced download sample. Next, I want to talk about the sensor driver. The picture shows detail of entire calling process of sensor driver when the user calls the UORP API to operate device node. The bottom part is sensor entity, include hardware sensor, virtual sensor, and remote sensor. They interact with the driver through a low-speed bus or RP-message IPC. The above is sensor law hub, which is divided into two layers. The law layer is sensor law hub, which may interact with the sensor hardware, complete specific behavior through the sensor operation set, and the response to up-layer action. The other layer is sensor RP message hub, which is used to receive subscription, publication, and control information from other ports. Provide a framework with multi-core access abilities connected to law hub with sensor hub. It provided the generation ability of each sensor driver, such as register device node, implement file operation set, with buffer management, low power management on simple, and multi-user access. Therefore, when the application calls the URL API to operate the device node, the kernel will first call the sensor hub. The hub will decide whether to call the law hub operation set, and then law hub will first call the RP message operation set to confirm whether it needs to notify the remote call. Finally, the physical law hub is called to control the sensor hardware.
Alan, please mute yourself.
The sensor-driven framework of different systems and platforms always revolve around
when I mute, I think the audio stop.
Yes, and otherwise all the noises from your place are on the presentation.
I'm trying to stay in silence, but I am looking for other power supply to other computer because I need to fix the form to the participants.
Yes, please rewind back 10 seconds and let's continue.
Yeah, I will return a little bit and we will continue. Sorry
Thank
for
you.
the noise. Yeah.
The driven framework of different systems and platforms always revolve around sensor feature, and so does NuttX sensor. For the sensor, the general operation have open-close, initialize the range, resolution, filter, set the simple rate, configure hardware FIFO and working mode, trigger calibration. Based on the actual application and the reference of other systems, we have selected several key points as the sensor operation set. For other visual dynamic change requirements, they can be used as initialized parameters. The sensor ops of NuttX include open-close, activate, set interval, bench, self-test, calibrate, set calibrate value. In addition, the driver developers can obtain sensor data in 3 modes: interact, polling, and fetch. When data is ready, call push event and notify event to notify up half. Since the RP message log half is used to send or receive subscription, advertisement, data push, and control message from remote call. Inside the driver, between each pair of calls, the remote subscriber is called step, and the remote advertiser is called proxy. They are responsible for synchronizing message between the calls and support many-to-many synchronization message. When the topic is first advertised locally, the RP message hub will broadcast the message to all other calls. When other calls receive this broadcast, if an application subscribes to the topic, a proxy will be created to represent a remote advertiser, and the information in the broadcast message will be bound, include which call it comes from and the advertiser cookie information. After that, the reply will be sent to the local. The local will be create step, represent a remote subscriber, and bind the information in the relay message. After that, when the data is generated locally, the data will be sent to the proxy through the step. The remote control information will be sent to the step through the proxy to control the real physical device. When the remote is finished unsubscribed, the proxy will be destroyed, and the unsubscribed will be broadcast to the local. After receiving it local, the corresponding step will be destroyed. For application, the complete logic is transparent and insensitive. Next section, I want to share some programming model and tips for this development. This model is recommended when the application needs to monitor subscriber or advertiser behavior. For example, advertiser can publish message only when they are subscriber. At this time, advertiser can monitor for PRI events and obtain subscriber status through RP get state. Subscriber can monitor pull-in to get state in time. The model is recommended when developing an application, such as Fusion algorithm, which can decode application through independent topics. In daily development, there are some tips to share with you. Using fixed sensor to simulation algorithm and simulator environment, you can read sensor data from CSV file or USB device. Using sensor test and URB listen to debug issue. With the multi-core capability of URB, the application can subscribe a remote topic to simplify the process. Now, let's see some interesting function display based on Xiaomi Watch S1 Pro. The internal SoC of Xiaomi Watch S1 Pro uses BSM1, which is typical multi-core heterogeneous chip with one M55 core, two M33 core, and one Hi-Fi DSP, 4 cores in total, and around 5 VLA system. The picture is the internal architecture diagram of the entire SoC, and the right part is the core running the VLA system. UORB is enabled on each core for multi-core subscription and publishing. Among them, the sensor core is mounted with 8 physical sensors, run support and healthy algorithm, and publish daily information such as colors to AP core for display. In the whole watch, about 100 topics are used to publish and subscribe between multi-core. which make a great convenience for application development. This is a shell of Xiaomi Watch S1 Pro. I launched in AP Core. First, I will show you the topic and the DEV sensor directory. This topic are used in the AP system. Some of them are virtual sensors, such as sensor accept, which is mounted on the sensor core. I subscribe a sensor cell in 15 Hz by your listening. Subscriber sensor magnet on calibrator and the sensor gyro. And you can monitor active topic for AP Core. Instant subscriber rating and topic set. Then using CU command to launch a sensor core. This active topic for sensor core. This is the parameter. This is timestamp. No, this is temperature. Okay. That closes my presentation for today. Thank you very much for your time. I put my email up there. Please feel free to shoot me any question if you have. Thank you.
Thank you for the presentation, Tony.
Thank you very much, Donny. Sorry about the external noise because I live in a place where there's some people that go to boats and ships to to sail, for sailing in the ocean. So it's very noisy. And if I mute it, it's not good because it will mute the audio of the presentation. So, by the way, after the presentation, also we'll put the final video, and then the original video will not have external noise, so it will be a little bit better to see it later. Hello, Flávio. Flávio just enter here, Flávio Ipiranga.
Do we have some questions for Donny?
Let's see here if we have some questions. I think we have some.
Unfortunately, I cannot open YouTube while I'm streaming.
Yeah, no problem. I can look here. No, I didn't see any question related to the presentation itself. Okay, Flavio just posted he's fixed some audio issues.
Greg, are you still with us? We have 28 minutes until the next presentation, and I think that it's really nice to have Greg with us, or at least he was here 30 minutes earlier.
And then also people can ask questions directly to Greg. Sorry, Greg, go ahead.
Well, I have 28 minutes worth of things to say.
Sorry?
I don't have 28 minutes worth of things to say.
I'm fairly sure that you have more. Please.
It's good to see you all. We've all aged a bit. It's been a while now. So NuttX has been a project for 14, a released project for 14 years. So those who have been here since the beginning are at least 14 years older.
Yes, but it's still nice to see you around us, and it's nice to see the man that started the whole project that gives us fun.
It was a smaller thing originally. It was a hobby operating system. It was for fun.
Can you increase your microphone volume? We can barely hear you.
I'm not sure how to do that.
Yeah, it's a little bit low, Greg, but we understood what you said. Yes, it started as a pet project, right? But it's not anymore because, as you saw, is used by many companies and many successful products.
Yeah, I would say it's mostly a commercial operating, an open source operating system for commercial projects now. It used to be the majority of people who were users like me were hobbyists, just tinkering and wanted to have a fun environment to tinker in.
Yeah, it's true. It started that way, but now many people are using it. So I sorry to interrupt, guys. I think someone else enter here, but I don't know who is the guy. Hello, who is in the meeting? Yeah, I don't know.
Hello.
Yeah, Flavio enter again, and it's a little bit complicated because sometimes people don't use their real name, and Yeah.
Can you please tell us who you are, Rialto?
Yes, please. Yeah. I don't know what to do now. If we can keep this guy, or we need to.
I will kick him out, and maybe he will answer next time.
Yeah.
Sorry, Rialto, we have to know who you are.
Yeah. Okay. So returning to the question about the comment about the pet project, many projects started like a pet, but after some time they just lost the energy and decide to stop working on it. And NuttX, Greg didn't give up the project. He's still working the project for almost 15 years on whole, almost every day of his life. And it's nice when you see the graphic show all the files he was modifying during each day of the year. It is really amazing. I think anyone, any common people like us have this kind of energy to still there working day by day, and I think you did an amazing job. You stayed there in the project. For the first day you started, you release it. After the last day when it was submitted to Apache Foundation, and you still there doing some comments and some suggestions to improve the project. It is really nice. We got a question from Thiago. I put it here in the video, so it will appear in the YouTube as well. Greg, can you talk about some curiosity about the project? What do you say about the most impressive or unexpected use for NuttX? So, what was the most impressive?
I didn't hear you well. The most impressive usage of the project?
Yeah, unexpected or impressive.
Or unexpected use of NuttX.
Well, a few years ago, when it first appeared on a satellite, I was pretty impressed with that.
Yeah,
it'd be interesting to know how many copies of NuttX are actually out there in devices. I mean, people don't talk much about embedded devices, but you'd think there must be millions of copies.
Yeah, it's really hard to get feedback about all projects that have been launched with NuttX. There are some companies that will present in this workshop how they are using NuttX, but others will still be unknown and will remain unknown unless they want to showcase.
When I was working on it, we wouldn't have been. That's not something we would talk about publicly. What operating system we're using. I mean, that's internal stuff, right? You just don't talk. In fact, as an engineer, you would be permitted to talk about that kind of thing.
Yeah. Many companies are very close about what they are doing. I want to share when I was working in a semiconductor company in the past. I was in work for Freescale. Now it's part of NXP. And one friend of mine said they are in the past for iPhone, the first iPhone, they was evaluating IMX processor at that time. And he said internally on Apple, it's not like a normal company where the same guy developing the application can see the interface and so on. And so the guy working in the driver didn't see what the guy in the interface was doing. And then he modified the driver, sent to the guy testing. The guy verified, oh no, it's still the LCD is still flickering, so you need to fix it. And it's crazy. It's the same company. Why they want to keep it completely in secret? But I think Steve Jobs was really crazy about this, about keep the things as hidden as possible until the last minute. Yeah, and I think many companies using NuttX also do the same. So sometimes it's difficult to know. For example, even here in Brazil, we have a case of a company using it in a product in a very very big product, a very nice product to let other companies to know, but they didn't announce anything about it. And then I push them back in LinkedIn in order to make an announcement about it, because when a big company say they are using NuttX, it opens doors for a small company to start to use NuttX. And sometimes many companies don't use because they think, there is nobody using this RTOS. Why are we use it?
At the same time, with the larger companies, there's no reason for them to advocate that smaller companies use the operating system either. It's not to their competitive advantage to have other people using the same operating system.
Yeah.
Well, you can make an argument that it is, but we don't often make that argument. I mean, that argument is the open source argument of sharing technologies and co-developing things across industry. But that's a pretty hard sell inside of an industry.
Things are improving nowadays, but if we look even 10 years back, even companies using Android as their operating system were not upstreaming patches and working together. Well, now if we look at the Google AOSP, or if we look at the kernel itself, the big players are helping each other so that the product gets a better commodity. Because in the end, all of them will maintain the same patches forever instead of doing innovation on the platform. So the things are evolving. At least this is my personal opinion. But it will still take time until companies will brag about the fact that they are using open source and invite other big companies to use the same open source for a better platform.
Yeah. Okay. By the way, guys, sorry to interrupt. Can you guys turn on the camera just to take a print screen with Greggy and other here? Yerny, Lupi, Masayuki, Michael, I see you here. Donnie, Petro. Hello. Petro is a little bit dark on your side, but yeah, maybe you need to turn the camera. Yeah, it's better now. Flavio and Donnie.
Can you hear me?
Yes.
But we cannot see.
Sorry, I don't have camera in this setup. If you want me to leave just to be a better picture, I can go and come back later.
Don't worry. It was if it was possible.
Okay,
Michael,
sorry for that.
No problem. Michael Young, and Donnie, are you here?
Yep.
Okay. Could you please turn on the camera just to take a picture? Just to say X.
Yeah.
Oh, kids.
Okay. Let me open the video.
Nice. Okay. Very good. Okay, guys. Now we have a picture of the event, and we'll share it later in the LinkedIn and to let other people know about the event. And I think we don't have other question in the chat. So let me ask Greg about his recent baby, the Pascal compiler, the Pascal virtual machine. Why did you start it, and what was the motivation? Or go on.
So I haven't been working on that much recently. It's one of those projects I've been doing off and on for many years. I actually started it back on a TRS-80 Model 1. It was because I'd run across, it was a Model 4, because I ran across this, it was written in BASIC. It was a little single one-pass compiler for Pascal. I had an Algor C compiler, and I converted it to C. And it was a fun little kind of integer Pascal. And it just kept growing, and it's a pretty nearly full-featured Pascal now. Basically, it was just for fun.
Oh, nice.
It's interesting because it compiles to P code, so the P code will run anywhere.
Yeah, and I remember you sent a link for the guy of the one of the C language or the Unix. Kernick, I don't remember his name correctly. He was in 83 or 84. He wrote that article complain about the issues with the Pascal, and then, like you said, he stopped the usage in some way of Pascal. Do you agree with his vision of Pascal, or did you see it's not the way he pictured the thing?
Pascal really has its roots as a teaching language, so it does some things that are very strict and rigid kinds of typing. But when you're actually doing real world programming, when the original language definition were not very good. Things like an array was not a pointer, so you couldn't pass. You had to pass a whole array. You could pass an array by value, or you could pass an array by reference, and as basically a pointer. But it is essentially you couldn't interchange those kinds of things. That's one of his biggest complaints. Mm-hmm. Most of those have been corrected with later versions of Pascal. There aren't very many versions of Pascal that are in use right now, but it's still a viable language. I mean, there's still a lot of so is COBOL.
Yeah. COBOL is a good example of it. I think it's more than 60 years old, right?
Mm-hmm. Well, what attracted me about the compiler is it's a single pass recursive descent compiler. So it's like lightning fast. It's a really good compiler for just-in-time compiling, because you just race through the code once and it's done.
Mm-hmm. More easy to compile, I suppose. Yeah.
Well, it's another case where the language is really designed to make the compiler easy. So it's a fun language. I'm not sure it's a And it was a fun project.
Mm-hmm.
I don't know if it has any real future.
I hope this pet project become a big project as well, just like with Linux Torvalds. The Git system, the control system became bigger and bigger, and now it is used by even Microsoft. So I hope your other baby become a big project as well, because it seems like sorry.
I don't really see that happening. Maybe it's not happening right now.
But it should be nice to use it, for example, to create something that people can run inside NuttX, for example, to run some simple applications, some simple programs. Because I think one thing we cannot do today on NuttX is, for example, we don't have a C compiler that we can run from the terminal, from the NuttX terminal, the NSH, to create the binary inside the NuttX itself. So maybe with
rather small to do that.
Yeah, I think
it's pretty much a full ANSI Pascal compiler.
Yeah, it should be nice. Okay, let other people here to do some questions to Greg as well. So, Aline, what you want to know from Greg that you don't know yet?
That's I don't know if there is anything that I would want to ask him, because I had the pleasure to meet him in person and to kind of ask everything that I wanted. But I would give this opportunity to the other people, because we still have 7 minutes until the next talk. So maybe somebody else wants to have this opportunity.
Okay, Pedro, or the here.
In 2019, we had our last face-to-face meeting, and that was a valuable experience. We should do that again sometime. These online meetings are nice, but we can't go have beer afterward, right?
That is exactly what we planned. After Guda, there was an idea to have this meeting in Japan, and unfortunately Corona came. But we never know when we will be able to travel again, and hopefully we will have you as a guest in person. That will be really nice.
Yeah. So others here, Lupi, do you have some questions to Greg? Because Lupi is a big contributor. He has many nice things about NuttX. So now is your time to ask the man what you want to ask him.
Maybe just one question is, what do you think about NuttX for education? Any plans to teach NuttX in schools, universities? I mean, I think it's a very good, nice to teach kind of OS that students will find it appealing.
I think it's a good educational operating system for some reasons. First of all, it's Unix, which has a legacy. I mean, every computer scientist should know something about Unix, right? No matter what they end up doing. And it's small enough that it's gotten large enough. It's a little too much to comprehend now, the whole thing. But it's small enough you can still get your arms around any subsystem and understand it completely. Like the networking is you can understand all networking with a little effort. I would challenge you to understand all the Linux network. So those. But on the other hand, it has a lot of complexity in it that's intended to make good embedded systems, which is not a good thing to make for teaching. You would like to have everything clean, simple, straight to the point, to emphasize the point you'd like people to know about the software. And you'll find so many special cases in there to work around race conditions or multiprocessing issues that it makes it more than most students would want to deal with. So I say it's got some aspects that are good for teaching and some that are probably not so good. But as far as a teaching operating system, of course, there's I'm forgetting the name. There's what's the one that I won't remember it. There's another POSIX operating system, which is specifically intended for teaching.
Minix.
Linux. Thank you.
Yeah. Actually, the Linux itself started like something based on Minix ideas. It's not a fork of Minix, of course, but initially even the file system was the file system from Minix. Yeah, so Minix is still relevant for education. Yeah.
So when I first got into embedded Linux, I started on embedded Linux company in 2001, and Minix was the kind of the file system of choice for embedded systems, for embedded Linux systems. And I mean, you don't hear about it now, but there weren't very many options. There were ROMFS and Minix.
Mm-hmm. Yeah, Minix FS. Yeah. We have a question here from Koval. Which great concept in computing never took off and were forgotten? I don't know if you understood the question. He just asked more high level question about which great concept in computing never took off and were forgotten.
So this is more just a general computer science-y.
Yeah.
One thing that I thought would never take off is AI, because it's been around for ever and ever and ever and never really amounted to anything. I mean, it's only in the past couple of years it's science. It's if I look over the technologies that are popular, it's mostly been smoke and mirrors, and that's what I thought AI was for many years.
Nice.
Maybe something you could write a PhD thesis on, but nothing that would be real. And now it's definitely real.
Yeah, but actually the AI is now more relevant. But yes, as you said, there is no new concept or new things that change everything. So it is.
Well, it's real enough now that it should scare you a little bit. It shouldn't make you laugh under your breath. It's a little scary.
I personally think that now we have the AI boom because we have hardware that can run it almost everywhere. while if we look many years back, it could only run on big computers. So that, please, Greg.
And if you look at the amount of resources that they require, the resources just weren't available. And
yeah,
I mean, even in mainframes, they weren't available.
I think that we should have we should stop this nice chat, unfortunately, and we should start the next presentation. Greg, if you're around, I think that we can continue with questions from the other participants or even from YouTube. We don't know if you have enough time to spend with us the whole event, or what are your plans?
I'll be around all day.
Super.
Okay, so I'm looking here to start the next presentation. And after sensors, now should be the
TCP/IP from Flavio.
Yeah, Flavio and Pedro. They are already here. Hello, Flavio. Hello, Pedro.
Hello.
Hello. So the presentation will be pre-recorded also, right? Or do you want to, or you present live here?
It's recorded.
Okay. Just to confirm, because sometimes people change their mind and prefer to present live. Okay.
Okay, no problem. Oh, first of all, good morning for you all.
Good morning. And go ahead. I just put your presentation here and we'll start it, okay?
Okay, you can play it.
Okay, thank you. Just a second. Okay, guys, can you see it?
Yes.
Great. Let's put in full screen and play.
Hi there, my name is Pedro Bertoletti, and me and Flavio will show you today the presentation entitled Using TCP/IP sockets as IPC in NuttX to manage multiple LP1 applications and one LP1 transceiver. First of all, let's introduce ourselves. My name is Pedro Bertoletti. I work as technology consultant here in Instituto de Pesquisas Eldorado, and my colleague is Flavio Ipiranga. He works as embedded developer here in Instituto de Pesquisas Eldorado. We both work in Campinas, in one of the cities that Instituto de Eldorado is based on. In order for you to know us a little better, let's talk about a little bit about Instituto Eldorado. Okay. Instituto de Pesquisas Eldorado, IP for short, is one of the biggest research institutes in Latin America, counting today with more than 1,000 employees in 4 strategic Brazilian cities. IP is based today in 4 Brazilian cities: Brasília, Porto Alegre, Campinas, Manaus. As you can see here, left side of the screen, there's a photo of Campinas site of IP. Okay. IP works in state-of-art research and development solutions for the most of the major companies around the world in some key tech segments like oil and gas, telecom, IT, artificial intelligence, agriculture tech, and so on. Now, let's get started. We'll start showing you an overview of our presentation. In this presentation, we'll show you how you use the TCP IP sockets in NuttX as IPC to make it possible to synchronize or talk with multiple applications to send and receive messages from LP1 connectivity. In this case, in this presentation, the LP1 used is LoRaWAN. Our goals here are having a solid and reliable infrastructure to ensure IPC works fine for multiple applications simultaneously, having the possibility to host different IoT products and solutions that use one single ESP32 and that has one single LP1 transceiver, and have the possibility to validate, test, and debug multiple IoT applications and solutions at the same time in a single ESP32. So we can test all of them under the same connectivity conditions, okay? Same signal strength, same antenna, same modem, same transceiver, and so on. Now, let's talk about IPC. For those who aren't familiar with this term, IPC stands for Inter-Process Communication. IPC is a mechanism that allows multiple processes to communicate with each other to get some synchronization between them. This allows processes to exchange messages, okay, or data with each other and get some synchronization, get some message exchange, and etc. IPC can be done in two ways. First way is by shared memory between processes, okay? And the second one is by exchanging messages from app to app. So in this second way, messages are exchanged between one app and multiple applications, okay? So this is a more safer way to exchange data between different applications and processes. Here in our presentation, in our solution, we use the IPC method by message exchange. As you can see in the picture here in the right side, IPC works like a message bus, okay, allowing bidirectional communication between multiple processes or applications. This approach raises some requirements, like each app or each process must have a well-defined address, and all messages should have some kind of integrity check, okay, in order to ensure the content sent is the same content received. All these requirements are covered by TCP/IP sockets, okay, as we will talk a little bit later in this presentation. Now let's talk about how IPC and limited and shared resources combined can be a good thing, can be useful. IPC is a valuable resource in situations where a limited resources must be shared in a safe, controllable, and reliable way between multiple processes or applications. In this situation, the limited resource here is directly controlled by one central process or node, as you can see in the picture on the bottom side of the screen, which receives requests for all other processes or all other applications and processes them in a safe and reliable way. In the solution we were working on here, in this presentation here in Eldorado, we choose to use LoRaWAN as LP1. So LoRaWAN connectivity is the limited resource here. In this case, if you look closely, the IPC works like a star topology network. Okay, in this the network topology or in this IPC topology, the central node accesses these limited resources, in this case LoRaWAN, in a safe way, ensuring there won't be two or more simultaneous access to these resources. So the central node is that node that controls these limited and shared resource. Okay, this limited or this shared resource can be anything that it's not safe to share without any kind of control, like GPIOs, like transceivers, modems, and so on. Also, there is a strong plus when using IPC for this goal shown here. The message exchange between the apps or the process and the central node can carry more things than just the message itself. It can carry integrity checks, message flux control, and security check elements. So it strengthens the communication between the app and the central node. As we said before, in our solution, limited resources is LoRaWAN, okay? And now as LoRaWAN is a limited resources, IPC used to control it, as we are proposing here, is justified. But why LoRaWAN it's a limited resources? Why it should be controlled by a central node? Okay, let's talk about some key points and main points about it. Okay, first of all, LoRaWAN transceivers usually have one communication interface, normally wired. So if more than one process tries to access this interface at the same time, it won't work. So the access to a LoRaWAN transceivers must be centralized or must be controlled by one node only, by one app only. Second point is LP1 connectivity plans usually offered in market, and LP1 protocols are designed to allow only few messages a day, which each message contains only few bytes. I'm talking about 10, 12, or maybe 20 bytes in the most cases. So this should be controlled, the amount of messages, the volume of data sent, okay, and received, in order to make sure connectivity plan will last for the desired amount of time, for a month, for example, and ensure all messages are sent correctly. So this technique to use IPC as a control for this LP1 resource ensures LP1 doesn't run out before it is expected. Okay, so it ensures LP1 connectivity will remain until the end of the time period it must be. And finally, access control. LP1 modems and transceivers configuration parameters are a little bit tricky to adjust, mainly considering it relies on where the transceiver is in the signal strength, SNR, and etc. So if some app or some process tries to change configuration, if it has this possibility, troubles can be. We will see troubles. Okay, we are in trouble. So to avoid problems in connectivity due to misconfiguration or something like that, it's mandatory that the central node or only one node, one node in the network controls the LoRaWAN transceiver and configures it. Okay, so this is mandatory for a good connectivity usage. Well, as we said before, we use IPC to ensure some security, some safe in our communication. Okay, so we are talking now about TCP/IP sockets. Why to use TCP/IP sockets in IPC? Okay. First of all, no additional message integrity verification is needed because TCP/IP already uses 16-bit CRC. So some protocols, some industrial protocols, for example, like Modbus TCP, relies on that too. So as long as TCP has has already the integrity check, so no additional message with integrity verification is needed. Second point is communication and addresses are well defined by design. TCP/IP works with IP addresses and ports, so it ensures message will reach its destiny correctly. Okay. The third point is TCP/IP sockets are already widely used in C or C++. There's a lot of libraries, APIs, software, piece of softwares that use TCP/IP sockets now. So it's not hard to establish a socket connection and works with it. It's not new. So as it is widely used in C or C++ programming language, so the developer will have no troubles to integrating it into an application or a process. The next point is some standardly very well-known protocols can run over TCP/IP sockets, okay? Like I said before, Modbus RTU. So if you want to run Modbus RTU into these very proposals we are showing here of IPC using TCP/IP sockets, it will work, okay? So this is a really good advantage considering some very specific applications like industrial applications in Modbus RTU. Next point, IPC will run on a local network, in this case, or in this presentation. So every tool to analyze and help to track bugs or track data in TCP/IP communication can be useful when debugging this communication. So if you sniff some communication using Wireshark or something like that, you can debug or can track the communication and maybe get some success to debug or to fix some tricky bug that is happening there. In the case of application has some bug or something like that. And finally, in the case of NuttX, it fully supports TCP/IP sockets. So putting it all together, we can see that TCP/IP sockets are really useful to be used together with IPC, and this combination is very good for this goal.
Now I'll talk a little bit about the hardware that you use in this project. One of them is the ESP32 dev kit. So this is the main board of the project, and we choose this board because it's very well supported by NuttX and also very known by the community. Another point that's very good about this board is that it's very easy to find in the market and also very cheap one for what this board offered to the developer. So this was the main reasons that we choose this hardware. Besides that, me and Pedro also have this same board, so it makes it very easy to communicate about the tests or the development, since we have the same hardware. And besides the main board, we have the LoRaWAN module that we use to communicate to the LP1. So here you have some specification about this hardware. And note that we have two classes that this hardware supports. In our project, we implement just one, the class A, because this is the one that's mandatory by the LoRaWAN specification. And the other point that we need to pay attention here is the baud rate, because in the next slides I will show to you about some configurations, and you need to use this one at the UART interface that we choose in the menu config. Here we have both hardwares we use in this project. So we have the ESP32 board and the LoRaWAN module. And we also have the connection that we use between them. So we need the data communication, that's basically the GPIO 23 and GPIO 22, that's the UART communication. And besides that, we also have the powering GPIO, so that will connect in the ESP32 board also. To reproduce this project, first we need to have a NuttX environment working in our microcontroller, in this case the ESP32. So we have this link here. In this link you'll find a tutorial made by Sara Monteiro, and in this tutorial you have some steps that you need to make to flash the NuttX OS in the microcontroller. So by the end of the tutorial you should have a completely working NuttX environment, and you can access the system by using the terminal. So after that, you should do the second step, that is configuring the network of the NuttX environment. So in the tutorial that I mentioned before, we used the NSH configuration. So in our project, we need to configure some network features. To do that, we use the NSH configuration. In the first time we tried to configure these network features, we had a lot of problems and a lot of trouble because we are not sure about what config we need to use and what we need to enable, what's the parameters. After we find out this configuration, the network features was a lot of easy to configure, and we just need to use the NetNSH option. So after that, we also need to do one more configuration related to network. Since our server and client are in the same hardware, we need to use the local loopback feature. So to do that, use the command make menu config, so you can enable this option. Here you have an image that demonstrates to us where is the option of local loopback in the menu config. So if you access the network support option and after that the link layer support menu, you show these options to you. So you just need to select the option in the head arrow. Since you use a server application, our project will be very helpful to make this application start together with the NuttX OS. So to do that, we can use a feature in the NuttX that is startup script. So to understand better how this works, we have this link from the official documentation that will explain better about this procedure. And after doing this step of configuration, we also need to enable some features in the menu config. So now we have two images, and one of them is about the file sys that you need to enable. In this case, to this feature, you use the HomeFS, so it's really on file system. And besides that, you also need to enable the startup script feature. So in the right image, you have the support to HomeFS startup script. And beside that, in our case, we choose to use the architecture-specific path, so we also enable this option. In case that you don't want to do this kind of configuration or had some problem following the documentation, you also have another option that is to use this to call the server application in the NuttX terminal. After NuttX is working, you have access to the terminal. So you can use the name of the application, and after that you put the ampersand symbol, similar what you can do in the Linux, so the server application will be running background. That way, after that, you can use the client application, and that should work the same as having a startup script. Besides the network configuration and the startup script configuration, we also need to configure our UART interface to communicate with the LoRaWAN module. So to do that, we need to enable some features in the menu config again. And first of all, we need to enable the UART in the ESP32. So in the right image, we have the menu that you need to select. So go into system type, and after that ESP32 peripheral selection, you should have something like that. As you can see, we have the UART and the UART0 and UART1 selected. So UART0 to debug and UART1 to communicate with LoRaWAN module. And besides that, we also have to configure our pins, so our GPIO pins. So in this case, we use 23 and 22. And finally, you also need to configure the baud rate. To communicate with your model, you use 9600 because the rate that you have in the model you are using. We also can see that we have more than 2 UART interface. So if you need or want to use the UART2, you probably will have some compiler error, because in this version of the project, we can just use the UART1. So if you want to use another interface or are using another board, so take care about this part, and you need to adjust some parts of the code. And now finally have the best part of this presentation, that is a demonstration, which will be presented by Pedro, and Pedro will show to you guys our results, and he will explain a little bit about the code.
Now, let's take a look at a demonstration of using TCP socket as IPC in NuttX operating system. First, it's important to say that the demonstration we'll show here has comprising 2 different parts. One client, which demonstrates the process that needs access to LoRaWAN connectivity, and one server, which demonstrates the central or control node, which controls the access to LoRaWAN connectivity. Okay. Remember, the server part is the one part that actually controls the LoRaWAN transceiver. In this demonstration, use TCP/IP sockets as IPC. The client requests the server to send 2-byte message via LoRaWAN on a short message to test it, and server handles it and gets back to client response if a downlink message is available or not. Well, the message exchange between the server and client are formatted in this custom protocol, which you can see here in this struct. The first field of the struct, or the first field exchanged in this message, is the opcode. The second one is a message size, and the last one is the payload itself, the message, which has a maximum 12 bytes and must be X-string formatted. Well, regarding location of these applications, here are my NuttX environment. We have here SBeans folder, which has the bootloader and partition table binaries, and here the NuttX itself, and here the apps folder, which has the apps for NuttX operating system. We have we put this example, the client and server part, here into examples. The client is named as client TCP, and server is named as, let me check, servidor TCP. Okay. Now let's take a look at the client source code. Let's start with it. First of all, as said before, the client consists of a process or an application that needs LoRaWAN connectivity to send and receive data packets, messages via LoRaWAN. In this case, the client tries to send a 2-byte message, one a short message to test, every 15 seconds. Okay, it's crucial to mention here that it's just a demonstration. Okay, and in practical terms, this is not cool. In real world, due to connectivity plus limitations, we are not able to send message at this rate. So keep in mind that this is just a demonstration. Okay. Getting deeper into the code, here we have the main function, and the first thing it does is to get the arguments passed through by the command line or by its calling. Client source code, client project here receives the server IP address via arguments. So if this IP address is missing, the application must be closed, okay? Because there's not enough parameters. Then, if the client IP address is passed here, the client source code tries to create a client socket. Okay, and if in case of success, it tries to connect to server socket and fill the address structure. Okay, with the IP address passed before. If everything until here goes okay, the software enter is in the infinite loop, which is constantly send server some data and get its downlink message or its response from LoRaWAN transceiver. So it's important to mention here, the first thing to do before sending messages is to format them into this custom protocol we created. So we inserted here an opcode. Opcode U is opcode for uplink message. The protocol message size is 4, and it's 4 because the message passed is 0102. It's an X string formatted, so it has 4 bytes long, so message size is 4. Then message is sent through the client socket to server, and if some bytes return, it waits for some bytes for a server response, and if it has a successful return, it prints and parses the message returned. It prints it to a screen for debug, for verbose debug only. This is all the client code does. As can be seen, client source code is very simple and has no control over LoRaWAN connectivity as desired. So the server part is responsible for interacting with LoRaWAN transceiver, with LoRaWAN modem as desired. Now let's proceed to server code. Unlike the client, server gets no arguments, as you can see here at the main prototype. And also, this code, this server code, is automatically started as background process when NuttX boots, when NuttX starts. So, first thing the server does is to configure LoRaWAN credentials, as you can see here. Obviously, I jammed my credentials, so you can put your credentials, your own credentials here. The credentials needed are application session key, network session key, application EUI, device address, and channel mask. The channel mask is a mask that informs LoRaWAN transceiver which channels should be used. And the channel mask here is also configured for Brazilian channels, for Brazilian allowed channels for LoRaWAN. So if you are not in Brazil, maybe this will change. After LoRaWAN transceiver configuration, the software proceeds to creation of server sockets. Okay, so if it goes okay, the address structure is filled and socket is bind operation starts. Okay, as you can see here. And after bind, it tries to listen for the incoming connecting, pending connecting from client socket clients. As you can see here, the maximum pending socket clients connections defined here in this software is 20. So up to 20 socket clients connections or attempts to connect, it's okay. If it can handle with handle 20 socket clients here. If everything goes okay until here, it starts in an infinite loop where it keep waiting for new connections, new client sockets connections, and if this connection is successful, a thread is instantiated for each client which connected. So each client it's instantiated to a thread and handled in a separated thread. Okay, this thread is described right here. All this thread does here is it listens, it is waiting for data coming from client. Okay, if data has been received, this data is forwarded to the deeper layers of the software. We'll describe it a little later, and the message is sent over LoRaWAN. When it gets back, when the message is returned, when the message is returned, it brings a status message of what happened here. Okay, so if the message size is less than 0, everything got wrong. Okay, otherwise, it means the data sent to LoRaWAN has occurred successfully. So we can print how many bytes has been sent in a response to server, and goes on. So this while true or while one remains executing while connection is active, is working. If read functions returns invalid number, meaning connection has been gone, like 0, that's nothing has been received, or negative number, it means this connection has been detected. So it terminates the thread, and this client no longer exists in server anymore. Now let's get a deeper view of the middle layer, the layer between this server main code and the deeper layer which deals with WARD and LoRaWAN receiver. This layer was the protocol.c. This layer is responsible for taking the client request, parsing it, okay, according to its opcode, and sending to the deeper layer, which is this. We will get a little later. The message received from client, and take it, send it over LoRaWAN. It also it knows, it gets if some downlink message has been received, and after that it formats a response message to be sent to the client by server code, and this message is also formatted in our custom protocol and has an opcode. Here it's downlink opcode. It has a message size. It's according to how many bytes has been received from downlink message in the deeper layer, and finally the message itself formatted in X string bytes. Okay. Finally, the last layer of server code is the WARD LoRaWAN layer. This is represented by this source code, WARD_LoRaWAN_layer.c. The source code handles all WARD data exchange between LoRaWAN transceiver and S32. And the main function in this module is this. All this do is clear buffer, receiver buffer, send the message over LoRaWAN, and waits for some time to a downlink message be received. And it gets everything back to the middle layer, which gets everything back to server. So server has 3 layers. The main layer, the middle layer, which parses the client request, and the deepest layer, which exchanges data, which talks to the LoRaWAN transceiver itself. Now, let's take a look on how it runs on a S32 board. I have here at my side a demonstration hardware plugged in to my computer. So I will access it via PicoCom software. Here we are at NuttX terminal, and next thing I'll do is reset the board. So you can see the verbose debugging coming from server side and have a real good idea of what's going on. Okay, I'm resetting it. As you can see, there are some verbose messages coming from the server side. Channel mask is configured, network join method is configured, and credentials and everything else. And now, server is listening for new client connections. Here at the board, we have a software called Client. This software is the client, okay? So I will call it. First of all, the server here is running as a background process, okay? So let's run the client, passing as argument the loopback IP. So every data will be exchanged here in the local network created inside S32. As you can see, client connected to the server and send some data to be sent over LoRaWAN. Okay, this cycle will repeat every 15 seconds, as you can see. Some seconds from now. Let's wait some seconds. Here it is. It sends again. And if you take a look at the LoRaWAN console we have here, you can see data is being sent. Okay. So the LoRaWAN communication is working as desired. Flavio and I would like to share our contact information, as you can see here, our email addresses. Please, if you have any questions after this presentation, feel free to contact us by our email shown below. Flavio and I would like to thank you very much for watching us. Please, if you have any questions, feel free to ask us
now. Okay, very nice. Flavio and Pedro, very good presentation. Okay, my screen disappeared. It's okay. Let me turn on the camera.
Yes, it is okay.
Very nice. So thank you, Flavio. Thank you, Pedro. It's a really nice presentation. And let's see now if you have some questions. Just a second. We have some. Why using AF iNet instead of AF Unix from our speaker here? Okay.
Okay. Can you hear me? First of all, it's okay.
Yeah.
Okay.
Yeah.
Okay.
Yeah.
There's a thirsty question, by the way. Thank you. AF iNet is a more flexible or more generic interface for sockets. I mean, AF Unix is for bounds or to communicate to special Unix files or special files or interfaces into the OS. So in order to make it more flexible and also make it available to handle with external sockets from external Linux network, we have decided to use AF iNet. So if we can using INET, we can switch between these two options without any changes in the code. We know AF INET is a little bit not so lightweight as AF Unix, but we have this flexibility. So we have chosen this side. Okay.
Okay. Very nice. Very good explanation about the why to use AF INET. So, any other questions? Please feel free, guys, to ask them.
Don't be shy.
Yeah, I think people are thinking what to ask about.
Do we actually have full support for AF Unix in NuttX?
Sorry, I think I couldn't understand you.
Yeah, the question is probably not only to you, but to the complete group. Do we have full support for AF Unix on NuttX?
Oh, I don't know if we had a full part of it. We have chosen AFNet from the beginning, from the start. Anyone here knows if we have AF Unix full support in NuttX?
I don't know the details. Maybe Greg can help us because he worked in the initial support for network. Greg, are you listeners?
Yes.
Yeah, I'm here. I'm coming.
Okay, go ahead.
Just having a little trouble configuring things. I can't see myself. I guess that's okay. I don't need to see myself. I know what they look like. Yes, AF local is fully supported. AF Unix is fully supported. AF local is the same thing. The underlying mechanism is basically FIFOs.
Okay, thank you very much.
Thank you, Greg. Thank you, Mike, for asking. Yeah, I think it's a good question, and if I'm not wrong, I think initially the X11 server using AF Unix, right? Maybe others here can confirm or.
I don't know if it's only a name clarification, yeah, because AF local it may run on something which is not Unix, right? But perhaps there's some difference. But in NuttX, they're treated exactly the same. They're just aliases.
Yeah. I think we have some connection issues, but okay, we got the response, Greg. Thank you. So now, Alin, we have some more 10 or 11 minutes. Yeah. So let's see now how we can organize the things. If you want, for example, if you need that pass the streaming to me, let me know, and then we can have more time to organize other things, because we both are stuck because we need to use the computer and we cannot. And in this time, we don't have others people here help us, because they in the last minute they faced some issues, and then we lost two hosters. So it's a little bit complicated to me and to Ali. I don't know. Maybe Ali, you need to launch as well, or to do something, please.
No, it's fine. If you have to use the computer, I can try to stream also. Stream and play the video.
Yeah, I think other good idea is to ask, like we did last year, ask the people that will present to stream their audio, their video, the presentation, because normally the connection works fine during the presentation because it's mostly static, right?
Yeah. The next presentation will be from Yupu Lee, Visual Programming with Zig and NuttX Sensors. Are you able to stream yourself, or should we try and stream it for you?
Okay, I'm not sure if I can try it. Let me try it. Yeah.
Okay.
Yeah, we still have time, so you can test it now before you do it. If we face some issues, we can handle it here. By the way, guys, if someone in the chat has some questions, or for anyone, please go ahead and don't be shy. You can ask it.
Hi, I have a question for Gregory. Because when I started to work with our company in 2002, we were working with the ECOS operating system, which was very similar to NuttX operating system. So my question is, what was motivator to develop your own operating system instead of extending the ECOS operating system?
Well, it's mostly a hobby. I did it mostly because I enjoy programming. So I've been writing embedded art process since I think the first one was about 1981. And so the thing that motivated me in the mid 1990s was to get a POSIX, a Linux RTOS. So I wasn't aware that I don't think there were any other POSIX RTOSs in the world at that time that I'm aware of. Embedded is actually before embedded Linux. Back then the only operating systems were like PSOS and VxWorks. There was no Linux. There was no Linux either. I mean, I remember using NuttX was already under development, and the first time I ever saw Linux 1.0 was after NuttX was started. So there is no predecessor. There was nothing to model it from. It's just what I wanted. I just imagined the kind of operating RTOS I would like to use and do it.
Yeah, and
I use Red Almond. I use the editor I used. I wrote the spreadsheet I used. I wrote. So.
Yes, and I think you can listen now, right? I forgot to unmute. Yes, I think the ECOS RTOS now is mostly gone as well. I think there is still a eco-centric company working on it, but we don't see many other people talking about it or using it currently. I think the project is not it's still in development. Yeah.
Five more minutes to the next presentation. If there are questions, we can take another one.
Yeah. Okay. Thank you, Robert, for telling me the echo. I think it is because sometimes we start to talk and other people is still talking, and then it creates some like some feedback. So it's normal to happen here. So
if there are no other questions, I have one for Gregory, and I don't remember if he mentioned this one, but I think that it will be really interesting for everybody. What was the first hardware that ran NuttX? Gregory, you're muted.
Greg, you are muted. Greg?
There are also some connection problems. Thank you, Greg.
Okay. Yeah, but that's a connection problem up here. So it ran for a long time. I played with it for a long time. It's just a thought game with just some source files. So it wasn't until about 2001, I think, that I think the first port. I think that was to a TI dual core processor with an ARM7 and a DSP. I tried some other things, and money as a hobbyist, that things were very expensive back then. You couldn't buy JTAG emulators, and there weren't a lot of MCUs. So I tried doing 8051 port. That was pretty interesting. That's like the second port, the 8051, but it never really worked very reliably. Terrible architecture for an artist. I can't remember the name of that TI processor, but it's basically the same one that was used in some early cell phones that had Blitzport to them. That's how I met Alan. Wasn't that how we met?
Yeah.
We were porting.
Yeah. The
name of the project.
TMS 570.
TMS 570 is the name of the ARM7, but when it's combined with the second core, it gets another name.
Yeah, I remember that is it, and the board was Hercules. Also, you have another one, the DM320, or the.
It was an ARM9. That was for I can't remember the name of that project, but there was a video player, and I recorded NuttX to a video player that had that processor.
Yeah, it's a video player.
How did we end up with the Z80 support? What is the story behind that? Because that is a really old architecture used quite for a long time, both by hobbyists and the industrial applications.
So there were several boards that I was working with other hobbyists for EZ80s. And the Z80 port came first on a simulator, and I worked to the EZ80. There actually are quite a few EZ80 boards out there. It's very EZ80 is really popular retro programmer people like me. And so that's how that whole Zilog thing came, was basically supporting other people's projects. Same with the Xeneo Zilog 16-bit processor, and I was involved with the Spectrum XZ Next project, which has a Z80 in an FPGA.
Nice. I'm sorry, we will have to continue the conversation later. Thank you, Greg, for sharing a little insight of history, the part that is really hard to grasp. And for most of us that joined later the project, it's fairly unknown. So probably other people have different other curiosities regarding the history of NuttX. Now, if you're able to play your video, please do it. Otherwise, we will try to do it for you.
Okay, let me try it. Are you able to see my screen?
Yes.
Don't think so.
I can see your screen.
Yeah. If you prefer, Luke, you can share only the screen that is the video, so it will be easier to control.
Okay, let me try that. Let's see. Share. Doesn't seem to be working. Do I need to restart Chrome?
See your screen. Just make the window full screen.
What do you see right now?
We can see the schedule.
Oh, but my video is, let me see, it's a different window. Do you still see a schedule?
Now I see your video.
Hang on. I think it's because my video is full screen. Let me see. Do you see a video now?
Yes. Please leave it full screen.
If I go to full screen, let's see. Do you still see it?
Yes, it's perfect.
Okay, so let me play the video.
We have no audio.
I should play through the speakers. Let me try that. Let's see. Display audio.
A new way to program NuttX sensors.
How about now?
Visual.
Is this okay?
Yes. Thank
you. To teach education classes in IoT. As an IoT educator, I'm always seeking new fun ways to teach about IoT sensors. Here is something I've pondered. Can we take some off-the-shelf sensors, like the common I2C ones, connect the sensors to NuttX, and send the sensor data to the cloud or a local server without doing much coding? That would be a great way to experiment with IoT sensors, with so many interesting possibilities for analyzing and visualizing the sensor data. A sensor network running on NuttX would be so awesome. Maybe we could program NuttX sensors with visual drag and drop. Let's explore that and how it might send sensor data to the LoRaWAN IoT network encoded with CBOR. Our visual programs could be converted into Zig programs. Zig is a newer programming language that works well with C, and it feels highly suitable for programming NuttX sensors. Our vision program shall also transmit sensor data to the LoRaWAN cloud for easier analysis and visualization. I shall explain in a while. If you would like to download the presentation slides, please head over to this link, logyuan.github.io/NuttX. Next, the letter L, not the digit 1. All our presentations, articles, and source code are available at that link. We have a live demo site that you want to try out visual sensor programming. This is all client-side JavaScript. We don't capture anything on the server side. Here's a short demo that shows how we do visual programming with NuttX sensors. For today's demo, I shall use the Bosch BME280 sensor, which measures temperature, humidity, and air pressure. Let us watch a quick demo of visual programming with NuttX sensors. We begin by creating a loop that will read our sensor data every 10 seconds. Next, we create 3 variables: temperature, pressure, and humidity. First, we set the temperature. For the value, we select the Bosch BME280 sensor and we read the temperature from the sensor. We clone this twice to set the pressure and humidity. We tweak the BME280 sensor to read pressure and humidity. Our BME280 sensor uses a different path for humidity. We set the path to sensor humi0. Now that we've read the temperature, humidity, and pressure, let us print the values. This is how we print the temperature, humidity, and pressure. We see the code that is being generated as we build our visual program. We are almost ready to transmit the sensor data, but first, we create a message variable and we compose the message. Inside the message, we will have 3 fields: T for temperature, P for pressure, and H for humidity. Now that we have composed our message, we shall transmit the message to the LoRaWAN IoT. Finally, this is the ZIG program that is auto-generated for our visual program. When we run this on NuttX, it will read the BME280 sensor and transmit the values to the LoRaWAN network. I shall explain the code in a while. And that is how we do visual programming with NuttX sensors. The demo we saw is made possible by BlockB, which is an open source browser-based toolkit that lets us create visual programs inspired by Scratch. Everything we've seen runs in a web browser, all client-side JavaScript, no server-side code. BlockB is customizable with JavaScript. We may create new blocks and support new languages. BlockB doesn't officially support ZIG, so we added a code generator to BlockB to support ZIG code. And yes, we built the code generator in JavaScript. Maybe someday we'll build it in WebAssembly with ZIG, perhaps. Remember this BME280 block that we drag and drop our demo? We created as a custom block with BlockB developer tools. Yes, even creating a new block looks just like BlockB programming. We could have programmed our code generator to produce C code, but it would have taken a lot more time and effort. Take a look at this ZIG code. It reads a NuttX sensor with a single function. But this is no ordinary function. Sensor barrel here is actually the name of a struct type, and temperature is actually the name of a struct field. Some folks call this meta-programming, and Zig makes it possible because of compile time expressions. This Zig code is super compact, easy to generate. To do this in C, we will have to wrap the C function inside the C macro, which looks really messy. You might be thinking, hey, I'm not familiar with Zig. You know what? I'm new to Zig too. So we'll explain the Zig features in this presentation. Now imagine a classroom of students doing hands-on with NuttX and sensors for the very first time. Temperature sensors, air quality sensors, accelerometers, GPS. What is the quickest way to get them on board? Well, let us create a block for every sensor that's supported by NuttX. Just pick the sensor block, drop it into a visual program. NuttX will handle the plumbing for our students, how to encode data and push the data to the cloud. But will our students understand how NuttX works? That's why we review selective details like sensor devices are actually located at dev/UART. So our students will learn this for troubleshooting sensors later. Now this block for the BME280 sensor generates this zip code, which looks neat and compact, might be a big plus for learnability. If you're wondering about the try here, well, that's how we handle errors in Zig. Like if we couldn't read the sensor, maybe because the part doesn't exist. This will stop the execution and return the error to the caller, a lot neater than error handling in C. Remember we talked about NuttX doing the plumbing for our students and encoding our sensor the right way? Well, this block does precisely that. It encodes our sensor data in a binary compressed format known as Concise Binary Object Representation, or CBOR. Think JSON, but smaller and more efficient. The message size matters when we're working with IoT devices. Should we encode sensor data as fixed point or floating point? It makes a difference. We shall come back to this. This block encodes a message with 3 fields, T, P, and H, that will be set with temperature, pressure, and humidity. Here is a generated zip code. This code might look strangely simple. What if we forget a parameter like humidity? What if the parameter is of a wrong type, like maybe humidity is actually a string? With Zig, we can validate this at compile time, so no problems. We shall explain in a while. Compose CBOR will call the tiny CBOR library in C, which shouldn't be a problem because Zig works well with C libraries. Finally, the last step in our NuttX plumbing, sending the data to the LoRaWAN network. LoRaWAN is a low-power, long-range, low-bandwidth wireless network for IoT sensors. By long range, we mean 5 kilometers or 3 miles in urban areas, and up to 15 kilometers or 10 miles in rural areas. But LoRaWAN is also constrained by low bandwidth. We might expect to send 50 bytes in a packet, though to minimize packet loss, we should probably send 10 bytes in a packet. We can send our sensor data to a local LoRaWAN gateway, like ChirpStack, or to a LoRaWAN cloud, the Things Network, which is free to use worldwide, assuming there's coverage. Our sensor data will be aggregated for easier analysis and visualization. This block transmits a message to LoRaWAN, and it will generate this zip code. Transmit LoRaWAN will call the LoRaWAN library in C. But how did we get the LoRaWAN library? We ported to NuttX, the official reference implementation of the LoRaWAN network stack by Semtech. We are keeping the LoRaWAN stack as is, minimal changes, because the LoRaWAN specification is still evolving. Maybe tomorrow the LoRaWAN stack will introduce a new geographic region, say Antarctica, with its own special LoRaWAN frequencies. Because our LoRaWAN stack is implemented as a NuttX library instead of a NuttX driver, we shall simply merge updates from the reference implementation, and voila! NuttX with LoRaWAN will run in Antarctica. Maybe for penguin sensors or something. Our LoRaWAN library has been tested with ESP32 on NuttX. One final thing before we move on. This every block does something every X seconds. It works great for reading a sensor data and for transmitting the data periodically. Right now we call sleep to wait X seconds in a loop. This might not work for some apps. Later we shall explain why we need proper timers and data logs. Now that we've seen the blocks, let us look at the complete visual program. We have an outer loop that repeats every 10 seconds, which generates this while loop. First thing we do is set the loop, read the temperature from the BME280 sensor, and print the temperature. Then we read the pressure from the BME280 sensor and print the pressure. At the right, we see the code that was generated to read the temperature and the pressure. This is how we print the temperature and the pressure in Zig. Next, we read the humidity from the BME280 sensor, which becomes this Zig. Now we're ready to compose the message. This block composes a message with 3 fields, T, T, and H, that will be set to temperature, pressure, and humidity. This is the zip code for the block. Finally, we transmit the message over LoRaWAN, which becomes this zip code. Remember that everything needs to repeat every 10 seconds. We sleep 10 seconds here. And we repeat everything in this while loop that we've seen earlier. This is how an entire visual program gets converted to Zig. We compile the Zig app and link it with NuttX. This is how we generate the Zig library. For details, please check out the presentation, Simpler, Safer, LBGL touchscreen apps with Zig and NuttX. We're ready to run our Zig app. Today we run it on the Pinecone BL602 board by Pine64. This is based on Buffalo Lab BL602, which is a RISC-V SoC with Wi-Fi and Bluetooth LE. We connected a Bosch BME280 sensor so we can read the sensor data over I2C. We haven't connected a LoRa radio transceiver, so the C-band encoding and LoRaWAN will be simulated for today. Apologies to the creator of the sensor test demo. We actually hijacked sensor test and replaced the internals with our Zig app. Here we see our Zig app reading the temperature, pressure, and humidity from the BME280 sensor. Then it composes a C-band message, simulated for now, and it simulates the sending of the LoRaWAN message. This repeats every 10 seconds. So yeah, it's indeed possible to drag and drop a visual program with a NuttX sensor and run it on a real microcontroller with a real sensor. This is a demo of our visual program running on a real NuttX device with a real sensor. Here is our demo setup. We have a Pinecone BL602 RISC-V board connected to a Bosch BME280 sensor for temperature, humidity, and air pressure. We have compiled the visual program into the NuttX firmware. Pinecone BL602 is now booting our NuttX firmware. New name says that this is a recent build, NuttX version 10.4.0. Let us check the NuttX devices. Looks normal. These are the sensor devices on NuttX. Barrel 0 is for air pressure and temperature. Humi 0 is for humidity. Both sensor devices are connected to our Bosch BME 280 sensor. Before we run our visual program, let us read the NuttX sensors. Is anyone watching this familiar with sensor tests? Let us run sensor tests to check that our Bosch BME 280 sensor is working okay. This is how we read the air pressure and temperature. Air pressure is now 1010 millibars. That is close to air pressure at sea level. Temperature is 28 degrees Celsius. Yep, it is warm right now by the Singapore seaside. This is how we read the humidity. Relative humidity is 72%. Yes, it is hot and humid in Singapore. Up till now, we haven't run our visual program yet. But wait, didn't we say earlier that we replaced the internals of sensor tests by our ZIG program? How were we able to read the NuttX sensors? Well, that is because our ZIG program includes the original code of sensor tests, all converted to ZIG. So sensor test works okay for reading any NuttX sensor, and it will run our visual program too. We can see this from the command line options. Sensor test is now a mix of the old and the new, but 100% ZIG. Check out my article on reading NuttX sensor data with ZIG. I explained how we converted the entire sensor test demo from C to ZIG. Now, finally, we run our visual program. The very same visual program that we dragged and dropped in Blockly and converted to ZIG. Our visual program reads the temperature, pressure, and humidity from the BME 280 sensor. Yes, the values look correct. Temperature is 28 degrees Celsius. Air pressure is 1010 millibars. Relative humidity is 74%. Then our visual program composes a seaborne message with the sensor data, which is simulated for now. Then it sends the seaborne message to the LoRaWAN network, which is also simulated. This repeats every couple of seconds and runs forever. Once we have integrated the LoRaWAN library, this visual program will transmit sensor data over the LoRaWAN network every few seconds. Yep, the visual program that we created in Blockly runs okay on NuttX. And that was a demo of our visual program in ZIG on Pinecone BL602 with Bosch BME 280 sensor. When we implement seaborne encoding and LoRaWAN, we will have a complete IoT app that will transmit sensor data to the LoRaWAN cloud like the things that work. With our sensor data in the cloud, we can aggregate the data with Prometheus and visualize the data with Grafana. So many interesting possibilities. Here is a sneak peek of NuttX sending sensor data to the things that work over LoRaWAN. And this shows how our sensor data will be visualized with Grafana. This works great for multiple devices and multiple sensors. If I ever teach IoT again to a class of students, I would love to see them build an IoT sensor network like this with NuttX devices. Now, our visual program might look overly simplistic though. Real-world applications are actually more sophisticated. For example, it's not okay to send a LoRaWAN message every 10 seconds because of the LoRaWAN message limits, we should only send a message every 60 seconds or so, like this second loop here. But if we read the sensor data every 60 seconds, won't the data get stale and outdated? So we should sample the data every few seconds and transmit the average data instead, which means we split our program into two loops. The first loop for sampling sensor data, the second loop for transmitting sensor data. But this won't work. Remember that we use while loops to sleep. The first loop will run forever, and the second loop will never run. We need to fix this with timers and multi-threading. When we implement timers and multi-threading, we have another problem. How will we pass the sensor data from the first loop into the second loop? Well, we will need to lock the sensor data to prevent concurrent access. Right? Maybe use a message queue to synchronize the two loops. In the real world, LoRaWAN messages are also constrained by message size. Depending on data rate and radio interference, we might expect to send 50 bytes in a packet. But to minimize packet loss, it's probably better to send 10 bytes in a packet. So every single byte matters in our sensor data message. One trick is to transmit our sensor data as fixed point instead of floating point numbers. We scale up our numbers by 100 and truncate to integers. This preserves 2 decimal places for sensor data while transmitting them as integers. Thankfully, Block D lets us insert math expressions. This is how we scale up our sensor data by 100. Is it really possible to write any kind of program with Block D? Well, no. Our code generator for zip is incomplete. Some blocks won't produce proper zip code. Assigning a variable twice to the same variable, this won't work because our variables are actually declared as constants. What if we define the variable twice? Once in the outer scope and again in the inner scope inside this loop here. Well, this won't work either. Unique to Zeek is a problem of shadowed identifiers. Zeek will allow this because the A in the inner loop will shadow the definition of A in the outer loop. It's an odd limitation of Zeek. We will have to work around this. In case we're thinking that Block D is good only for simple toy programs, well, Block D programs can get quite sophisticated because it lets us define functions. This is how we call a function, passing the value of A as a parameter. And this is how we define the function that adds the values of its parameters. This will generate valid zip code. It might be useful for, say, computing the average temperature for the last 60 seconds. Remember our BME 280 sensor block and the code that it generates? Let us take a minute to look inside this super function called read sensor. We call it a super function because there are so many sensor things inside it. Like opening a sensor, checking for errors, closing the sensor. Note that we're using the defer statement, which means that the sensor will be closed only when the function returns. By the way, we write underscore equals something when we don't intend to use the return value of the function, like close. Otherwise, the Zip compiler will think that we forgot something and helpfully stop us. Inside our super function, we call iocto to set the standby interval and the batch latency, and then we poll for the sensor data. This should look very familiar to NuttX developers because we call IOPTO so often. Calling it from zig looks exactly the same, except that we insert C dot in the beginning. Then we initialize the sensor data struct in zeros and read the sensor data into the struct. And we return the sensor data. Remember earlier we deferred the closing of the sensor? The closing actually happens here when we return from the function. At the top left, there's something interesting going on. Let us zoom in for a closer look. This code allocates a sensor data struct on the stack and fills it with zeros. But what is the type of the sensor data struct? According to our function definition, sensor type is actually a type passed in as a parameter. If we trace back to the function call, we see the name of the struct, sensor value, which is passed to our function as a parameter. This means that zig will happily let us pass the name of the struct type to a function, and zig compiler will substitute the name of the struct type at compile time. That's why the struct type is declared as comp time. Comp time meaning compile time. You might think, this looks familiar in C, but hold that thought, we got more. The same kind of compile time magic happens when we return a field from the sensor data struct. Field name is the name of a field in the sensor data struct. If we trace back to the function declaration and back to the function call, we see that the field name is temperature. So this code will return the temperature field of the sensor level struct. This is so cool. If you're thinking, we can do this in C too. Well, you're right. In C, we will define a C macro with sensor type and the field name as macro parameters. In the body of the C macro, we insert the entire code of the read sensor function. So yes, it can be done in C, but it will look really messy and difficult to maintain. Definitely not as elegant as zig. One final trick for compile time magic. Remember this code for composing a sensor data message? It looks exactly like a C function that accepts a variable number of arguments, right? Well, in zig, we can process the arguments at compile time. See this comp time assert? This verifies at compile time that we will always have an even number of arguments. So zig compiler will stop us when we forget a key or a value. This inline while loop is super interesting. Zig compiler expands and unrolls the loop at compile time, which means that we can access every single argument at compile time. This by checking whether the argument types are correct. All these features make zig an easier target for automated code generation. Not forgetting type inference, because zig compiler infers these types like F32, CBOR message, based on the functions that we call. So we may conveniently drop the types from our generated code. In case you're curious how Blockly generates zig code, this is the code generator that we wrote in JavaScript that converts this block to this zig code. Blockly is one huge JavaScript project that might be challenging to maintain. Perhaps in future we might convert the code generator to WebAssembly and zig for easier maintenance. Here is an interesting idea that Alan shared with me. Imagine Arduino, but in a visual form, with plug and play. It works like this. We plug a sensor into a breadboard, NuttX will recognize the sensor, and the sensor appears in our Blockly program. So if we connect a few sensors like these, they will all automatically appear in Blockly. Now we can program the sensor blocks with some application logic, and we will have an IoT app. That would be a really cool way to get our younger learners interested in IoT sensors. In this presentation, we have covered many topics. Everything that I've covered is explained in these articles, including the source code, visual programming, Zig and Blockly, CBOR encoding, Prometheus, Grafana, and the things that work. If you would like to download presentation slides, please head over to this link, lutyuan.github.io/NuttX. That's the letter L, not the digit 1. All my presentations, articles, and source code are available at that link. But wait, there's more. LoRaWAN is super complicated, so we need a few articles to cover the LoRa transceiver library, the LoRaWAN library, and how we build a LoRaWAN app in Zig. Now we have a fun visual way to program NuttX sensors and send the sensor data to the cloud. We shall experiment with more NuttX sensors like this interesting all-in-one I2C multi-sensor. There's sensors for light, motion, infrared, ultraviolet, and VOC. That's for volatile organic compounds. Blockly isn't well integrated with the NuttX build process. We might wrap Blockly into a desktop app so that the visual programs generated by Blockly will go directly into the NuttX build. We still have plenty to do, but hopefully someday our IoT students will experiment with IoT sensors the visual NuttX way. Thank you.
Okay, very nice look. Okay, you can just disable the sharing. Clicking the stop sharing button.
Stop.
Okay. Yeah, very good. Yeah. Thank you very much. Look, your presentation is really nice, and I think it will open doors to get more students, more people with some, for example, people that already work with Arduino could use it very fast, or even people that never used Arduino can start with these ideas. It's really nice, really good idea. Okay, so I think nobody has asked questions yet.
I see one question here. Do we have a library for most NuttX devices like ADC, PWM, GPIO, and coders? So I think the answer is that yes, we NuttX supports those devices, but then we need to wrap them in a way and support them in Zig and Blockly. So it's a matter of wrapping it the right way so that we can use ADC, PWM, GPIO, and coders. Yeah. So it's additional work, but technically can be done. Yeah.
Yeah. Okay. Just to complement the question of Roberto, how difficult is to add support? For example, if you don't have PWM yet, so you want to put PWM on Blockly, how difficult is it?
PWM on Blockly. Okay, so first we need to come up. So remember earlier on we did this super function read sensor, right? That exposes the NuttX sensor API as a Zig function. So we will need to do that also. We need to expose it as a Zig function that can be called true Zig. So that shouldn't be too difficult because Zig can actually import NuttX header files quite easily and expose them and call them right away. So that's not a problem. The next part is that we need to do the drag and drop part. When I drag and drop this component, it should call this particular function. So that part is a bit tricky because Blockly is done in JavaScript. So we have to do some JavaScript code generation to handle this generation from blockly drag and drop into zip code. Yeah, and then after that, compile it with into NuttX with the zip compiler, and it should work. Yeah.
Okay, very nice. Thank you for the explanation. Also, Robert Lipp complement the Roberto question. He said he followed your developing it, and it has had a great reception from the public. And it's really nice. I think it needs to be extended. I forgot to enable my camera. It needs to be extended for more universities. People need to start to test and use it. Yeah, it's really nice.
Yeah, thanks.
Okay. We have other participant here. Thiago. Hello, Thiago. Are you here? Can you list us? By the way, Thiago work with me.
Yes, I'm here. Are you listening?
Yes. If you want to turn on the camera to people see you, go ahead. Thiago worked with me in Expressive. So today he will present about his development with the ESP32. He did a great job. He had support to I2S. So now NuttX will be audio support in the ESP32.
I'm sorry, I couldn't open the camera because the OBS Studio is using it, so
okay. No,
it would mess the setup.
Sure, no problem. Yeah, no problem. So guys, now for people watching this workshop, we put a link on YouTube with the presence list for this presentation. It will ask a secret word, just a secret word to confirm you are watching the presentation. So for this presentation, the word will be LVGL. It should be Ziggy because the LVGL was the first one, but okay, just to not make it too obvious. So because the title of the form is already about visual programming, so it will be a little bit more difficult. So we will put later the next presentation form as well, and then those people who was watching at least three presentation, correct, Ali?
Yes.
To participate. Yeah. So if you participate of three presentations today, you can participate of the final raffle of today, and if you participate 3 today and 3 tomorrow, could participate of the final raffle, right, Ali? The smartwatch.
Yes, let's hope that people will be able to join us, and we will have a nice raffle that will conclude the day today and tomorrow.
Very nice. Yeah.
So, guys, do we have a presentation from Thiago now, or?
Thiago presentation will be after the Lua lib UV because we'll have more time.
Yeah, you said today.
That's all right.
Yeah. Super. Then I think that we have roughly 15 minutes.
Yeah.
If Greg is still with us.
Yeah, Greg's still here. Hello, Greg. Also, I Also, I can't believe Masayuki is still here as well. Hello, Masayuki. What time is it in Japan, Masayuki? Crazy. We cannot listen yet.
I think that it's at 1.
Yeah, maybe 1 a.m.
1:45 in Japan.
Almost 2 a.m.
Yes, almost 2 a.m.
Wow.
Oh my God. Wow. It's amazing. Masayuki is a
long runner.
Yeah, he's like Jackson.
He will last until the end.
Yes.
Let's see, do we have more questions for Greg?
Yeah, here in Brazil is 1:45. Robert Lippi also asked about. I didn't understand his question. If it was similar to announce in the early talks. No, the early talks we didn't put the form, so we put only now, and then just to confirm that people stay here. So the idea is to start from now, because we want to see who are really engaged in the workshop. So the idea is to start from now.
There are 4 more presentations today, and there will be the last 4 presentations tomorrow that will have the word.
Yeah. So, Robert, yes, it was your 4th presentation, but you still here, and now you can enter the list, and if you stay just a little bit, like Masayuki, that is in Japan, is still there in 2 a.m., almost 2 a.m. You can participate of the final huffle. So.
Also, I think that we should bring up the rules for the raffle, because there are some small issues. If I'm allowed a few seconds to be able to share the rules, so that people don't wait for forever without any outcome. So the LTE board, as you probably suspect, as the name implies, has a modem inside, and the modem is not certified everywhere yet. We are working to certify it in more places, but in this moment, only people from some regions where the modem is certified will receive the prize. So if you are not from one of the regions in the list, do not enter the contest, because it will be just more work for us. So the allowed regions for us in this moment to provide you the boards are US, UK, France, Spain, and Germany. If you are from another region than the one specified, please do not apply. So again, US, UK, France, Spain, and Germany. We will also add those countries in the form, so that we are sure that you got the message. And hopefully next year we will have more regions where we can ship.
Yeah. Ali, maybe we can use some of the boards from the previous event. Also, just information, I forgot to talk it in the early during the start of the presentation. Some people of the previous event didn't receive the board yet, so we'll find a way to send them to people. It are just few people in Europe. I think 1 people in Mexico, and then we will find a way to send it to them. But for the people here in Brazil, we send for everybody. So everybody receive it. So let me make the rule, Alan, more flexible. Maybe we can let people to do it, and we filter it later, because in the form we have the country of the people, so they can enter, and we will put more some boards from the previous year. I think maybe more. I don't know, 5 boards. We can fix it. And this year we didn't go out to ask for sponsors to give more boards, because we faced many issues last year. There is no easy to find some kind of board. Mainly some STM32 boards are very difficult to find on regular distributors. And then we decided not to do that. We just use the board we have here, and Alan got some board from Sony, but with these rules, because it has the 3G modem, right? Yeah, and it's not certified in some place. For example, here in Brazil, we cannot use this 3G modem yet, because Anatel is like the FCC in United States, or how is in Europe, CE, I suppose. And they need to certify it here in Brazil before let people to use it. So that's it. Koval just gave some ideas. Very funny. I will put it in. Okay, I will put it a little bit.
I would say the same for the people who are in Brazil, actually.
Yeah.
We could take the boards on Rio, maybe.
Yeah. Yeah. Or
that is now with COVID still being around and all the rules that are still in place in some parts of the world. But thank you all for understanding us. It is quite hard to put an event like this up, and also to find time and resources for shipping the boards. We still have issues, and we still had a few boards that have not been shipped, especially in Europe. We are really sorry for the delay, but we will ship them as soon as possible. Most probably when we start shipping the boards for this year, we will also ship the ones that are not shipped since last year. The other important thing is for you to find those 3 words today and 3 words tomorrow, so that you can go in the last raffle for an Xiaomi S1 Pro smartwatch, and run on your list the NuttX real-time operating system. That is a big achievement for us all.
Yeah. And this year we have companion, as you can see in the YouTube chat. Too many spammers, but we are trying to handle it. Okay, I'll put Thiago message also in the YouTube. Okay, Robert. Koval. And guys, the last question to Greg on this slot, because I will start the presentation in 6 minutes. So Hello, Greg. Thiago, go ahead. Do a question to Mr. Greg. What you want to know about NuttX?
I don't know. I would like to ask more, if possible, about the satellite usage of NuttX. Was it done with a nanocube or something like that? Do you know, Greg?
Pardon me? What was done with NuttX?
Thiago,
what do you mean satellite? I didn't send also, Thiago. Could you explain, elaborate a little bit more?
Greg has answered us about satellite, about people who used NuttX on satellites.
Satellites. Okay.
Yeah.
And I would like to know if you have more information about that, if it was using on nanocubes satellites or something like that. Do you know?
Yeah, I can reply. It's CubeSat, right, Greg? It's a small satellite.
The
presentation is a presentation from 2019. You can watch online at NuttX events, I think. Still there? 2019.
Yeah.
2009. Yeah.
So in 2019, we had a really nice presentation regarding this, and you will find it in the YouTube channel. And then you get all the details. I can also check if I still have the PDF laying around.
I think the PDF is still there. Yeah. Bert just reply here. It start a company. It's a startup. Also, I think, I don't remember, it was this year or last year, institute from China also submit support for Spark processor used on satellites, or also in some Chinese songs. I don't know how to say songs. These like a flying object that go to inspect other planets. I think it's sondes. SONDE. I don't know if I pronounce correctly, but it's sondes.
More like a probe.
Like a probe, yeah.
Mm-hmm.
Perfect. Yeah. It's used on probe as well. And these kind of Spark satellites, Spark processors, have some features to protect against radiation. Thank you, Flavio, also to explain this. Yeah, the probe and like a probe explorer. Thank you, guys. Okay, guys, I think we are almost done, right? Any other question, Thiago? It's okay.
It's okay for now. Thank you, Greg. Thank you, Alan and Aline.
You are welcome, and thank you for being here.
Thank you, Thiago, and sorry for wrapping things up. We are close to the slot for Alan. Alan's presentation is next, and he will talk about creating a natural interface game with NuttX.
Yeah, natural interface games with NuttX, yes. Maybe I need to close my camera here. I don't know if it works, because I will need it there in the presentation. Let's see.
Thank you. Please do it.
Thank you, Aline. I will try just to close it here. If it doesn't work, I will close the Jitsi, and then I will enter and use other camera and turn off. Let's see if it works. Just a second. Camera control. Okay. Okay, guys, I will share the screen, and please let me know if you can see it. Presentation.
Not yet.
And now?
Yes, it's fine.
But, yeah, but I think I will not be able to put the camera there. Let's see.
No problem.
No camera.
Leave it as it is.
Yeah. So. Okay. Is everything fine from your side? I think you need to put the presentation, right?
It is already done.
Yeah, it's okay, right?
Yes, let's start.
Okay. So thank you, Ali. Thank you, everybody here to participate and to have me on this event. Today, I will talk about the natural interface game that I implemented using NuttX. So first of all, what is natural user interface or natural interface in general? Conceptually, it's a kind of invisible interface. That means you don't need to have a physical, not physical, but a widget like a button to you click on it. You just use your body, like your hands, or maybe the eyes movement and so on, the voice, and then this interface needs also to be natural to humans. So, for example, when people are playing the tennis in the computer, in the Nintendo Wii, for example, they are using the Wiimote like a racket. So it's a kind of natural. It's natural for humans, and so this kind of device is very nice to create these natural interface games. In some way, we are already using the natural interface in our days, in our normal life, because when you are pinch an image to do zoom in and zoom out, you are already using some kind of natural interface. The best example of natural interface is the Minority Report movie. It's a movie from 2002. That means 20 years ago. And in that game, the Tom Cruise, the actor, the famous Impossible Mission series, he controlled some kind of screen or like a holographic screen in front of him, using some kind of infrared LEDs glove in his fingers. And there's also a nice curiosity about this movie. Some years ago, maybe 2 years ago, the CNN Business did Minority Report Tech 15 years later, and then they show many technologies that was forecast on that movie. For example, self-driving cars, or like meta universe and things like that was already presented on that movie. So, but the most important thing of this movie is, of course, the natural interface. When you talk about natural interface, this is the kind of image that came in our mind normally. So, as I told before, example of device used to create a natural user interface is the Nintendo Wiimote, Leap Motion controller. Recently, it was bought by Ultraleap. Microsoft Kinect. Unfortunately, Microsoft is not using the Kinect for games anymore. It became like a product only for industrial applications now. So they are not focusing on end users. Other nice example is the voice assistant device like Amazon Echo Dot and others. So you use your voice, natural voice or natural interface to create this not exactly an interface, but to interact. So in some way, it's an invisible interface again. Multi-touch screen, as I explained. So in our demo, in my presentation, I will use not like a multi-touch, but like a gesture, just using your hands for left, right, up and down to control the screen or the game in this case. And here, just an image showing all these devices that I talked in the previous slide. Wiimote and the Kinetics and Alexas and so on. And so now let me talk how the idea of creating this game started. Actually, it started about 10 years ago when I installed the F-Droid repository. For those people who don't know, F-Droid is an open source like Google Play or Google Store that allows you to use for open source applications for Android. So if you don't want to use, for example, any of the Google services, you can install the F-Droid in your phone, and in the F-Droid repository, you find many applications to replace normal life applications. For example, if you want to install Firefox, if you want to install some audio recorder or so on, or any other application, Telegram and so on, you find it on F-Droid. So it's a very nice companion for people that want to use open source applications on Android. So that is the game. If you look this game, you see if you move up, for example, if you decide to move up, you put these blue pieces in the middle together. So when you put 3 or more pieces of the same colors, the pieces will disappear, and then it will open the space to have more room to still doing more movement. So in some way, it's a very strategic game. This game is like a mix of Tetris with the Crush Candy, and also like the logic game 2048. So it's like a mix of these three games. It's a very nice game to play, as we'll see later. So why to use NuttX instead of use Arduino or other simple system? Because NuttX is POSIX and it is Linux-like. That means if I create the application, this game, on Linux, I can port it very easily to NuttX. The original idea was exactly that. I want to create the game first on Linux, then after validating and after testing all the features, I will compile it on NuttX, and hopefully it will compile fine and will work as I was expecting. And also because NuttX has a video frame buffer very similar to Linux frame buffer. So if I decide to use the frame buffer on Linux, it will easy to do the same on NuttX. But in the end of at the end of the day, I decide just to after get the logic working on Linux, I just add the frame buffer on NuttX directly. It was very easy. And NuttX has a Linux-like device support. That means if I want, for example, if I want to use a keyboard, mouse, or anything like that on Linux, I could use it the same way in NuttX. Okay. Also, NuttX already had support to APDS996 sensor. I did this port of this sensor, I don't know, maybe 5 years ago. I need to remember, but yeah, probably 5 or 6 years ago. Actually, I used the initial port from a guy that was using to SparkFun. So he implemented the initial driver, and I contacted him, and he accepted to let me to port it to NuttX. So the initial plan was to do it in one weekend. So I think 2 hours was enough to do it, because my first idea was I just need to move some pieces up, down, and what possible go wrong. That was my silly idea. Also, I decided to not analyze the original game source code. As I told, this game was developed initially for Android, but currently this game is not available in the F-Droid repository because it uses a graphic library called Cocos 2D, and this graphic library became outdated, and the developer didn't decide to update it to new version. So we don't have this game anymore in the F-Droid, but we have some say some fork of it that someone did and put in other place, so you still be able to find it in other places. You can download the APK in some other place. It should be an easy game. So as I said, what could go wrong with it? So just develop it on Linux and compile on NuttX. And the first idea was to do it in text mode only, to focus on logic, and then I will move to NuttX and create the interface, like a frame buffer. So my first deception, or my first let's say shock of reality, was because this game is not so easy as I was thinking it was. For example, the game starts like that. Here, instead of using the blocks, I am using numbers to represent the blocks. For example, if a cell has the number 1, it is the red block, red cell, or red square, square. If a cell has the number 2, it will be yellow. If it has number 3, it will be blue, and so on. And the game starts this way. We have a border, like an edge, with the pieces, and the center is completely empty. So if I press the up button, the floor will move in direction to the ceiling, to the roof. But as you can see, my initial issue was because when I move up, it was moving up the seal as well. The seal was removed from the screen, from the table, from the matrix. So I need to figure out how to fix it, how to not to move not only the seal, but for example, if some other piece is just below the roof, it cannot be removed as well. You need to the moving parts, the moving piece from bottom need to stop when it hits a new piece. And the same applies to down, left, and right. So when you move to any direction, you cannot remove the wall. So you need to the moving part need to move until it hits the static part, the wall, the floor, the seal. So basically, it cannot remove a piece that is already in the board. It needs to stay there until we find the same colors, 3 or more pieces of the same color. And then, as I explained, it's like the move should be like it should respect the direction. For example, here we have in the second column we have the number 3 in the roof, and then the number 1 just in the bottom. When I move up, the number 1 will move to up, and then new pieces will appear in the bottom. So as you can see, the number 1 is moving up, and the other pieces that is still appearing will move. And for example, when the number 3 in the third column reach the floor, that means when it's just below the number 4, it needs to stay there. It cannot replace the number 4. So now came the first issues, because initially my idea was to remove horizontal lines and vertical lines. The problem is when I remove it, for example, in the first row, I have 3 pieces of the same colors. But when I remove this 3 pieces, the number 2, for example, this 3 pieces of value 2, the other piece that in the second row, that is the same, that is still the number 2 is not removed because it doesn't have some neighbor anymore with the value 2, because I already moved it to 0. So to figure out it, I create a very simple strategy. If I want to say, if I want to indicate that cell was already validated and already removed, I just inverted the signal. Now, for example, instead of putting 0 at that position, I am putting -2. And now when I compare, I use the absolute cell. And then this way I fix this issue that I was not initially expecting to have. So the same also apply to the vertical lines, as you can see here. And for the vertical line is with number -2 now, and then -3. And after I find a way to remove the horizontal and vertical lines, now it's time to search for triplets and squares. So it was very basic. For example, if I start searching in the first cell, I just verify if the next cell, the next column in the same row is the same value, and later if the next row in the same cell is also the same value. So in this case, I already have a triplet, so I could remove it. And also if the next column, next cell has also the same value, I have one square and I remove it. I put it as a negative value. But we are not done yet, because after some time testing, I realized I was not verifying for inverted triplets. So in this case, I need to ignore my current position and just verify if the neighbor have the same values. In this case, I found inverted triplet. And like people like memes and jokes, we now are using Unicode. As you remember, I decided not to create it graphically initially on Linux, but to make it more visual, more beautiful to play and to use, I decided to replace the numbers with Unicode squares, and the border, the signal plus, minus, and the pipe, I replaced it also with the Unicode to create the border of the matrix. So it became very beautiful and very enjoyable to play this way, because when you are playing with numbers, it's okay, it's good, but it's not so obvious. Maybe you didn't realize the colors so easily like when doing this way. So now to move to NuttX. And as expected, it was just a matter of compilation, and even the raw keyboard, the termios for implement get ch. So this way I don't need to press arrow up and enter, so on. I just use the arrow up, down, left, right, and it automatically get the pressed key and wait for the next key, for the next arrow to be pressed. I don't need to press enter like we normally do when you use scanf or other normal function to read for the keyboard. So I implemented a get character using the termios that was the same used on Linux. So because Linux doesn't have the get ch, the get ch is normally I think it was created by Borland company, is for 80-90 company that developed the Turbo C Pascal, Turbo C, Turbo Pascal, Turbo C, Turbo C++, and they created some some header files, some library call it Conius, and it has these get ch functions. So after the keyboard, now I just need to create a drive for the matrix for EPA 102 is an RGB LED matrix. So my idea was to use it like an LCD display. Then this way I can use any other LCD display later if I want. But also because using it as LCD, I could use frame buffer easily. I don't need to implement any other thing to control the LED. I don't need to verify positions of the LEDs and so on. So it makes everything more transparent. And this is the matrix that I use it. You can find it easily on eBay or AliExpress. So it uses the standard SPI interface. So instead of using the other most common, the people other fruit call it NeoPixel, for example, but it's the WS8202. It's very common for. I think it's 8212. It's very common, but it's not SPI interface. So we need to take care of timings and so on. Actually, it has already support on NuttX, this other WS82102, but it's not it's not nice to use something that's not standard. I always prefer to use a standard interface. That is because I use NuttX, and that is because I use POSIX. And so using SPI is way more easy than take care of signal integrity and so on. So now it's time to implement the LCD. It was straightforward as well, but just a small detail. Normally, when we have an LCD interface, because the LCD interface is based in the CRT, the cathode ray tubes of the 20th century, let's say this way. And normally, at the end of the first line, the next line starts from the left to the right. But because, let's go back here, because it is LED matrix, it will be easier to move from the last LED to the next one. And this is the way the manufacturer of this matrix did. The last LED in the first line is connected not to the first LED in the next line, but to the last LED in the second line. As you can see, if you pay a little bit attention, there is some trace in the lines, and after the last LED, it returns to the next. So I need to find a way to fix it, to invert, and I just did it. So basically, I verify if we are in a even row. If we are, we just copy the right position normally. But if we are in a odd row, we start from the last pixel in that line to the first pixel in that line. So we inverted the frame buffer here in this if-else test. And this is the working LCD interface. There is a video showing it. I will not show the video now. I will show it after the presentation, because this way I don't need to stop the presentation now, and you will avoid the issues here. Okay, but I will show it the frame buffer test and later the game test. And I decided to use this board, the ESP-RS, is a demo board that our colleague Pedro Minatel from Expressive did to the Rust training, and then I used that board. It's ESP32C3, so it's a RISC-V microcontroller, and I connected this board with the RGB matrix with the APDS 9960 gesture sensor. And this is the demo that I will show in a few minutes. And my conclusion, the initial 2 hours became 3 weekends. So it was way more difficult than I was expecting. So it's not a simple game. NuttX proved to be very Linux-like, as you know, and as I was expecting. So it was just a matter of putting the source code in the app repository, create the make files to compile it, and we are done. I didn't face any incompatibility with Linux issues. So it was very nice to validate it. So the original goal was reached. And that is it. I want to thank you guys to stay here, watch my presentation. And now I will do the the demo. Okay. I will stop sharing just a second, just a little bit, just to find to get the video starting here before enable it. Okay, just a second. Okay, this is the, I will share now. This is the frame buff test that I was talking. Just a second. This is the video one. Can you see the video screen?
There is just a static picture.
Yes. Yes.
Yes. I will play it now. Sorry.
No problem. Thank you.
You're welcome. Can you see the LEDs blinking?
Yes.
Yeah. So as you can see, it's very fast to control the RGB matrix like an LCD. Okay. Now I will turn off the screen again. And okay, let's start the demonstration. I will run. Let me share the demonstration. I pre-recorded it to avoid, as you know, all the demos are subject to Murphy law, and I'll put it full screen first. Can you see? Are you guys seeing the? I will play it now, but is the screen appearing?
Yes.
Okay, I will play it now. Okay, let's start the demonstration. I will run the Shift application. And as you can see, it's a little bit difficult to see the LED colors because the LEDs are too bright. So I create this plastic frame with some paper in the top. Now it's easier to see the blocks. And now I will start to play the game. So if I move up, I put together the red blocks, and they are eliminated because we have 3 blocks together. Same here. Moving to the left, I put the green together. Also, another cyan appeared and was removed. If I move down, I put this white together. And same I can do if I move 2 times, I can eliminate more blocks. For example, this cyan blocks in the right. Move down again. So as you saw, it's a very, very nice, very strategic game. And sometimes it's better not to remove the current block and wait for the next next move to eliminate more blocks. And also it's very addictive game. So it's really nice to play. And I think it's a nice game to have in some hacker clubs, in maker clubs, maker offices, and so on. And that's it. So let's go back to presentation.
Thank you, Alan. It was a really nice presentation. Hopefully more people will get an idea on how to create games on NuttX.
It also looks like a piece of art. Very nice.
Yes. He always has this kind of nice LED displays. Last year he had an LED panel with text that was circulating. Really cool. It looks like Alan dropped. We have 20 minutes until the next presentation. If anyone has questions for Greg or for us, feel free. Unfortunately, I cannot see the YouTube, so if somebody can help with the questions from there, I would be grateful. Hey, Mark. Welcome.
Hello. Yeah, I do have a question for Craig. Do you have any measure on how many hours of effort you put into NuttX?
Let me get Alan in. Greg, are you still around with us?
Yes, I'm here.
Do you have any measure how many hours you spent with NuttX?
I don't know if I can come up with a number of hours. I basically worked on it every day, 7 days a week for past, 10 years or so, because I'm retired and that's what I was doing. So I do have 31,000 commits.
We saw them.
And I imagine there's a few per day. So I'm not sure how that translates, but it might give you an idea of the magnitude. So I've heard a lot of people say that, an RTOS is easy. I could write an RTOS in a couple of weeks. And there's some truth to that. I mean, you can do the basic context switching and that stuff in a couple of weeks. But that's not really an operating system, I don't think. I think an operating system is the full environment of which when your program runs in. It's not just a scheduler. And to get a reliable scheduler, I think you have a reliable operating system. I think you're talking about a decade's worth of work.
We had a presentation, actually my presentation that opened the conference today. I don't know if you saw it. I presented the... Sorry, your connection broke.
Oh, I just said it was too early for me. Sorry, I missed it.
No problem. You can see it online. I actually studied how many push requests and how many commits we received in the last 2 years. And unfortunately, I had only the history from 2013 onward. But it would have been nice to see the whole development of NuttX starting with 96, 97 when you put the basis.
It really wasn't under configuration management until 2007. So the problem you're seeing is because it was initially under CVS. And then it moved to SVN for a few years and then finally to Git.
Yep.
So what you're seeing is you're seeing up to where Git started keeping track of things.
Yeah.
And GitHub's not smart enough to track before that. I think that's because there are no email addresses before that. Somewhere along the line during the CVS to SVN conversions, it put a UUID as everyone's email address. But if you use Bitbucket, if you put it on Bitbucket, you can see all the way back to the beginning. Bitbucket's a little smarter at dealing with those kind of inconsistencies in the Git database.
Unfortunately, I didn't check the Bitbucket repository, but you're right. I will do that for the next year. Probably people will like to see how things were at the beginning.
And there isn't really a good track of authors prior to Git either, because I was a single committer system still. So
yeah,
it looks like I did everything. But that's not too far from the truth, because in the first 5 years or so, there weren't a lot of contributors.
Even without the initial commits, you're still number one in the leaderboard. You have the most commits.
Probably more commits than all other committers together, I would guess, right?
I don't remember if that is the case, but he has number one.
I think at 31,000 it's going to be a while. There were a long period of time where there were lots of commits in a day, hundreds of commits in a day, but not over the whole period of the project.
There are some spikes around 2013, 2014, and then things calm down a little, and then they ramp up again.
So I believe.
Sorry.
I was working. I believe that's because I took a job for a while, so I was working. Wasn't working full time for a couple of years. When HP moved their enterprise networking to Costa Rica, they found out I was here, and I got recruited to work for HP for a couple of years to help them get their development organization in place. So I worked for HP for many years, so I was pretty well known, I guess.
That is really nice.
Then I retired for real, I guess. Then after that, about 62. I mean, at age 62, which is 2012, 2013, yeah.
Do we have questions for Alan? Sorry for interrupting you, Greg. I see that Alan is back, and we still have some time for Q&A. If he can confirm that he hear us. Alan, can you hear us? Until Alan is restoring his line, if anyone has some more questions for Greg, we would gladly take them here. Mark, are you having the presentation live?
Yeah, let's go for it.
Okay, we still have to wait 11 minutes. So
okay.
if anyone has questions for Greg, he's here. He can answer your questions. Can somebody help me with YouTube? Are there any questions on YouTube?
No questions. In fact, I think Alan could answer the facts that were rising in there. No more questions from the YouTube.
I still don't see Alan's camera or hear from him.
Alan said he's trying to figure out screen.
Okay.
Okay, I'm fine now because too many screens and monitors open at the same time. So I have the same presentation open in many browsers, in many places. I need to figure out what is the right chat to use. By the way, guys, I just put the link to the Nest presence list. I tried to find the questions you comment. I think it was mostly the Koval suggestion about the audio, right? I tried to see if you have some questions here. Yeah. Yeah, it was the RZR, the Philip Koval, suggesting to add sound support. Yes, that's the idea to do it in that game. As we explained early tomorrow or early this morning, Thiago add support to I2S, to audio on ESP32, and then it will be added to other families later. So yes, that will be possible to do audio. For example, in the original game, when you remove the piece, they do the sound like I'm not good in sonoplasty, but I think people got the idea. It's like it was removed from the screen. But of course, it could be like a explosion as well, because we could add some like. Ali is back.
Yeah.
So yeah, so the idea is to add audio support because it will make the game more fun. And by the way, maybe Koval, if you want to join us, I can send you the link. Just confirm that you want to join us. And Koval presented a few years ago about the web things using the Mozilla web things. It was a really nice presentation as well. And today we'll talk about Mark will talk about the Middle, and Middle also has they are creating a nice library for games as well. So it will be possible to program games in C# on top of Middle using NuttX. So it will be really nice, and they are. He can talk a little bit more about it later. Okay, guys, we still have 5 minutes. So,
did you manage to post the next word?
Yes, I put it there. I put the link in the next word. The next secret word is frame buffer.
Okay, so we still have 3 more presentations, and after that we will have the raffle. You have the chance to find 3 words out of 4.
And just to explain, now we will have a presentation from Mark. Later, we'll have a presentation from Luz, from guys of Luz. It's a distributed architecture. And then we'll have the async scripting with Lua and libuv. And after this presentation of Lua and libuv, Thiago will show a live demo, or maybe a pre-recorded if he faced some issues. But the idea is to show the I2S audio working on ESP32. He got it working, I think, few days ago, correct, Thiago?
Yes. It just worked properly a few days ago, and I prepared an example using audio file being streamed through HHP through the Wi-Fi network. So I would say that is a good fit for the ESP32.
Yeah.
And I really would like to show you live. I hope nothing goes wrong with the live demo.
Tiago, it's really nice that you work on audio. My colleague Koizumi-san has a presentation tomorrow regarding audio, and I think that we will all value your input because we want to try and start a brainstorming regarding the whole audio system in NuttX. So if you can join tomorrow the presentation here with the speakers, and then continue the brainstorming together with us, it would be really nice.
Of course, I will be here
tomorrow. I think that it's time for the next presentation. Mark, can you please start sharing your screen?
Yeah. Ali, I think we have just more few minutes, right?
2 minutes.
2 minutes, yeah. Yeah, maybe he can just start to organize the things. By the way, because you talk about the audio, I think audio subsystem was created by Ken Petit.
Yeah.
I am inviting him to be here with us. I forgot to send him the invitation one before. He is online. Oh my God. I will send you a mail. Okay, Ken?
Yeah, we are sorry. We forgot a few key people in all this organization mess. We ended up being just 2 organizers without backup. So sorry if things are not working really as we planned.
Yeah. And yeah, I try to remember the most contributors, but it's difficult because sometimes we always forget to add someone. And for example, today I forgot to add the Thiago link to this presentation, to this GDC. And then he sent the message, I didn't receive the link. And so I'm sorry, guys. It was really, really difficult to remember everybody.
Okay, I think that it's time for Mark to start the presentation, and we can continue the chat later if that is fine for you.
Yeah, I think we are on time here, and thank you, Mark, to be here, to accept our invitation, also to Middles, and I hope you explain to people what the main idea of Middle, and let them to enjoy it. Welcome.
Okay. Thank you very much. So what we're going to look at this evening is Meadow. And Meadow is a .NET development system, and we are using NuttX as one of our core components in the system. So my name is Mark Stevens. I'm currently working on the firmware for Meadow. The Meadow board is developed and distributed by Wilderness Labs, well, manufactured by Wilderness Labs. In the past, I've been a software engineer, project manager, operations manager, and a few years ago, I decided to return to software development and became involved with Wilderness Labs. And I've been tinkering with hardware and software since the late 1970s, so I've worked on a wide variety of platforms. And the firmware on Meadow is interesting and challenging. So what we're going to look at today, we'll have a brief overview of what Meadow is. This is necessary to give some context. We'll have a look at the .NET development environments and managed applications, in particular how they have been used in embedded systems in the past. So we'll have a look at a little bit at the history to show you where things started and how we got to Meadow. We'll have a quick look at the architecture, some of the hardware, some of the software, to have a look at the various components and how they link together. Then we'll have a dive into some details. So we'll have a look at some of the message processing, some of the components, the operating system components, the stuff we've added to the system. We'll have a look at how those link together. And then we'll finish up with a quick look at what the future holds. So let's start off by having a look at Meadow. So currently there are two boards available to run Meadow. These are both developed by Wilderness Labs. We have on the left-hand side, we have the F7 Feather, which for those of you who are familiar with our Adafruit boards, the Feather format is pretty standard, and so it allows easy connection to a wide variety of other hardware platforms. And then on the right-hand side, we have the Core Compute module. So this has more GPI opens, and it also has the ability to connect through to wide Ethernet and SD card modules. Both of the boards have two microcontrollers on them, as we'll see in a little while. They have 64 meg of flash available for program storage, of which we actually need a few megabytes. I think you get about 60 megabytes to the end user application, because we need a few megabytes for storage and over the air updates. Both boards also have 16 megabytes of RAM. So, you know, the hardware itself is pretty beefy hardware. Both boards are designed to be embedded boards. So we have a plethora of GPIO pins available to the user. So we have 16 16 digital ports. We have a range of analog ports, and then the usual suspects in terms of communication buses. So things like SPI, I2C, UARTs, and I2S. So we've got the ability to connect to a wide range of additional hardware boards. So that's Meadow. So let's have a look at .NET and managed applications. So .NET on the embedded framework has been around for quite a while. So probably became very usable round about .NET Micro Framework around about C# 2, I think. I think that's a version of C# that's available on that platform. The micro framework has since evolved, and a group of people took it over and started running with it and making the Nano framework. There's also another group of developers working on a project called TinyCLR, but both of these have some restrictions. So .NET on managed land, .NET on the embedded land has been around for quite a while. In fact, I got involved around about 2010 with my first .NET micro framework board. Meadow is a little bit of a departure from that in that we're trying to implement the full .NET, make full .NET available. So if we have a look at start off with something like Nano framework, it's really .NET 2. It is available on a wide range of microcontrollers, including some lower powered microcontrollers, and development really is C#. Then if you look at something like a Raspberry Pi, so you've got a single board computer, and as you would expect with a full Linux operating system, you have a wide range of features available to you. TinyCLR, this is also a micro framework derived project originally, I think. It's got a limited number of assemblies and assembly sizes. I think you're restricted to C# as well on this. And for .NET developers, there are things like there's no generics available. So really, we're talking it's not full .NET. So Meadow is an attempt to change that. So Meadow is full .NET Standard 2.1. You can develop in C#, F#, and VB.NET. As it's .NET Standard 2, you can use NuGet packages from off the internet, so both for hardware control and for providing additional facilities, things like JSON parsing, that sort of thing. The system has built-in Wi-Fi and Bluetooth, and this is available through an ESP chip, which is one of the microcontrollers on the board. The platform is designed to be managed through the cloud, so we can do things like over-the-air updates, security, and so on. So for those of you who haven't really done a lot of .NET development, with Meadow, we have the full range of modern languages available through the .NET platform. So you can C# is the one that's quite common. We have a number of developers who are working with F# and some who are using VB.NET. One of the big advantages of .NET is that you don't have to worry too much about memory management. So as NuttX developers, I'm sure you'll all be aware of, allocating memory, freeing memory, and so on, having to keep track of memory, not overrunning buffers, and so on. .NET takes care of all this for you. So it offers a safer development environment. You also have a full range of modern development tools. So on Windows and Mac, you have access to Visual Studio through some extensions. And with Linux, Windows, and Mac, you can use Visual Code as well. So as you can see, we've got the ability to develop on an operating system of your choice with modern tools, and you can use a wide range of additional libraries by using things like the NuGet repositories to pull in additional third-party libraries. As I mentioned, the Visual Studio and Visual Studio Code both require extensions. Once these extensions are deployed along with Visual Studio, you have the ability to develop code on your laptop and deploy through a single USB connection to the hardware. And also you have full access to the usual debugging capabilities that I'm sure you're all used to, things like single stepping, breakpoint, and variable inspection. So the key thing here is what we're trying to do is give existing .NET developers access to the tools that they are used to. and then bring embedded and hardware development into the portfolio, their skill portfolio. So let's have a quick look at the architecture. We'll start off by having a look at the hardware. So both of the boards that I mentioned earlier have two microcontrollers on them. The main microcontroller on the board running NuttX and .NET is an STM32 F7 processor. It's quite a beefy processor. It's running at about 216 megahertz, and we have 2 megabytes of flash built onto the board. This processor gives you access to the 16 megabytes of RAM and the 64 megabytes of flash storage that are on the boards, as well as access to the GPIO peripherals. The STM32 on the core compute module, as I mentioned earlier, has a larger number of GPIOs, and some of those can be used for Ethernet and SD card interfaces, should you wish. The second processor on the board is an ESP32. It's a Pico D4, I think. We have 4 megabytes of flash on that chip, and that chip provides access to both Bluetooth and Wi-Fi. So this is your wireless interface. And these two chips, there's a number of GPIO lines that connect these two chips, and we'll talk about those a little bit later. From a software perspective, we start with the STM32. We have the user application, which is developed in .NET. This uses a number of libraries to provide functionality such as console input-output, memory management, and so on. And they are .NET standard libraries. Wilderness Labs also provide a suite of libraries as well. There are a core set of libraries that allow you to talk to the hardware, or to allow the user application to talk to the hardware. But there's also a number of foundation libraries that provide access to things like temperature, humidity sensors. So if you've got a BME 280 temperature, humidity, and air pressure sensor, we have a library that is available. You just download that library, plug it in, and then you can say, hey, just give me sensor readings, say, every 5 seconds, or give me the temperature tell me when the temperature changes by, say, more than 1 degree centigrade. So these are the Meadow libraries. Underneath this sits Mono. So Mono is responsible for taking the various libraries, interpreting the libraries, because at the moment Mono is providing 3 different ways of running the code. There is interpreted, there is just-in-time compilation, and there's ahead-of-time compilation. So at the moment, interpreted and JIT are thoroughly tested and working on the board. So this takes, the Mono takes the user application, the .NET libraries, the Meadow libraries, and interprets those into an intermediate language and then executes that intermediate language. Now, Mono itself has the components that are living in managed space, but it also needs to be able to talk to the operating system that is running on the hardware. And this is normally, as most people, operating system developers are aware, normally this is C, C++, and assembly code. So Mono provides what is called a platform abstraction layer. And this breaks out the services that Mono needs in order to run, breaks them into some lower level C code, and eventually calls operating system methods. So if you want to read from a web page, the user application may say, give me a HTTP client object and read from this web page. This is broken down into a lower level, a series of lower level calls, and eventually in the platform abstraction layer would end up as things like open a socket to a web server, connect to the web server, read data from the web server, close the socket, and so on. And those lower level calls we're using the Unix lower level calls, which just happen to be POSIX calls. And this is where NuttX fits into through to the ESP32. And that provides Wi-Fi and Bluetooth services, but also we have a group of system services as well. So things like being able to put the microcontroller to sleep, get battery power levels, and so on. So hopefully that's given you a high-level picture of how things connect together. So let's start to have a look at some of the details. So Meadow is running in kernel protected mode. So we have the operating system at the bottom level running in kernel space. And then we have a number of applications running in user space. So we have Mono, including the platform abstraction layer for Mono, that runs in user space. We have a module for connecting to your laptop, so whether that's a Mac, Linux machine, Windows machine. We provide communication through a HCOM communication module. So the USB communication takes instructions from your laptop, and this can be things like, well, tell me what versions of the operating system are running on the board, or it could be, here is my user application, my .NET application. It's been compiled into intermediate language. Take this, write it to the flash. So from the Wi-Fi perspective, we have, as mentioned, the higher level application would say, give me a web page. Mono would break this down into a number of low-level commands, and these would end up in the PAL. With the Unix PAL that we're using, these would map onto POSIX API calls. And as NuttX exposes the POSIX API calls, it gives us a direct connection into NuttX. So with the core compute module, that has both Wi-Fi and Ethernet. So we have the capability of, say, with a network command, sending it through to the wired Ethernet, or we could send it through to Wi-Fi. In this particular case, we're talking about Wi-Fi. So what we did in NuttX is we looked at the user SOC drivers. And we implemented the methods, a group of methods in the function table for the POSIX API. And we mapped those onto code, a method of generating messages that we could send over to the ESP32 for it to actually implement the Wi-Fi for us. And we do that using SPI and some GPIO control lines. Now, as it happens, FreeRTOS also exposes a POSIX network API. So this gives us a nice one-to-one mapping between the NuttX calls into things like socket, connect, receive from, etc., and the same API calls available on the ESP32. But this also presented us with some challenges. So both NuttX and FreeRTOS are multi-threaded, and .NET also supports multi-threaded applications. So we need to make sure that a message from a particular thread in a .NET application, a network request from a particular thread in a .NET application gets the response it is after, rather and not having crossed messaging, not having cross messaging. This is also complicated by the fact that the SPI interface that connects the boards is a synchronous interface. So we have to take messages coming in from multiple sources, feed them through a single synchronous line, and then on the other side we have to break those out and allow those to run asynchronously again to take full advantage of the power of the ESP32. The ESP32 also has an interesting limitation in that the SPI interface on the chip we're using is restricted to 4092 byte per packet. And obviously, if you're making network calls, you could be returning 10K, 30K, 40K, etc. So we need to find a way of dealing with that. So just to summarize the network requirements, we need to support a multi-threaded environment for both .NET, NuttX, and also on the ESP32. We shouldn't block either the STM32 or the ESP32. We could have multiple requests coming in at a time, and also for multiple interfaces. So it's perfectly possible to have a Wi-Fi request going on at the same time as we have a Bluetooth request as well. We also need to support the fact that both the STM and the ESP32 processors can both generate messages. And for anybody who's worked with SPI, I'm sure you're aware that there's only one one component on the board that can be in control of the SPI bus at any one point in time. So we need to find a way of working around this. And in this case, we make the STM32 the controller of the SPI interface, and we need to find a way of making the ESP32, or give the ESP32 a way of indicating to the STM processor that, hey, I've got something for you. You're not expecting this. It could be something like a Wi-Fi disconnect event, but you need to ask me about this, and then you can deal with it. We also, as part of the requirements, we looked at two different types of method calls. So, for instance, something like a receive from as a POSIX call is actually a blocking call. So when from the user application perspective, when it makes a receive from request, it is expecting the result back at the end of the method execution. So compare that to something like a network connection request. You could say, okay, connect to the Wi-Fi, but I know that's going to take 2 or 3 seconds, so just let me know when it's done. So that would be a non-blocking request, whereas the receive from would be a blocking request. So we need to sort of allow for those two different types of messages. So let's have a look at the messaging system. So we'll use the example of receive from. So the user application said, hey, give me a web page. So the green boxes, by the way, indicate that this is a process, and the blue boxes, which will appear in a bit, will indicate a data structure. So we have we're using the PSOC interface. So receive from looks up the appropriate method mapping in the PSOC interface, and it finds out that we've got an equivalent processing method in the implemented on the processor. So this method will take the incoming request and it will create a message because this has got to go over the SPI interface. So it will create a message encoding all the information that's needed for a receive from request. And it will put this message into a message queue. On the STM inside NuttX, we have a thread, which is the SPI thread, and this has a couple of functions. The first thing it is there to do is to monitor the message queue. The second thing it's there to do is to make sure that the messages get from the STM32 to the ESP32. So it receives a message, and it doesn't care that this is a receive from. It just knows that this is a message. But the other thing that receive from will have done is to say in the message that this is a blocking message, and I'm waiting for a response. So the SPI thread keeps a list of those waiting messages, waiting for responses, and then it starts to send the data over the SPI bus. So we're now on the right-hand side, we have the SPI task. It's a free RTOS task. So we're on the ESP32. The SPI task does one thing and one thing only, and it waits for instructions from the STM32. And in this case, the instruction is going to be, here is a message. So it will receive the message, and it will have a look at the contents of the message and work out who is expected to deal with this. So in this case, it's a receive from, so it's going to go through to the Wi-Fi queue. So this queue is a list of the outstanding messages for the Wi-Fi subsystem on the ESP32. There are similar queues for Bluetooth, for system, etc. And I've just shown the Bluetooth one there just for reference. And just like on the STM, we have a task which is listening to the Wi-Fi queue. And the Wi-Fi task will take the message from the Wi-Fi queue and say, okay, so this is for the Wi-Fi component. What do I need to do with this? So it will decode the message and say, right, this is a receive from request. So using this socket, I'm expecting up to 10K of data. So execute a receive from on this socket and give me the result. It will then get the result of the receive from request. It will then take that response and it will encode that back as a message, and it will put it in the response queue. So the response queue holds all of the responses, plus things like, say, a Wi-Fi disconnect message that are needed by the STM32. And again, as it's a queue, we have a task which is monitoring the queue, and its sole job is to say, okay, I've got a response come in, I need to let the STM32 know about this. And it does that with a GPIO line, and there's a listener running on the STM. It then says, okay, so there's a special message coming in, and this is the ESP32 wants some attention. I don't know what it is, but the ESP32 wants some attention. So it needs to then tell the SPI thread, well, talk to the ESP32. And the easiest way that we found about doing this was to actually just use the message queue. So we've just put a message in the message queue to say, hey, tell me what's going on. Is it, tell me, have you got an event for me like a Wi-Fi disconnect, or have you got a response to a message that I've sent to you in the past? And then we run through the whole process again of the messages coming in to the SPI thread across the ESP32 and so on. And eventually we will get to a point where the system says, hey, this is the STM32's asked me for a response. So the SPI task will simply take a response from the message queue, and it will then send that over to the SPI thread on the STM processor. once that thread has the response, it can then say, oh, right, this is a response to a message. And it can then close the loop by using the list of waiting messages that was created earlier, and then eventually use the semaphore in the receive from to unblock the receive from request. And so we've now gone full circle. We've gone from the initial request, we've passed the request of the ESP32. It's got a response for us. The response has come back, and we can now return to the user application. And on the on this slide, it's just a quick detail for anybody who's downloading the slide deck. It's just a detail of all those individual steps on the previous slide. So there are a few challenges with the messaging system. We have the problem of synchronizing the two systems. So the STM32 is running NuttX, and we are spawning a whole number of threads on the NuttX system. And this is not necessarily going to be in synchronization with the startup of the ESP32. So one's going to start first, and we need a way of synchronizing the two chips to get the initial synchronization and initial comms set up. We also, with the two SPI, the thread and the task, we need to deal with transmission failures because these chips could be working in a noisy environment. We don't know. So we need to have a way of working out when we get message corruption and to recover from message corruption. We also have to think about message sequencing because of the bug we mentioned earlier, where messages can only be, or SPI messages can only be 4,092 bytes long. We need to deal with things like, well, what happens if we get a 10K response, or what happens if the system requires 10K? How do we deal with that, and how do we synchronize the messages to make sure that we get the data in the right order? And the final thing we have to think about is we have to have a look at timeouts on the system. And again, this comes back to implementing a resynchronization of the two tasks. So some of the other challenges we had. Modern .NET in itself is reasonably beefy. As you've seen from the specs of the chips, we have 16 megabytes of RAM and 64 megabytes of flash. So it's a reasonably large-scale problem for a microcontroller. Our current development system, we're running on a version of NuttX that's a little out of date. It's not certainly not up to date with the current branch. So occasionally we find that a feature or a problem that's been solved in the current version, we have to go and sort of steal a file from the current version and just patch it into ours at the moment until we get time to rebase. Rebase is one of the things we want to do. So also we have the chip errata, as we mentioned, with the SPI 32. The USB communications interface, when we first started development on this, we tied the USB comms in a little bit too tightly with the operating system. And originally it was in the kernel, and it's now a user application. And that gave us more stability, especially when we're talking about, for the operating system developers, it's not too much of an issue, but we're trying to get this out to end users, and they need stability. They need to be able to recover the board 100% of the time. We've got some unit tests for things like the networking, the various comms modules, and so on. And because of the multitasking nature of the environment, it made heap checks a little bit interesting at times. And the last task, last major challenge we have is things like over-the-air updates. So with this system, as you've seen, there are several components that are key to the actual system itself. So we have the application running on the ESP32. We have NuttX running on the STM32. And we also have the Mono runtime system running on the STM32. So when we're doing an over-the-air update, we're firstly not just updating one component, we're trying to update 3, 4 if you include the user application. And we also have the fact that one of the components is running on a totally separate microcontroller, and we have to find a way of keeping all these synced up so that we have the right versions in the right place to ensure that the user application runs and the user gets a good experience. So let's just have a quick look at the future for where Meadow is going at the moment. So we're currently in beta release, but we're prepping for release 1. As I mentioned earlier, we need to rebase NuttX. We'd like to be using the latest and greatest, and also hopefully we'll gain some features from the latest releases, some additional drivers, etc. We'd like to look at moving .NET Standard 2.1 support to .NET Core support. We're also looking at dynamic linking, and my colleague Neil Ferguson has a presentation tomorrow on dynamic linking. So if you're interested in that, make sure you join us tomorrow. And also, we'd like to have a look at ahead of time compilation and get this rolled out to developers. So ahead of time compilation is a way of, instead of interpreting the .NET either just in time or fully interpreted on the STM32, we would compile the application down to native STM32 instructions and then deploy that onto the board. So this should give .NET developers full access to the full speed and facilities on the microcontroller. So if you want any further information, we're on social media. I'm on social media. The company has a developer website, so you can have a look at the software libraries that are available, and get some more information about the board. We have a wide variety of code on GitHub. There's a number of projects on Hackster.io. One of our developers has done a great job of providing demo applications and videos of the applications running. We also have content on YouTube as well. So I'll leave you with that for the minute, and just let's say thank you. And are there any questions?
Okay, thank you very much, Mark. It's a really nice presentation. And yes, Meadow is very nice. It's very powerful. Let me turn on the camera. Okay, nice.
Thank you.
Yeah. So we have the first question. Let me mark it. Okay. What is the RAM footprint? It's from Yen.
Yes, I'm here. I'm actually interested in RAM footprint because I saw you are using 16 megabytes of RAM. How much of it is needed to run Mono on this board?
We do have a fair amount of space available to the end user. I can't remember the full amount, to be honest with you. There is a fair amount. I mean, we are talking... It depends on the size of the application as well, and the number of libraries that you pull in. So the more libraries you pull in, the less memory you have, because Mono has to keep a list of all the methods that are being used, and obviously do the just-in-time compilation. We have just implemented linking and tree shaking, which reduces the size of the footprint required by Mono. I've not personally run out of memory. I've run things like String Builder, which are relatively large components, and I've had no problems at all. But in truth, I can't remember off the top of my head the exact numbers.
Okay, we have the second question from Fabio Yuzzi. why have you not run everything directly in the ESP32?
At the moment, it's looking at the size of the right. We don't have the extensive number of GPIOs available. So if you look at the core compute module, it gives us access to a wider range of GPIOs. And at the moment, when we started development, we weren't able to actually get access to the amount of memory that we actually need. The ESP32, when this project kicked off, was restricted in terms of the amount of flash and the amount of RAM that the chips could actually access. I think with the new, I can't remember if it's the S3 or the C3 series, you do have access to more RAM and more flash. So that is a possibility now with those, with those larger hardware capabilities.
Yeah, like the ESP32S3, for example, right?
Yes, I think that's the one I'm thinking of. Yeah, but when this project was launched as a Kickstarter a few years ago, and at the time we just didn't have access to the amount of memory that would be required to run Mono.
Yeah. We have other question from Yernik. You can ask it directly again if you want.
Yeah. Why are not using NuttX on ESP32 also?
At the time, I can't remember if the ESP32 port was available. I think it was about 3 years ago when we started working on this. But another influencer was the fact that Espressif supported the ESP IDF and FreeRTOS. And to go with that library that's supported by the vendor gave us a greater confidence in stability and future. So we're not saying that NuttX is not stable, it's just that if the vendor's shipping that library, they're going to be supporting it. And if we have any problems, we can go direct to the vendor.
Yeah, just because I work in Espressif, just to let you know, now Espressif also supports NuttX directly. So yeah, now the situation changed a little bit. I have a question. I saw you implemented this SPI communication between F7, STM32F7 and ESP32.
Yep.
But why don't you use the user SOC to implement this communication, to use it transparently on NuttX?
We had a look at the PSOC interface, and given the fact there's a one-to-one mapping between the two, we needed a way of getting the data from the STM32 to the ESP32, and the method that was chosen was SPI. It was implemented. The SPI comms was implemented in the hardware. So we went through using a PSOC interface to actually just provide a one-to-one mapping of the methods on NuttX to the methods on the ESP32. Answer your question, or is it?
It was mostly about user stock. You asked. Yeah, because it is integrated directly in the network of NuttX, so it avoids to have like a foreign stack on NuttX. So you can this way use all the network tools available on NuttX. Yeah.
But the things that were going through my mind when I had a look at that, I was looking at. I didn't want to go through another software layer, given the fact that by implementing a method table, because I still think we would have had to have implemented the SPI comms anyway. Although it could have been done in the user SOC driver, we would still have to have implemented the comms. And I just looked at it and thought embedding it in the kernel although we have the risk of us corrupting memory, because we work in protected memory, so we do have kernel memory and we do have user memory. I looked at it and thought, well, instead of running the possibility of doing a context switch again, to just run direct off the method table that's implemented in the PSOC interface.
Okay. Actually, we don't have it. It's also integrated yet, but I think having user socket on NuttX to use the ESP32 as a modem, like similar, like you use it, like only to export the Wi-Fi, for example, should be nice. But yeah, good point, because you also exported the Bluetooth. Yeah, and I think maybe Masayuki and Greg can correct me, but I think user SOC is not integrated with Bluetooth yet. Only with network, only Wi-Fi, and yeah.
But we also have things like system functionality on the board. So we need the ability to say to the Wi-Fi, sorry, not to Wi-Fi, but to the ESP32 itself, we need the ability to say, go to sleep, we're going into power saving mode now, or put the Wi-Fi components into low power mode, but keep active and keep talking to the STM32 to do things like battery management and so on. So the actual FreeRTOS code is not just implementing Wi-Fi; it is providing access to a wide range of features.
Yeah.
The messaging system we have, it's open to. So we have, let's say we want to do some. We want to use the free processing power on the ESP32 to do, say, some number crunching. We could add that in as a module on the ESP32, and we can then just add another message into the system. So the actual messaging system itself, as you touched on, isn't just there for Wi-Fi. It is there for a number of components and is available for expansion later on.
Yeah, and in the ESP32 code, in the IDF, did you use the existing code, or did you modify many things to support these system functions?
There was some code, a small amount of code that we used, obviously, to get off the ground, things like getting the application up and running. We're using a lot of the standard components on the ESP32, so things like queues, semaphores, I think they're called semaphores, tasks that are available through the IDF. But for things like the Wi-Fi, it was really a case of, we have this messaging system, we need to wrap up requests and responses. So we've got data for a request, say, I want to read from this socket. And then a response might be, we've read from this socket, here's 4,000 bytes of data for you. Those sorts of things we had to develop ourselves. On the Bluetooth, we used some of the existing Bluetooth code as a way of starting and getting up and running. So it's a combination of there's a lot of custom code in there, but there was some of the examples in the IDF were used to kickstart us going into like the threading system down through the Bluetooth system and so on.
Nice. I think our friend Kim Petit want to talk. Hello, Ken. Welcome to our event. Nice to see you.
Yeah, actually, I think Mark, and Alan, the discussion about using user sockets. I think one of the things you would have probably still had to do would be to create a transport for the SPI, and also implement that on the free RTOS side. And the reason why I know that is because I actually did, and I can maybe do a presentation for next year's workshop. I actually did just the opposite, where I had NuttX in an embedded processor on the receiving end of the SPI. In other words, NuttX wasn't the master, it was the slave. And I had a Linux operating system that was actually the master, right? So I needed the ability to do a telnet, an FTP session, and have several different sockets open down into the NuttX running on the RISC-V core across that SPI interface.
Yeah.
Right? So I ended up doing just that, and I wrote a SPI socket, which I called Spigot, a SPI socket transport layer, right, that I had to implement on both sides.
Yep, so sounds very, very familiar.
Yeah, when I was looking at it, I'm like, wow, this is just the opposite of what I did, right, on the application that I have, which I did get all that running, right? So, yeah, that definitely would have required a transport layer protocol on both sides, and then also some semblance of a stack running on the free RTOS, which you probably also didn't have at the time.
Yeah, nice. Sounds very, very familiar.
Okay, guys, let me ask everybody to turn on the camera, and I will do a print screen to get Mark, Ken, Greg, Yannick, Nicholas, Alan, Pedro, Michael, and Masayuki. Oh, Masayuki is still here. Hello, Masayuki. Michael, are you here? Okay. Pedro?
Greg?
Nice. Hello, Greg. Let's do print screen. Oh, not. I would just screen. Please turn on again. Oh, guys, I didn't got the print screen. The print screen opening for the browser.
I got it.
What? My connection? I don't know.
I got it, Alan.
Did the print?
Yes, I managed to get the print screen.
Oh, perfect. So, guys, any other question? Let's see. No, it was the last one was about the. Masayuki, people are are wanting to see the motorcycle, the Jaspion moto. Masayuki?
You're muted.
Yes.
We just received the request. We cannot see the Masayuki motorcycle. Your moto is still in the wall.
Ken, for tomorrow we are planning a discussion regarding the audio subsystem in NuttX. Can you please join the session from Koizumi-san?
What time is the session?
Let me check the schedule. I'm sorry, I do not remember from the top of my head. It's the third presentation, and tomorrow the sessions will run without pause. So I would say around 12:31 GMT.
I will try. That's about 5 a.m.
Extremely early for you. Unfortunately, Koizumi-san is in Japan, so it's hard for us to put his presentation later.
I will try. I sprained a muscle. I've been taking muscle relaxers, which tend to make me sleep. So I woke up at 7:30 this morning, not 5. So I'll definitely give it a try. I'll set an
alarm. Yeah. What do you think? No, but that will push it too late for him. I was thinking maybe we can do a switch and have his presentation the fourth one. What do you think, Alan?
I don't know. Maybe Masayuki know he's better. Do you think it's okay for
Koizumi-san?
Koizumi-san to be a little bit What time should be it in Japan? Do you know? It should be.
Masayuki-san, what is your time zone? GMT plus 6, 7?
GMT plus 9, I think. So my presentation will start at 8 p.m. tomorrow. So Koizumi-san will start maybe 10.
Yeah.
I guess.
Yeah.
Considering
I bet I just set an alarm at that point. Just leave the schedule the way it is. That's probably the easiest. And I'll just make sure I set an alarm. And I'll go to bed a little early tonight.
We are really sorry. I know that scheduling those all around the globe meetings is horrible for everybody.
It's difficult. So yeah, just keep the schedule there. I think that's the easiest, and I'll accommodate.
Thank you very much. We appreciate it.
Yeah, and maybe we can try to create a new talk later to after the event, maybe some meeting to Kozoyomi, Ken, and Masayuki, and Thiago also is interesting.
After the initial kickoff, I think that we should stick to the developer mailing list. It's easier, and we may get even more feedback instead of having a one-on-one or a closed meeting. I think that this makes things easier. Also, due to the time zone, it will be easier to have an asynchronous communication.
Yeah.
Christian, did you manage to post the third word?
Do you mean
the next word for the
I will prepare the form here. We have the participant already here. So Nicholas is here. So Nicholas, just to confirm, Nicholas, I will play your presentation, right?
Yeah, I send you the presentation so you can just play it by your own.
Nicholas, okay. Can you play it for us?
Yeah, maybe it's better because I need to do the form.
While we play, or in my case, while we stream, we cannot do anything else. So if you can stream it yourself, it will be a big help.
Select the window where you are playing the video.
Yeah. Okay. Give me a second. I just have to find this video back because I sent it to you, but I don't remember where I get it.
Okay. I was going to say the name of the video. By the way, Mark, thank you very much for being here and presenting about the medal. It was really nice presentation, and I hope next year you stay here to see the Ken presentation about the user stock implementation he did using NuttX as not as master but as a slave of a Linux system. So and I hope soon other people also start to contribute this kind of implementation for user stock in the ESP32. Normally, we don't care too much about it because we have the Wi-Fi and Bluetooth working in the ESP32. But it is nice because sometimes you want to use ESP32 with other microcontrollers, like you did. So it should be nice, to have the the user SOC.
Yeah, if this is coupled with the dynamic linking, which Neil will be talking about tomorrow, it gives you the option of also looking at different transport providers, so things like LTE, cellular modem boards, and so on.
Yeah, and yeah, this is something that some people need to use it, but many others don't. So better to have all the needed support on NuttX. So Mark, thank you very much. And now, Nicholas, it's your time. Thank you very much.
I still struggling to just, I don't know why, but the video just don't want to play. That's the perfect time.
You need to give permission, so you share.
No, I think the problem is on my computer. No software just want to start right now. I don't know why.
Any software?
yeah. I'm just trying to start VLC on nothing's happening.
Alan, can we try and stream it? Can you try to do it?
Yeah, I will try to stream it.
Sorry about that, guys.
No problem.
Don't worry.
Thank you for having me today. My name is Nicolas.
Okay, let's just a second. Let me share it. Yeah, the name is very confusing to find. It's not screen 1, screen 2. Live streaming was not. This one also, I suppose, not. Let me find a way. Just a second. Okay, this one I found. Yeah, the name was different. Okay, let me know if you guys can see it. I put in full screen mode.
Not yet.
Okay, and now?
Still no.
I think now is okay, right?
Unfortunately, no.
Oh, crazy.
I just successfully opened it, so perhaps I can do it right now. Okay, so let me try.
Okay, go ahead.
But I'm not sure you will have the sound, but we will see.
Yeah, you need to allow the sound as well.
Okay, how can I do that?
Normally, when you start to play, it will use your microphone. Just didn't turn off it. Let's try. No, I cannot see the audio. Please, and I will try again, because maybe it was.
Hello everyone. Thanks for having me today.
Maybe it was because we both are trying at the same time.
Okay, so I try again?
No. Let me try again.
Okay, yeah.
Okay. And now?
No, unfortunately, no streaming.
No yet?
No, we can see your image.
Yeah. Here it opens like it's going to transmit, but nothing happened. Maybe let's move it to another.
Or perhaps I can do it live. It will be a little bit difficult for the demonstration, but perhaps I can do it.
Yeah, no, let me try one more time.
Okay.
No. Crazy. Yeah, these kind of sharing streaming tools are not so.
That's not easy to use.
Yeah, they should be more.
Hello everyone, thanks for having me today.
I try just another time. Okay. It's still not.
Okay, so let me do it. Let me do it live. It will be great. I have things. I think I will be able to do the demonstration the same way, and it will be a little bit strange, but I will make it like that. It's okay. So let me share my screen, and I will make it live.
Okay, sorry.
No problem.
That. Yeah, but I think you need to share your screen in the same way, and if it's not working, I need to.
And you can see my screen?
We can see your screen.
I can see it.
It works.
Great.
Please make it full screen.
So
maybe you can try put in full screen. I don't know if it's
I don't know how to do that.
F11.
F11.
Yeah. Okay. So basically you can see my thing on top, right?
Yes.
That's fine. Okay.
You're Apple. Sorry, I don't know.
Yeah. Yeah. I can do it. I don't know if you. No, I can't. I can't do it. I don't know why. No, I know why.
Perfect.
I know how to do that. Okay, so let's start. My name is Nicolas. I'm CEO at Leos. I am embedded system engineer and specialist on robotics. I'm really not a NuttX guy. I just heard about NuttX a few weeks ago, thanks to Alan, because Alan just joined our community at Leos a few weeks ago and talked to us about NuttX. And we had a really interesting conversation with Alan about it. So Alan, thanks a lot for inviting me today and allowing me to present this what we are doing at Leos during this conference. So I'm going to talk to you about what we are doing at Leos. We are working on a microservice orchestrator dedicated to real-time and distributed embedded systems. So to begin, I will talk to you about why I am talking to you today. First, I think this is because we have the same vision. Next, I will explain to you what is Leos and what we are doing at Leos. And at the end, I will talk to you about what could be the benefits to have NuttX working with Leos. So about the vision, just to begin, I have to talk to you about how the embedded system code complexity increased during the last 10 years. This complexity explodes, but the productivity don't grow so many on this field because we don't have a lot of tools and the embedded systems. And that's why NuttX is extremely interesting. This is because this is a tool allowing to increase productivity. And we are doing the same kind of things with Leos, but in a really different way. To give you an example of something really interesting and really close to what we are doing, let me talk to you about Tesla. During the Irma hurricane, Tesla was able to update the car batteries to increase the autonomy of the car, allowing people to flee the area of this hurricane. And this is something that today customers expect to have because we have this kind of updates in any kind of mobile phone, web applications, something like that. But it's something extremely difficult to do in a critical device such as a car. today's software is extremely easy to make agile software, because we have microservice architectures allowing us to consider a complex software in tiny, simple pieces of features, and to make it agile and be able to constantly improve it, we need those different pieces of software to be versatile, loosely coupled, and connected. If all pieces of software have those three things, you will be able to improve it constantly. Today, hardware is completely driven by software, but there is a big difference. We have hardware specificity, and this is a big problem regarding agility. First, it's really difficult to keep our software extremely versatile. We can do the same thing that we are doing on normal software industry because we don't have virtualization and things like that, so we can't use Docker. Also, it's extremely difficult to keep it close coupling because we have those hardware specificities, and we will have to develop specific piece of software to drive those hardware specificities. And this makes this code highly coupled with the device. And reusability becomes almost impossible in this case. And the last one, when we have multiple electronic boards in a device, we don't have default way to exchange information between the different pieces of software running on all the boards on the device. And all of it completely breaks the agility of the whole design chain. The result is that embedded system engineers spend 75% of their time to remake existing things. That's why we created Luos Engine. Luos Engine is the open source dev tool that makes hardware as agile as software. To solve those problems with Luos, we encapsulate any features. Features can be hardware or software. For example, hardware can be like a battery, a sensor, or any kind of motor on the driver. We encapsulate this driver into a service. Then we put an API on top of this service, allowing any services to access to any other services anywhere on the complete product. What I mean by complete product is you can have multiple services running on the same boards, on different boards on the device using an embedded network, any kind of network. And you also can have applications running on the cloud, on a computer, on a mobile application or something like that, and link all of it as if they were all located in the same place. As a service developers, you will have access to all the other services running on your product. And this makes development versatile, loosely coupled, and connected. And this completely changed the way people think about hardware product development because instead of having this really monolithic way to make it where everything is developed for one specific product, Luos allow you to think your product as tiny independent bricks of code that you can compose to create your product step by step and to make it evolve extremely easily. So now let me show you. I will try to show you. I don't have my complete setup right now, so I will try to make it. We're using my webcam here. So to show you how it's working, I'm going to develop with you simple connected bike alarm. To make it, I'm going to use those small boards I have here. Those boards have two boards, one which is the main one with a Cortex M0 on it from ST Microelectronics. I have two connections on these boards, allowing me to have to link as many boards as I want on configuration on the network. And I will share the network on the power supply on those connections here. And also I have another board on top of it, which is a kind of shield. And we have a lot of different shields allowing to show motors on a lot of different sensors or things like that. We are only using those boards for demonstration purpose. We don't sell those boards. This is completely open source on our GitHub repository. So if you are interested on this board,
Nicholas, sorry to interrupt you. You show the image in the camera, but it only appears here in the Jitsi. In the YouTube for our.
Okay. So I have to stop sharing my screen, right?
Yeah.
Okay, so let me stop sharing my screen.
And we put you in full screen.
Great. It will be better for the demonstration. So here is the board. Now you can see it. And we have different kind of shields. And these shields allow us to do a lot of different demonstration, but we don't sell those boards. We only use it for demonstration purpose, and everything is open source, so you can directly download the plan of those boards to produce your own board. So this one I have on my hand right now is a motion sensor. As I mentioned, we can put as many services we want on one board, and we have big differentiation between application services and driver services, because application don't have to rely on any hardware because you can use available drivers on the device. So basically, applications are most only software and don't rely on any hardware. So basically, you can move it on any board of your device. It will work exactly the same. On this one, which is the motion sensor, I put only one service, which is the driver, allowing me to access to this motion sensor. I will also use this one, which is a simple RGB LED. On this one, I put two services. One, which is a driver, allowing me to access to this RGB LED, and another one, which is an application that tries to get back the information of this motion sensor to make the LED blink when there is a movement. To make it work, I have to link those two boards together. And because I don't have my complete setup right now, and I don't have any power supply, I will cheat a little bit and add another board, which is a USB board, just to power this system. I will come back to this one later. Okay, so like that, let me plug it. So when I start the system, as you can see, the system just works. So if I successfully stop moving, the LED will stop blinking like that. And if I move, as you can see, the LED is blinking. So when I start this system, Leos made something we call the detection. The detection starts by defining the physical position of all the boards on the network. Basically, we can find the topology of the network. So here we have 3 different nodes. And then we can list all the services available on all those nodes. Then to finish, we create like something we call a routing table, which is a kind of database with all the nodes on all the services available on all of them. And we copy paste this routing table to all the nodes, allowing any services to access any other one directly. And by doing that, the applications running on the LED right now have a direct access to the motion sensor. So right now I have a really basic alarm system, but I can't start or stop it. I don't have any way to start or stop it. To be able to start or stop it, I will have to add a new features in this device. And I don't want to change anything on this first part I just developed. I want to add a new thing without having to change anything I already developed. To make it, I'm going to use this one, which is a simple button. On this one, I put 2 services. One, which is a driver, allowing me to access this physical button. And another one, which is an application that constantly monitors the state of this button and try to find the alarm application running on the LED and to start or stop it depending on the push on the button. To make it work, I just have to add this new one on my device. That. Okay, let me just plug it on the right way. It will be easier for me. Okay. And now by adding this new board, because this board have been detected by the other one, Leos will run again a new detection, allowing all the nodes to know that there is a new board available, which have this and this on this service. And now everyone can use it directly. And when I push this button, it's not working, of course, because this is my home setup and this is not the same. And let me try again. So when I push, as you can see, the LED turn white and the alarm just stop. And if I push it again, the alarm runs back. And you can continue to develop your product like that by adding new features step by step on your product. When it comes to go to industrialization, you don't want to have tons of boards like that. And you will have to redesign the hardware, allowing you to reduce the cost on the production side. When you will do that, you will only have to change a little bit the drivers you will not have to touch anything about the applications, because the applications don't rely on hardware. So also, as I mentioned previously, with Leos, we consider every service like a connected feature. So basically, we can connect it with anything. So for now, I'm using this USB board I have here only for power supply purpose, but I also can use it to communicate with all the services and to control any services available on my device from my computer. So I will try to make it using my computer. So I will share my screen again. Okay, so can you see my screen?
Yes.
Okay, great. So I will use a small piece of Python code to show you how you can just control all your embedded features in using Python natively with Leos. So this is probably not the good one. Okay, so I will use a library called PyLeos, which is allowing to simplify the way we are connecting to those specific boards and to get back the information from Leos and use it. So the interesting line is this one. On this line, we are connecting to this USB connection, and we are converting all the available embedded service into an object called bike. So when I run this piece of code, Leos will start. As you can see, there is some warning. This is a new thing. But yeah, it should be okay. Okay, great. So as you can see, here we have the routing table I mentioned previously with all the nodes where they are on the network on all the services available on all of them. Then I can use all those services directly as variables into my Python code. Here, I linked this 3D bike I have on my screen with my motion sensor, so I can show you my camera at the same time as my screen, but you have to believe me, but I'm moving my motion sensor, and as you can see, the bike just follows the movements, and at the same time, the alarm is still running exactly the same way. So basically, I can get feedback from any services without changing anything on the behavior of the device, and I can do it natively without having to write one line of code on the embedded side to be able to do that. And also I can do it the other way. I can take control of any features embedded on my device. For example, here I want to access the bike, which is the object with all the features on it. I want to access the service called start control, which is the application monitoring the push button to start or stop the alarm. And by using this command, I can start or stop the alarm exactly the same way. The push on the button will do that. So when I do that, you can see my screen, but the letter white on the alarm just stop. When I do that, the alarm runs back. And you can use it to develop your own application on the computer, for example. At the beginning, we were using this specific Python thing just to test any features on the embedded side extremely easily. So that's it about my demonstration. Let me go back to my slides with my really good GIF. Okay, so just to resume, the main concept of Leos is to encapsulate features into services. Then I don't mention it, but you can also create something we call a package, which is a collection of service in a folder. And then this package will be extremely easier to move from one microcontroller to another one, or from one project to another one. After that, you have a collection of packages you can put on nodes. Nodes basically are microcontrollers. Your microcontrollers will be on board. And when you have multiple boards or multiple microcontrollers, you will have a Leos network. And then you can remote control anything on the embedded side using Python or any languages. Basically, this specific configuration sends you back some JSON information, so you can make it work with any kind of languages. Leos Engine is working on a 30 kilobyte flash, and we need approximately 2 kilobyte RAM to make it run. It depends a lot of how many data you will want to send and receive. Also, this technology in this configuration on my demonstration was bare metal, but you can also make it work on any kind of real-time operating system. We are working with any kind of microcontroller from the 8 bits to the bigger one. And right now, we have some limitations about the network because we are using half duplex network only, and we can only manage one network at a time. I will come back to this specific thing later on my slide. So the main philosophy of Lewis engine is to be deterministic. So we have also real-time compliance. We are a lot of real-time compliant features. It's have been think to work for cost, size, and industry constraints products. It's massively multi-master, so anyone can talk to anyone as you want. And we don't do any memory allocation. So basically, you can control how many RAM Lewis will use on your setup. So now let me talk to you about some features I can't show you on this demonstration. The first one is called Lewis Object Dictionary. The idea of this feature is to be able to use an information without having to know which is the unit that have been used by the other one that developed the other software. For example, if you have like an angular sensor somewhere, and this angular sensor driver I've been coded using radian units, and you have an application using this angular value, but using it in degree. Lewis will be able to convert it on the fly, allowing both of those applications to use the units they want to use without having to take care which is the unit used on the other side. Another interesting feature is called templates. Templates is a small C file allowing you to define what kind of information can deal with a specific service. This phrase was not, the sentence was not really good, but basically if you have like a motor, you can create a template.c dedicated to this motor, and you will have all the information allowing you to deal with Lewis messages and to convert it into a data structure directly available on your motor code. So basically when you develop your driver, you will just write and read some variables into this data structure, and the template.c will use this data structure to synchronize all the Lewis messages. If someone, an application, for example, send you some targets, this target will be updated in the data structure, and your motor will be able to use directly this information. This is really useful when you are working with someone else to develop a specific piece of a product, because you only have to write this template.c, and you will be sure that this driver or this application will be usable natively by all the other one, because you defined the API of this specific service. So basically, it's allowing you to create like the complete interface and the complete API of a specific given service type. Also, we have something based on timestamp, allowing to deal with real time, on which is extremely interesting because we don't do any time synchronization between the electronic boards. We are doing something we call distributed latency based time synchronization. The idea is when we send something, we evaluate the latency between the generation and the consumption of this information. And with this latency, we can calculate the date of the event on the local timeline. So if we have a sensor measuring, like, I don't know, a distance, and send it 1 millisecond later, and this message will be received 1 millisecond again later, we will have a latency of 2 milliseconds, and we will send this latency in the message. Then the receiver will reduce the actual time by 2 milliseconds, allowing the local nodes to know when this distance measurement occurred. And we can do it exactly the same way for future events. For example, if you want to send the target to a motor that have to move at a specific date, you will be able to do exactly the same. And we write we wrote an article about that, so you will have access to the slides, and you will be able to click on the link on the bottom here, allowing you to read this specific article about this distributed latency-based time synchronization. Also, because with Leos, we have access to the network and we have access to the flash, it's possible to compile Leos in bootloader mode. Basically, we can make it with any board supported already by Leos. And this create a small binary where you can put anywhere on your microcontroller. And then you will be able to remote update the firmware of your boards. It's extremely useful when you have a really complex product with tons of boards on it, because you will be able to have only one USB connection, for example, and flash all the boards on only one command. So now let me talk to you about some interesting features that will come in the future. Right now, as I mentioned, Leos is only able to deal with half duplex network. This is something we have to work on, and this is the subject of the Leos Engine v3. On Leos Engine v3, we will make it compatible with any kind of network. Basically, you can have homemade network, and you will be able to just write a small piece of code allowing you to make Leos interact with this homemade network. And also, we will work on something we call multi-fi. The idea of the multi-fi features is to allow Leos to deal with multiple networks at the same time. So, for example, if you have a lot of different boards, all of those boards can use, I don't know, can network or something like that, and you have one board on the device that have access to a Wi-Fi. You can use both of those networks in the complete configuration to link any service across any of those networks. So it will allow you to completely break the frontier between the embedded side and the normal computer or cloud world. So now, what about NuttX plus Leos? Because we don't do exactly the same thing with NuttX and with Leos, and it's extremely interesting to combine both of those technologies. First, because NuttX could use Leos as an extended IPC, because basically Leos is an IPC synchronizing and exchanging information between the different services running all across around the product. So it could be really interesting because you could use it as to synchronize different NuttX board using this kind of technology. Also, NuttX and no NuttX features could be compatible. What I mean by that, if you have a big configuration with a lot of boards on one board with NuttX on it, and all the other ones which are extremely small and with bare metal drivers and things like that, you could have like bare metal on those boards on NuttX on another one, and NuttX will be natively compatible with the features hosted in the bare metal ones. Also, there is some advantages for us, of course, because Leos could support a lot of different environments. Thanks to NuttX, we only have to make Leos compatible with NuttX, and then all the boards already supported by NuttX will work natively with Leos, which is extremely interesting for us. And also because the Leos users could natively and directly use all the NuttX features, which is also awesome. So just to talk to you about how we organize our code, I just made this simple drawing. So as I mentioned, we have the network layer, which is right now the half duplex network layer, and we have a hardware abstraction layer on this network thing. And we have Leos Engine, which is the main core of the library, with also a hardware abstraction layer accessing to some timers and memories and things like that. And on top of it, we have the different services written by the users. The main idea with how to integrate NuttX with Leos is to create an hardware abstraction layer using NuttX interfaces, and at the same time, our users will be able to use NuttX on the services developments. So basically, you can have as many threads you want on any kind of services and synchronize those different services using Leos. About that, as I mentioned at the beginning of this talk, we are not NuttX guy, so it will be really appreciated if some of you guys could be interested in this kind of thing, because we will work on it. But any help is really much appreciated into this development. So thanks a lot for having me today and to listen to me. And now, if you have any questions, it will be a pleasure to reply to you.
Okay, thank you, Nicholas. Very nice to turn on the camera. Yes, really nice presentation. Also, Philippe Koval, also from France. He creates something very similar. Present something similar to that 3D bike that you show.
Okay.
He used the web things. Maybe we can talk with him about it.
Sure. So yeah, that's a hack I presented at last NuttX event. By the way, hi everyone. I've been chatting all day, but I didn't manage to see you in person. So yeah, I can show you if you're curious. It's less advanced to what you describe it, but it's like something can be good for inspiration for people who want to create similar things. So
yeah,
I don't know if we have time. I have recorded a 6-minute video, but I can make it faster if you want.
If you want to continue the discussion. Same thing.
Arlene, I think your audio is cutting for me. I don't know, it's only for me.
No, I was not able to hear him as well.
The same.
Yeah, the same.
Sorry, I said that we have time. Can you hear me now?
Okay, yeah, good.
Yeah.
So I try to be quick and feel free to interrupt me. So let me explain. Can you see my screen?
Yeah.
Okay, so I'm just turning off the audio and I'm explaining the context. So what you see here is an electric vehicle, an open source vehicle. That's some item which is used as a RD platform, and we have one of them in REN, and there is at university. Sometimes, from time, it's open to hackers and makers, and I was able to hack on it. So that's the context of this demo. So we made different meetings in the past. We were able to try to control the speed of the motors and so on, but we supposed to have one meeting during this COVID lockdown, and it was cancelled. So I decided to let's see what can we do if we are not able to get access to the vehicle. What can be done remotely from home? So I joined this project. So it's called Mozilla Hubs. I don't know if you know. It's a shared virtual world. It's an application running on the web, and you can play with 3D models inside this shared virtual world. So it's a multi-user environment, and you can create different things. You can navigate among them. So you can interact with others members which are sharing the same world, and you can also interact by adding more items to the world. So it's something quite similar than Second Life. It's a project that gained traction in the early 2000s. So here I'm importing a 3D model. So it's a CAD model of this electric vehicle, and I wanted to try to establish some use case where people can interact on a shared environment. So this was my first challenge is how to get some kind of control of this item in the virtual world. So there is no such API, but from the web browser you can get access to the DOM object, and here I'm showing the scale of the object. So by using this JavaScript console, I can decide to introspect the world and change it. So here an example, I'm changing the scale of the object. So it's not has been designed to work that way, but since it's possible, if you read my mind, I think it would be interesting to have let's say a reference object, which is a physical one that will be in a place, and this object can be also viewed from a virtual world and be updated in real time. So maybe I'm not clear, but you will understand with this example. So I'm navigating on around this static object, and you can also import dynamic objects like a camera. So here is a webcam, which is above my desk, and I can decide to move this screen webcam object among it. So the reason is the webcam is that I wanted to show what is happening on my desk at the same time what is happening on in the virtual world. So we have something happening in reality and something happening in virtuality, should I say. So so the next part of the demo is you see this Lego toy, which is somehow showing the electric vehicle. I didn't have access to it, so I managed to do it this way. And on it, I use NXP Freedom board, which is just like the one you shown as a motion sensor on it. So from NuttX, and this is an interesting part for you, I added the support for this board. So you can select it from the build configuration menu. And something interesting is that it has a sensor, so you can add the support of this specific sensor. And I wrote a driver for it. So this means NuttX can support natively this sensor, and to use it, I also created a sample qualification. So here I'm booting NuttX. So that's the microcontroller running on this Lego toy. So at that time, it was NuttX 9.1. And I made this sensor application, which is updating the value in real time. There is no timestamp, by the way. I noticed you added some, and that's something that can be improved into this app. So if you look at it, it's a JSON stream, so something we can make use out of it. So the next part of the demo is that I made also another application, which is, so here first, before I'm showing, NuttX is a Unix POSIX system, so you can use the pipe mechanism. So we are using a FIFO device. So basically, I'm writing a stream to this virtual file, and I can reuse it to read it and write the stream to the network. So here, you probably know this also from Linux, it's pretty similar. So I have my network setup, and I can decide to use the netcat command to stream what's inside this pipe to outside my development board. So that's now the last part of the demonstration is I have a stream on the network which is updating the value of the sensor, and then I can try to inject it into my virtual world. So this is JavaScript code I'm pasting into the browser. So I'm using WebSockets, and for this you can connect both worlds. So yeah, it's so slowly oscillating. That's normal because there is no filters. And if I'm moving my device, it's also updated in elsewhere. So that's I'm not sure it's really useful, but that's interesting to show different piece of software where not designed to work together that can be glued somehow. So it's involved very low end technology, low level drivers and so on, to high end VR world in shared web environment. So sorry if you were there last year because it's the same demo. So that's not something new, but
yeah, that's really interesting. On my previous company, I was developing robots, and my company was called Pollen Robotics. And right now, Pollen Robotics still exists, and they develop a complete simulation available on the web, allowing you to write the code, allowing you to drive the robots, and you can see it virtually. And when you have the right robots, the virtual robots will move exactly the same way on the real world. So it's kind of the same kind of things. And the idea is really interesting because when you are developing this kind of device, you can just test it on the virtual world first before broke the robot, which is kind of extremely highly costly. So it's you don't want to pay a lot by breaking the robot because you just miswrite a line of code. So this kind of things is extremely interesting, and I'm sure there is a lot of benefits of that even on the embedded world, because there is a lot of things that you could visualize on the embedded world, but it's kind of difficult to extract information from the electronic boards when you don't have any screen or something like that. And having a natural link like that, allowing you to display things extremely easily, is something extremely important.
Yeah, thanks. But yeah, somehow with Green Mind things alike, and for the record, this concept is called digital twins, and that's not something new. It was introduced in year 2000, so that's rather old now. But nowadays, it's doable using open source software, so that's pretty cool. By the way, your presentation was really cool. I like it.
Thank you, Philippe.
And I was wondering, when you had this sensor units, the simple board, how are they connected together? It's they are daisy chain using I2C or something like this?
Yeah, on this specific configuration, we are using RS-485. And basically, we have some specificities allowing us to just discover the physical position of all the boards. So to be able to do that, we have a daisy chain wire on top of this RS-485. So basically, we have one RS-485 on a daisy chain pin, allowing us to detect all the boards.
Okay, nice.
So basically, we are only using this daisy chain wire only during the detection. Then we are only using the RS-485 to exchange information between the different services. Also, we plan in the future to use the same daisy chain wire to do like a keep alive, allowing us to detect without the need of any data bandwidth if every board is still running.
Okay, cool.
But this is the network we have right now, which is called Robust. And on the next revision of LIOS, we will get rid of it, and you will be able to have any kind of network. On this topology thing will be optional. So basically, you will be able to run and create the routing table without having a deterministic position of all the boards. But using LIOS, you can physically know where the boards are on the network, which is kind of interesting. For example, this piece of technology is coming from robotics, because when I was working on robotics, we had a lot of motors, for example, and all the motors were exactly the same. And using the traditional way, most of the time you have to create a specific firmware for all the motors with a specific ID on them, allowing you to know that this specific motors, for example, is the left knee or the right knee or I don't know. With LIOS, you don't need to do that, because you just can flash exactly the same firmware, and you don't need to have a specific unique ID on all the firmware, because this unique ID will be the physical position of your motors in the device. So basically, even if you just swap both of those motors, your robot will work properly without any problem. Mm-hmm. That's the base idea of why we are doing this topology detection first.
Oh, that's cool.
Yeah, very, very clever idea. And do you have some integration with the ROS? With the
Yeah. We have some integration. We have someone called Johan Mola, which developed an integration to ROS1 and ROS2. This is working a little bit like the Python code I just showed you, because you can run a piece, I don't remember how it's called, but a Rust node somewhere on your Rust ecosystem. And then this Leos node will convert all the JSON coming from the Leos network into Rust messages, allowing any Rust packages to natively use any sensors on motors, on batteries, on things like that available on your network. And we have some users that use this kind of connectivity to drive heavy and extremely complex robots. And this is really something extremely useful. And also we are working on some other integrations, and NuttX is the next one on the list.
Oh, nice. Yeah, I think this idea to integrate Luz with NuttX will open door for many applications. So it is something like Philippe demonstrated last year, but using some more distributed OS system like Luz, and it will make things more flexible. Maybe you can work with Philip to put these things together to use his.
Yeah, to be honest, we met with Philip yesterday or 2 days ago, and we start discussing together. So yeah, I'm sure we will continue this discussion because we have a lot to share.
Well, I noticed you in the NuttX schedule, so there is no magic. But we can cooperate. Everything we done is open source, so of course it should be reach possible.
Yeah,
that's nice. And tomorrow, our other Philippe, our other friend, Philippe from Brazil, also will present about motors. He likes robots as well. And so it will be a nice presentation about this subject. And NuttX has many robot features already integrated for users. So like the motors control, FOC, DSP, filters and functions. It's really nice to have these features already in place.
Yeah, and this is also something extremely interesting because you already have tons of drivers, and if we make Leos work with NuttX, we could benefit from all those examples as Leo services. So we have to still figure it out how to make it flexible and make it work extremely easily. But I'm sure this could be really interesting for everyone that would like to have a quick prototyping, allowing to just use some drivers already existing in NuttX and have multiple boards on, have everything running in like a coherent system is something extremely interesting.
Yeah, that's nice because we have the power of both systems to develop things more easily and more fast.
Yeah, and right now the thing that is not really scalable at Leos is that we are using bare metal and we are working on a driver. You can't just copy paste this driver into another board because you are dependent to the hardware. And with NuttX, you can do that, which is extremely interesting for Leos because this way, any service, even the drivers, can be moved extremely easily. So that's extremely exciting for us to start working with NuttX.
Yeah, you can. For example, now that it's difficult to find some microcontrollers because the shortage of components in the market, so you can move from one microcontroller to other very easily.
Yeah,
this is very powerful, very nice.
Yeah, sure.
And you can make it more easily if you are using a script language like Lua, or in the past life I built my robot on NuttX with JavaScript.
Yeah,
on microcontroller. So that's something.
Yeah, at the beginning, we developed Leos completely in Rust because we were really big fans of Rust, and we were some of the first guys on Europe to use Rust on real products. And just for the story, we developed a robot for in a museum in Paris that was a replica of the really first robot in the world. which is called Robot Dog, and we make a replica of this robot in the museum on Paris, and we developed this robot using Rust. So this is like a big contrast because that was extremely innovating to use Rust in the embedded time, in the embedded at this time. So we just made it for the joke to have like a really modern language with a really old robot.
Yeah, and this history is interesting because normally people want to move from C to Rust.
Yeah.
But in your case, you need to move from Rust to C because C is more universal. Right?
Yeah. And I think this was extremely early to use Rust on the embedded world, and that was not officially supported by Rust at this time. And we struggled a lot to just make it work on a normal microcontroller, and we were using STM controller, and we struggled a lot. And also we had some struggle to convince engineers to use our technology because that was Rust, and nobody at this time knows Rust, and it's already extremely challenging for us to explain what we are doing at Leos and what are the advantages of what we are doing, and to convince engineers to just try it and look at it and try to understand where is those advantages. So adding Rust on top of it is almost even more challenging to convince engineers. So that's why we go back to C, but I hope one day we will come back to Rust.
Yeah, for sure. I think sooner or later you need to come back to Rust again because it's making the system more safer, more robust. So it will happen eventually anyway.
Yeah, but the main thing for us is we need engineers to be open-minded about it. This is the main thing that's make us use C instead of Rust. And when engineers will be ready on big companies to use Rust, we will use it for sure.
Yeah.
But guys, you're probably aware that now Linux kernel will support Rust code. So we can imagine someday NuttX will support Rust libraries or whatever.
Yeah.
Maybe from 6.0.
Yeah, NuttX already supports some examples, very, very basic because you need to create the bindings. And tomorrow we'll have the presentation from Dan. He's working the Rustix project. Rustix is like implementation of these binds for POSIX OS. So the idea is if we can run Rustix integrated with NuttX, so sooner or later it will be very easy to run a more advanced Rusty system on NuttX, and then maybe if Luz decide to move to Rust again, it will be easier to.
Yeah, sure.
I cannot say it be easier, but it will make it more convenient.
Yeah.
Sure. Yeah, for sure. Okay, Nicholas, thank you very much. This is a very good presentation. I think everybody like it. I received some feedback already here in my phone. People saying, "Oh, thank you a lot for this great presentation."
And thank you for having me.
We are very happy to have you here. And Ali, I think now you can announce the next.
Yes, we are getting ready to have the last presentation of the day, followed by a demo, and after that we will have the raffle. So from what I can see on the screen, we already have Michael ready with the presentation on his side.
Yeah, and Michael, just start talking. Before you start, we have two small minutes, less than 2 minutes. Just say hello, just show here for people, and then we can start the presentation, if you can, of course. If you are set up, you can go on.
Yeah, sure. Hello, my name is Michael. Is my audio fine? Can you hear me all right?
Yeah,
Yes.
it's good.
Can we also see your camera?
Yeah, now we can see.
Okay. All right. Then I will go for it. All right. Once again, my name is Michael. Thank you for sticking around for the last talk of today. Good afternoon. Good evening. Today, I'm going to talk about async scripting with Lua and libuv. This talk is really just going to be a series of demos that combine scripting, networking, and event-driven programming for an embedded target. And we'll show these demos in order of increasing capability, usefulness, complexity. There's two general parts. First is blinking an LED in three more complicated, increasingly more complicated ways. And the second part, we'll talk about some networking. For these demos, I'm using an Odroid Go. This is a little handheld gaming platform. It's meant to emulate retro video games, but it has an ESP32 in it, a battery, and an SD card for a permanent file system, and it runs NuttX. For all of these demos, there's no strict hardware dependency. Any platform that NuttX supports will work as long as it has networking support. And I did all this stuff for just a personal project, so it may not be completely production ready. Maybe don't depend on it yet. And one last point, the vast majority of the work I'm going to show is from other people. So credit to the original authors. I'm just kind of stitching things together and see what I can do with them. So to start, first let's talk about what is Lua. Lua is a scripting language. Runs in like a stack-based virtual machine. There's one rule in Lua, and that is everything is a table. Its primary data structure is a table, which is a hash map or a dictionary. For example, arrays are just tables with integer keys. Classes are just tables where the names of members are keys, and member variables and functions are the values. And we'll look at, let's see, Lua is pretty easy to embed in an application. There's a C API for calling from Lua into C, and also from C into Lua. In a little bit, we'll look at extending Lua in NuttX using C modules in order to access hardware. It's also pretty easy to port to a new system. The only strict dependency of Lua is an ANSI libc library, of which NuttX provides a great libc. And I wanted to point out that so many people have ported Lua to NuttX in the past, and many more will in the future. A big shout out to, was it Yurne, who gave a talk earlier today about porting Lua JIT to NuttX, which is a super fast implementation of the Lua 5.1 language standard. I'll just be using vanilla Lua, and as of this year, it's available in the main NuttX apps repo. So it's one kconfig option away from building. So let's fire up my NSH prompt real quick. I'm down here. So what I'm going to do is we can just launch the Lua REPL. So this is built, this is ready to go. And we can do some scripting here. We can do things like hello. Lua supports a module system. So if I look at my file system, I have a file here called hello.lua. Let me give a little reboot quick. Oh, I'm in my Lua interpreter. Okay, so here's my file system. I have a file on my file system called hello.lua. So this one, we create a table called hello. We add a function as a member of this table called say hello, and then we return this table. And this is one of the world's simplest Lua modules. But if I fire my Lua interpreter back up, I can do hello equals require which is the equivalent of Python's import statement. Now I've just imported that table into here, so I can do hello. Call the hello, say hello function. And this is the gist of sharing code in between different Lua modules. It would be great to be able to access some hardware since we're in an embedded system. And we can do that, or I've done that by building a C module that we can include in this Lua environment. NuttX has the user LEDs driver, which exposes the dev/user LEDs character device. You can set and query the state of individual LED using an IO control. Since Lua depends on just ANSI libc, it doesn't know what an IO control is. So we've made a really slim wrapper over the IO control function. This module will receive a file descriptor and the IO control request and any parameters from Lua. It will call the IO control function in C, returning results. And then to expose that to Lua environment, it will go and grab the Lua's file type. And the file type is a giant table of various methods. And so we're going to take our IO control method and then just put it on the end of that table. And then to include this module in our Lua environment, the Lua interpreter in NuttX exposes a Lua module makefile, which works very similar to the NSH app makefile. So you can, if you include this in your modules makefile, it will add it to a list of modules to be included in the Lua environment by default at runtime. Another alternative is you could use the DLL support in NuttX. This does everything statically at compile time. So your module is in the Lua environment, whether you require it or not. All right, so let's look at a Lua script to control some hardware. All right, so let's look at IO control.lua. Okay, so up here we have our dev user LEDs file. We open this with standard IO calls in Lua. Down here we have a big for loop where we first use the IO control method on our LED type, pass in our IO control request, and then some parameters. The second parameter is which LED we want to set. 0 is the first one, and then the second parameter is true or false. True for on, false for off. And then we need a way to block and wait to see our LED change state, and then before we toggle it back. So we're going to use a command in Lua to shell out back to the NSH shell and run a separate process. In this case, we'll run the sleep command, which will block our Lua interpreter for 1 second until it completes. So if we run this. All right, here we go. We got an LED blanket. So let's continue on. All right. Another great feature about Lua are coroutines. So coroutines is a form of async cooperative multitasking. One good thing is that they come built in to Lua. No external libraries are needed to use this behavior. There's a couple of actions you can take on a coroutine. You can yield data from it. You can resume a suspended coroutine and provide parameters to it. Or you could take a coroutine function and you can wrap it and then call it and drive it to completion. So these are roughly equivalent if you're familiar with Python's async support. of the keywords async, await, and asyncio.run to kick off that top level. Next part, they're useful because we can convert some callback driven code into synchronous code that we can just follow the logic top to bottom. And maybe the one thing that would be nice is, the box, Lua doesn't know anything about any async IO. So, to be able to call some hardware and then suspend until you have the result that you need. So the next part that we're going to pull in is a library called libuv. So this is a C library that provides async IO. It uses event loops. It provides some nice features like timers, networking, some file IO, IPC and signaling. It's a relatively battle-tested library. It's used at the core of the Node.js project and the Julia programming language. And even better, someone else has already ported it to NuttX. So this is available in the NuttX app repo. Just like the Lua interpreter, it's one kconfig option away to build. And the last part we need is some way to glue these together. There is a Lua module that is a set of bindings to libuv. It's a C module, and it will build for NuttX without any modifications to the source code because NuttX is a POSIX compliant OS. And all we need is to put a top level makefile in there and include our Lua module makefile to get this into our Lua environment. Just as an aside, I think personally this is what makes NuttX really great, because we have these amazing projects and libraries that already exist, and we can relatively easily and quickly just stitch them together and get a result that is larger than the sum of the parts for an embedded target. So let's look at how to use some of these modules on our board. So first, I have a file called love.lua. All right, this is how we can use the love module. So up here we have our LEDs. We open it in the same way. Next, we have a new type we call LEV new timer. So we create a timer type. We have a little variable I, just a global variable for state tracking. And then we kick off our timer. We start at 1,000 milliseconds of feature. We tell it to repeat every 1,000 milliseconds. And when that timer triggers, it'll call a callback. Here we have a Lua function defined inline, similar to like a Lambda function in Python, where we set the state of our onboard LED, toggle or flip our global variable. And the last line, led.run, is where we kick off the event loop that libuv uses. So let's give this a run. I'll this guy up here. All right. The end result is the same blinking LED at 1 hertz. No change from the user's perspective. But we're not shelling out. We're not blocking the entire Lua interpreter, waiting for the sleep command from NSH to finish. So let's take this callback code and convert it into top to bottom coroutines. So another file here. All right, so I'm going to start in the middle here. We have a new function, coroutine wrap, which will take our coroutine and wrap it into a blocking function. We open our LED, and then here in a for loop, in a synchronous top to bottom for loop, we set the state of our LED, and then we call a function sleep, which is defined up here. And so this is our coroutine that yields. We do something maybe a little bit clever here, where we take the currently running coroutine and we capture it here. We make a new timer for libuv, and we start this timer, and in the callback, we take our captured coroutine and we call resume on it to wake up our sleeping coroutine. And then, before the timer triggers, down here at the bottom, we call coroutine yield to yield from our coroutine. So this function is equivalent to Python's async IO sleep, where we don't block the execution. We just say, hey, I'm not ready to run yet. Try to run me at this time in the future. And then we kick off our event loop down here. So let's run this guy. Cool. Same blinking pattern. All right, let's move on, and then let's talk about networking, because another great thing that libuv brings to Lua is socket support. So we're going to do something. We're going to build like a TCP server, and so these socket methods that libuv and love expose mirror the sort of standard BSD socket methods, where you can create a server socket, you call bind on it, you call listen. Listen will wait until a connection occurs. Then you can create a client socket and then call accept on that connection and then exchange some data. So while we do this in the background, libuv on its event loop is going to use select to wait for our socket to reach the desired state. And then when it does, it will call the callback up to Lua. So first, let's make sure I know the IP address of my board. Then we'll look at our TCP echo application. Up here, we have a helper function called create server. So for a given host and port and a provided on connection method, we'll create our server socket. We'll call bind on it, and then we'll call listen. When listen resolves, we'll have a callback function here defined in line where we create a client socket and then accept the connection with our client socket, and then we'll hand our client socket off to this provided on connection method. And we'll use that function right down here for create server. And then here's our on connection callback, where we take our provided client, and then we'll try to read some data from it, or we'll read a chunk. If we get any data, we'll write it right back to our client socket. And if we don't get any data, we'll close the socket. So let's fire this guy off. Okay, it's listening on a port. I'm going to grab using a terminal up here. So I'm going to grab a terminal, and we'll use netcat to connect to our NuttX board. So where's that port? All right, so we should be connected, and that means anything I write should be echoed back. All right, cool. So same thing as before, we have some callback-driven code here, and we can convert it to synchronous code. We can go one step further and think of a good application that can use sockets. And the first one that comes to mind is an HTTP web server. So just like before, instead of write our own web server, let's pick one from the Lua ecosystem and then just run it on this board. There happens to be a Lua web server called Atlas. The dependencies for the Atlas project are Lua and libuv. So that fits our requirements perfectly. I think we can run it here, and it won't really know it's running on an embedded board versus a desktop computer. So this Atlas web server, it will spawn a coroutine to handle HTTP requests. This is so that we can be waiting on one socket to send us data and still handle sending HTML data back to another client. Instead of just being a web server, it actually has a web framework architecture similar to the Django project on Python, where you have a web app that is separate from the web server. The web app registers controllers for specific routes. A route is like, /index.html or /about or some other page. And a controller is just a function that receives a request table with details about that request and the client who made it. And its job is to return a response table. And that contains either HTML or an HTTP status code, or any other data that you want to send the client. So let's take a look here. I have a directory on my file system called app. It's got one file in it. So let's take a look at our web app. All right, there's a lot here. Let me scoot this guy a little bit over. We're going to go from the bottom up as you take a look. Really the important part is we have a variable here named app that's of type application. It takes routes. Our routes here, we got 3 of them. We're going to have a route for /on. That's going to be handled by controllers on. Off is handled by controllers off. And then our default home route is handled by controllers home. Those are up here. These are just named functions, a different way of declaring a function in Lua. Here we have a function named on. Takes a request and returns a response with the output of this other function, LED true, of type text plain. Similar thing for off, and then home, result of the home function. Our LED function up here has got to look somewhat familiar by now. Here's our LEDs variable where we open. Here's where we set our LED state. Return a little message about the requested state. And then home up here, we gather some information about our Lua environment and the NuttX platform we're running on. And then we generate some HTML on the fly in order to send back. And since we're generating this HTML on the fly, we could do something where we look at specific parameters of our request and generate a different page, different HTML for one client that requests it than a second client and have a bit of more dynamic page. But for now, we're just printing out some stats. Let's look at what we can do to kick this web server off. There is another file called start server.lua. This one is much shorter. What we do is we create a configuration for our web server. In addition to the host and port, we have our web app. And this string right here, little obtuse, but it means look in the app directory for a file called app.lua. Within that file, you'll have a variable named app, and load that. And then down here at the bottom, we have our coroutine wrap, and we have our top level coroutine that calls main.run to kick off this web server. And this is the top level coroutine that all of the child coroutines can yield back to. So let's give this guy a go. All right, and then in this window, let's drag a web browser up and let's see if we can connect to this. All right, so here's our board. Hello from NuttX 10.3. Let's see, we're using just under 100 kilobytes of memory. From I don't have much of a benchmark. This looks all right to me. I heard from the Lua JIT talk that they were seeing about 100 kilobytes for all the Lua scripts they're running, so it doesn't seem we're way off target. This seems all right for a completely scripted web server. And then we have some links to run. So we go to on, we can see our LEDs turned on. And then if I go back here, and then let's go to off. So you can control the state of our LED. All right. And I suppose from a high level, why this might be useful is that we could change the state of our code without having to modify the underlying NuttX OS. In fact, in everything I showed here today, We didn't have to reflash the board. I didn't even have to reboot the board. We ran different Lua scripts with run in different applications. We could fetch new code on the fly. You could have a user copy a new web app onto the SD card of this board. You could go and fetch it from a remote server. We could add a new route to this web app that, or a new controller that handles new route, which accesses some different part of the hardware and has a different effect without having to reboot our base NuttX system. You can modify the Lua environment that you run code in, so you could accept some script from a user and you could remove the I/O module from your Lua environment to prevent them from accessing the file system at all. You could use a different Lua interpreter. Going back to the Lua JIT talk, I haven't been able to try that on my board yet. This is vanilla NuttX, but this same web server I can run on my desktop computer using either Lua or Lua JIT. All of the dependent modules are compatible, so I think we could get a little bit of a nice free speed up by switching interpreters. And I am going to leave it at that for today. Thank you for listening to this talk. You can find links to all of the code that I showed and the different projects. Check out this in some Medium articles that I published, the same talk in blog form. And thank you for sticking around for the end of today. If there's any questions, I'm happy to answer them now.
Thank you very much, Michael. Actually, we have some questions here from Philippe Koval. Could code be used also hosted online and download on boot?
Yeah. Yep. One thing we do is, if not to focus on just this web server, right? But if we had a product that was hosted internal server, when it boots up, it could go make a web request to some remote server and download the latest update. That's just placed a file in the file system, and then run that.
And about it, can use the temp.fs. He's asking, right? The temporary file system to do that. Yeah.
Yeah, you can either use the Lua NSH app that we have here, which is the same Lua REPL that you get if you apt-get install Lua on your desktop computer. It's built for NuttX without any modifications. Or you could start a Lua interpreter from some C code, and you can pass that a string of Lua code instead of reading a file from the file system.
Nice, very very nice. Thank you for that. Let's see if we get more questions about it, Michael. I was looking some comments here. They sent here in the chat, and so I think mostly that is from Koval also comment in JavaScript. In IoT.js JavaScript, with NuttX used on Tizen RT, they used the libtuv instead of libuv. Just some comment. Other question, I guess Lua code can also be compressed, right?
Yes, there's intermediate form of Lua. First, Lua is converted to some Lua bytecode and then interpreted by the VM. So there's a utility for desktop which I haven't built for NuttX yet, but is just the Lua bytecode processor. So you could freeze your Lua code into bytecode and then load the bytecode with the Lua interpreter. And it would save you the first parsing step and also, the code space or the file size of, having text and spaces and comments.
Okay, nice. Other question here from Yannick. Nice presentation. Hope Lua will become more mainstream. Not a question, actually, just a comment. Yes, I also want to see it, and I was comment with early with some people that it's funny because Lua was created here in Brazil, but it's used everywhere except here in Brazil. People don't use it too much here in Brazil. It's a shame because it's a very, very nice programming language and it's very, very useful. I used Lua 2 times for during my during my development, and the first one was in a industrial supervisor system called NuttX. It was an open source supervisor, just like the WinTouch. The guy created the WinTouch, the NuttX, just to create an opposite in open source. It was really nice project, but it didn't last too much, unfortunately. But it was really nice, very powerful. And after that, I did a project using the Lua in the Raspberry Pi, and my experience was not that so good, but I used Lua with the FLTK, the graphic library. They have some binding, but the thing I missed on Lua was more standardized libraries, because when you go to Python, normally when you want to use serial, you know how to use. When you want to use some other features, you know how to use. For Lua, we have many options, and sometimes when you want to use one with other, they are not mixed good together. Yeah, Thiago just comment. Okay, Yannick, you can talk, please, go ahead.
Yes, this is the main reason Lua is more appropriate for embedded than Python, because it comes without batteries. And you can also add things later. You have a lot of libraries at your disposal. If you see in Lua Rocks application. But nevertheless, for the embedded, it is better to be without too many libraries, because otherwise it is blown out of proportions.
Yeah, I agree. I completely agree. I think it should be nice to have some set of libraries developed for embedded application with Lua. Should be really nice.
Yeah, I think Lua is particularly good at gluing together some C libraries and providing a good interface for them. For example, I enjoyed working with the libuv library, and that provides a number of things that are not available in the base Lua. For example, base Lua doesn't even support sockets. So for libuv, you can get sockets, but it's a bit nicer to reason about code using coroutines to run something from top to bottom instead of keeping track of which callback is called when. But as a glue language, I think it works very well.
Yeah.
Yeah, this why I also wanted to introduce LuaJIT, because with the foreign function interface, you can call the socket function from C directly from Lua. So it's even easier to work with the foreign function interface than with the C modules in Lua.
I'm very excited to try that because I realized to control the onboard LED that I would need an I/O controller. I wasn't able to call that from vanilla Lua. But you're right. I think if with Lua JIT, instead of having to write a C module and load it, I think you can call that directly from the foreign function interface of Lua JIT.
Yes, because the project, as I spoke in my presentation, Lua Radio, for example, which is used for the software-defined radio, it is a very good example of doing this from the Lua code. It uses directly the FFT library from FFTv3 library and also libsdr library and calling directly from Lua to speed things up. Even LuaJIT it needs help from C, so it can speed things up if you're calling directly to C libraries.
There's one other great use of Lua, and it's a lot less exciting than using radios, but I've seen some success for using Lua as a configuration file parser. That if you want a configuration file from a user on your product, to specify what Wi-Fi network to connect to and, what to do in a certain situation, and you're deciding between YAML and TOML and a bunch of these other standards. If you have any logic that is in Lua, the table syntax of Lua looks all right as a configuration file to just set a configuration variable, and then if you load that file from Lua, it goes straight into your VM where everything is accessible. If there's any syntax errors, the Lua interpreter will take care of that for you, so you don't have to worry about writing your own file parser. And you can include some user logic, like say, hey, write me a function that I should call on some event, but I'm going to keep you in a sandbox and I'm going to take away any dangerous functions that you might try to call and only give you, a print function for login and a few other utilities. I was inspired by that by seeing how the Lua Rocks utility that fetches like Lua modules for a normal desktop project uses just other Lua files for their configuration files. So there's some behavior that you can override, but they keep the training wheels on, so you can't break their core process.
Thank you, guys. Really nice discussion. We are happy that there have been some really nice follow-up answers.
And go ahead. Now we have the Thiago, right?
Yes, that was.
I would suggest to postpone my presentation before or after the presentation of the audio suggestions by tomorrow, just to stick to the point and not to late the raffle. I don't know. I'm ready to present, but if you think that we could postpone, no problems to me.
Should be fine.
It is up to you. I think we are also almost done here to the the draw, to the ruffles. Just to let just the people know, I finished all the forms, so I am just filtering and remove because some people reply the form two times, so
There are two Alan's connection in here.
Yeah, his connection dropped. Yeah.
Yeah,
Okay.
the connection drops due to the plugin that we need for the broadcast.
Okay. So what do you say?
It's up to you. What you prefer? You prefer to present tomorrow?
I would say that tomorrow, between those presentations, would be better because it's the same subject and then might attract people who wants to know about the auto framework of NuttX. Just for that.
I agree. Also, tomorrow the presentations will be more closely to the NuttX itself and the core different platforms. So I think that it makes a lot of sense if you have time to present tomorrow.
Yes, for me, there is no problem to present tomorrow. I will be here in time.
Okay, perfect.
And you and Alan can rest a little early today.
Yeah.
We are now at almost 10 hours, 40 minutes of streaming.
Yeah, I think here in the Jitsi you can see the time.
The length, yes.
Yeah, the length of the presentation, the event. Okay, guys, I just finished filtering all the names, and so we can do the ruffles, and let me remove here only more two people.
There was a question regarding of Robert. So there are no times for tomorrow's talks. I think it would be one after the other. There's no
yes.
Exactly. It will more fluid, but people will not have the time slot to know. This presentation will start, for example, 11 a.m. There is no fixed option after the first presentation. It depends on how much each presentation will spend in their time, in their length.
Also,
right?
Since tomorrow we have presentations that may spark some discussion, in that case we are not stopping the discussion after, let's say, the 1 hour slot will be done. We will let the discussion continue until the subject is finished, and then we will start the next presentation.
Yeah. So, from my time, I am good. So, to start the ruffles, I will share my screen, and maybe we need to find some way, Alan, to avoid, for example, we have 18 people that reply all the sorry, not 18, because some people use different names. Just a second here, but it's the same person. Okay, now now I think it's finally completely filtered. Yeah. Okay. We have 17 people with the we participate at least of 3 presentations, filling the forms. And so I suggest I share my screen, and I need to
Please remove the email addresses.
Yeah, I'll put just the name. I copy just the complete name, and then let me share here, and maybe you or someone else we do the we run the random.
If we run the random number from another computer, then it will be impossible to show that we ran it. So it's easier if you show the random number.
Yeah.
And then we
Ali,
pick
by the way, I try to present my screen, but it's not showing. Let's see here if I can show entire screen or something like that. No option. Window.
Okay. Do you have the address for the random number generator? Because I can try and run that one on my side.
Yeah.
We get 5 numbers, and then we show the list and who are the winners.
Okay, I'll send you the link so you share this spreadsheet, and then we can run the random. Okay, I just send it in the Discord.
Yes.
Yeah. Alin, are you sharing your screen or not yet? I cannot see.
No, not yet.
Okay. Robert Lip, just to reply your comment, this kind of thing we need to be completely clear to other people, so we cannot just this is the random number. We need to choose some sites to do that, and you need to show the value.
Yeah, it is completely random. So the minimum number is 1, the maximum number is 17, and the result is 15. Please note the numbers.
15 is, let's see, the Robert Leap itself. Nice.
Perfect. Second row, number 10.
Alin, maybe if you can open that spreadsheet is better, because people need to see what
idea. So number 15.
Yeah.
Okay. Number 10.
Lorival, congratulations.
Yes, congratulations. The third one will be number 16. Philip Corval. No, 16. Roberto Butcher.
Nice. Congratulations, Roberto.
Congratulations. Number 8. Number 8 is Yerney.
Congratulations, Yerney.
Thank you.
Number 6.
Eric Ferdinando.
Congratulations,
Eric.
Congratulations, guys. If you are located in one of the countries that are allowed to receive this Presence LTE board, we will send it as soon as possible. For the others, we will have another draw tomorrow after the event, and you can still win one of the other five boards.
Yeah.
Thank you for participating to this lucky draw.
Okay, thank you guys. And so now it's time to relax and talk on a little bit with our speakers and our guests that are here waiting for us. So guys, we still have here Ken, Yannick, Greg, Thiago, and Felipe, and also people in the chat. Roberto, congratulations.
Maybe it would be nice to ask everybody to start their cameras to take the last picture of the day.
Yeah, good idea.
Like we did every year. Ken is smiling.
It's only 2 p.m. here. It's not the middle of the night, so.
Philip, can you join us? Nice.
Let's see, and print screen.
Masayuki-san this time didn't last. But he can join us tomorrow again.
Yeah, tomorrow you can take more pictures.
Yes. Thank you, guys.
Congratulations, guys. It was very tough to do it again, but we need to do it to show to other people. We want to how we like NuttX. So it's good to have all you every year here. And as I told to Alan, we need to do it many more times.
I agree.
Yeah,
so let's hope that the others also agree, and we will have more and more speakers.
Yeah, and Yuka, I just see him in the chat. Please enter here in the. Aline again.
Thank you, guys. It's getting quite late here in Slovenia, so.
I suppose. I think it's very late for many.
See you tomorrow. Bye.
Bye.
Bye. Thank you, and too fast. Hello.
Hello.
Take the print screen. Hello. How are you doing?
I decided to join for a second. So good.
Nice.
So excited to be here and talking tomorrow.
Yeah, we are looking forward to your presentation tomorrow about the PolarFire, about the microchip PolarFire MPFS architecture. Yeah, it's really nice. So guys, now we are almost done, and tomorrow we need to do all this again, but tomorrow it will be more fluid. So I think maybe we will finish at least 3 or 4 hours early than today. Let's see.
I think that you're too optimistic. I'm hoping that it will be 2.
Yeah.
That there may be. I hope to spark some interesting discussion tomorrow. So yeah, let's see.
Many. Yeah, tomorrow we still have many interesting presentations. Yeah.
Thank you for today, guys. It was an awesome day, the first day of the event, with many interesting talks. We had 10 interesting presentations, plus Philippe, which showed us a short demo, extremely interesting. If you haven't seen it live, you can watch it on YouTube. Thank you, Philippe, for joining us. And we hope that next year you will submit a full talk.
Yeah, maybe using Luz with the web things. By the way, Philippe, what is this?
I don't have any choice now.
What is this oscilloscope behind you, or not oscilloscope?
Yeah.
It's like an old school oscilloscope, or is not an oscilloscope? Just behind you.
It's an oscilloscope. It's an old oscilloscope. It's running, but I figure it out. I miss the probes connector, so I will make use of it. And something interesting is that you can play Space Invaders, with this oscilloscope. There is a Easter egg in the firmware, and if you press a specific key shroud, you can access the game.
Okay.
Nice.
Yeah. And probably it's running RTOS.
Yeah. I think it's a little bit old than NuttX, so maybe it's not NuttX, right?
We can try to port to this hardware.
It's a good idea. And Ken, about your project, I don't know if you can talk a little bit. We have only 5 minutes to finish.
Yeah, sure. So this year I've been involved into a project called Oniro, which is also an operating system, but not a kernel by itself. It's more like a set of tools and different middleware to target all range of IoT devices. So we are targeting high-end devices like the one you can run on big high-end CPU or just your regular computer, and also on a very low-end device like microcontrollers. So there is some goal in this project to unify the way of building firmwares, and it's tied to existing open source projects. So for big computers, we are using Linux, and for microcontroller, we are using Zephyr currently. But there is also open to support others. For instance, there have been some effort to support FreeRTOS and LightOS, and I suggested, if I'm not mistaken, that we could add NuttX support too. We just need to add bitbake classes, so it's Python script to build a foreign to use a foreign build system. And since NuttX is Makefile based, it shouldn't be too difficult. But I didn't explore this.
Nice. And Ken Petit, about your project with Linux and also NuttX as a slave, it is also used for some industrial application.
That application actually, we've got a high speed 48 gigasample per second A to D and 48 gigasample per second DAC, which I don't know how many people here know about ADC or DAC speeds. That's actually fairly high speed for a CMOS. And then we use we have a RISC-V core, actually a dual core RISC-V inside the chip. It's all 12 nanometer. We're moving to 5 nanometer, but it's basically right now that application is a government application, and it's used phased array radar. So they'll put
military application, I suppose, like the previous project, right?
Yeah, it's for a high end radar. So they'll send out chirps, from a radar, high energy. They'll look at the data coming back, and identify targets out in the world basically, and then also used for communications.
Nice. And Yuka, Leighton, your project is with current project is if drone is correct?
Is what?
Yes, that's correct. Yeah.
Nice.
So the project is about bringing more security and safety into drones, basically. So
Nice.
we are building a autonomous drone system and securing that, or building it from the security in mind. So that's the project all about.
Nice. And so I hope we see more information about it tomorrow, because yes, drone and security is very important, because you see now what's happening in Ukraine and Russia. If your drone is not so well protected, they can be hacked and used by the other
Yeah.
country.
It's funny, actually. One of our customers is looking at using our chip to build a drone killer for the government. So
crazy.
A drone that shoots down other drones. So yeah, for warfare.
Yeah. You have the war of drones. Now you have the war of drones.
That's right. That's right.
You read my mind.
Yeah, I think everybody thought this joke. Okay, so guys, I want to thank you, all of people in the YouTube watching, and thank you very much. As Aline said, it's very hard to be here. It's very difficult to do this project, to this workshop, but we like it too much. And also, Greg, thank you for joining us. And I hope you see your Pascal virtual machine working on NuttX. Maybe, I don't know, if you have some time tomorrow to do some quick demo, should be nice, right, guys?
Of course.
Yeah, so
we would like to see.
Yeah, but I don't want to push you, Greg.
We could barely hear.
Yeah, Greg,
we cannot understand.
Your microphone is saturated.
Greg, it sounds like you're on a mission.
Your microphone is saturated.
Can't get the camera to on.
Yeah, let's bring it. Maybe no, it's a little bit different to listen, Greg. I think the sound. Yeah, maybe the. Yeah. Yeah, good idea. Maybe. Yeah, maybe. Yeah, now they use. No.
We can see you, but we cannot hear what you're saying.
Yeah.
Can you hear me?
Yes.
Greg, please repeat. No. When you start, yeah, when you start to, it is saturated. Yeah. Greg, Philip suggests you to type in the chat here.
I think that he cannot hear us.
Yeah.
I can hear you, but you're breaking up. I can hear you, but I can't understand you.
Yeah. Maybe the internet is with some issue.
Yeah, it feels like after we speak, he gets a feedback that is very distorted.
Maybe that's better. I can reduce some internet usage. Give me a question. I don't understand what the question was.
Alan, please type the question.
Okay, I just put it.
Did you post it on YouTube?
YouTube. I can put here as well.
Okay, so I don't have any hardware set up right now to demonstrate anything.
Okay, go on. Don't worry. Okay, I prepared. Greg, yeah, the audio is returning.
Muted Greg.
Yeah, we need to ask to mute. Yeah.
Yeah, he's muted now. Sorry, Greg.
Sorry. And okay, guys, I think we are done for today. God bless. Okay, guys. So thank you all of you, and we are looking to see all you tomorrow, right? Thank you, guys. Thank you, Greg.
I think everything's working now.
Thank you.
Thank you.
See you tomorrow.
Bye-bye.
Bye-bye, guys.
See you tomorrow.
Bye-bye.
Thank you for joining us today.